Good stuff, everybody. I appreciate you being here. I appreciate all of you being here. I know that there's a lot of things you could be doing right now, but you chose to hang out with us online. That's wonderful. My name is Josh Long. I'm so happy to be with you, even though it's virtual. I wish we could be together. I wish we could hang out and drink a rakia and, eat wonderful food and so on, but this is okay. I'm glad we can do this. I was told to turn off the camera. That's right. I got to turn that off before we get going. Okay. So let's get started. My name is Josh Long. I work on the Spring team. I'm a Spring developer advocate. I'm a Kotlin Google developer expert and a Java champion. And I spend all my time trying to help people build better software with Java and the ambient technologies around it. And today we're going to talk about a lot of these different things. And we're going to cover a lot of stuff. And that stuff is going to be covered in this Git repository. So keep note of this Git repository. It has the code. It has everything that you're going to need to follow along at your own discretion. We have maybe 90 minutes, a little bit less, so we have a lot to cover and very little time in which to do it. So I encourage you to take a screenshot of this one slide. And of course, you'll find my coordinates. So if you have questions, when you have questions, please reach out to me. I'm on Twitter and I'm on email. I'm happy to engage. I'm happy to talk. And I want to thank you for your time, obviously. A little bit about me. I work on the Spring team. I have, as part of what I used to do, of course, it's a different world now, isn't it? But as part of what I used to do, I traveled a fair bit, and I used to go to Bulgaria, and it was wonderful. I had so many visits with Java2Days over many years, and I miss it, So maybe next year, hopefully, fingers crossed, maybe next year or the year after, we'll be able to reunite again, As part of what I've done, I have training videos. These are on Safari on different topics. I have a book that I wrote in 2017 called Cloud Native Java, which is all about how to build applications using Spring Boot and Spring Cloud and Cloud Foundry. I have a podcast that I do every Friday. This is the podcast where I talk to interesting people in the Java ecosystem. So recently we had Dion Almer, we had Dr. Heinz Kabutz, we have just lots of different amazing people in the Java and Spring ecosystems. I have a blog I do every Tuesday called This Week in Spring, which is a recap of all the news that fits a reprint in the Spring ecosystem. And of course, I have a screencast series that I do every Wednesday called Spring Tips, which is just me looking at corners of the ecosystem together. Excuse me, I've got a bit of a cold. Some things should not be open source. My cold is one of those things. So that's good. I have a new book called Reactive Spring, and this book is the stuff that we're going to talk about, really, if you think about it. So maybe you don't need to buy the book. Maybe we'll just talk about it right now, and you won't need to buy this book. The whole thing that we're going to talk about is reactive programming. But before we can do that, before we can have a discussion about reactive programming, we need to consider why we care about reactive programming, what motivates its use. And reactive programming is not a new thing, obviously. So let's talk about the big picture before we dive into the details. What motivates this need, right? Why are people caring about reactive programming now and instead of like 40 years ago, for example, right? And I think it's not hard to think of problems that have sort of only become very, very serious in the last, let's say, 10 years. Right? 15 years at most. And so what motivates the use of reactive programming? Well, I think if you look around, it's not hard to identify problems related to our ability as human beings to go faster. How can we deliver software faster into production? And this is something that causes a lot of trouble for a lot of different organizations. They know that they need to go faster. They look at their process and they understand that there are different pools of activity in the organization. And when it comes to the developers, we try to go fast. We try and do sustainable, repeated delivery, but it's not always easy, is it? And so we look for ways to go quick, right? What can we do to go quickly, to more safely and quickly move software into production? Obviously, lots of different things that we could do. Okay, never mind. A lot of things that we could do to go faster, but a lot of organizations, they look at their code bases and they realize that these code bases are large. They're large, big code bases with lots of people working on them, and this causes a problem because all that coordination that's required to deliver that software into production slows people down. And so they look for ways to shrink the size of the code base. They break it apart. They decompose the monolithic application into small pieces. And the smaller the piece, the fewer the people that are required to maintain it, to evolve it, to sustain it, to develop it, etc. And this allows for some very interesting things. It allows for small teams that are focused on one thing. So they don't have to do work for other parts of the organization. They're all focused on one feature, as opposed to, this is different from having people that are in different groups. You have IT, you have, ops, you have developers. Instead of doing that, you say, these people are working on the order service, and these people are working on the fulfillment service, etc. So now you have people that are grouped by their feature instead of by their role. These people are not doing work for any other team, so they don't have any wait time. There's no lead time or delay between action. This allows them to go faster and allows them to move independent of the other parts of the organization. Autonomy is very important here. Autonomy is how quickly can I move independent of the rest of the organization. So now we've got small code bases. We've got people that are focused on delivering software quickly, and we need to find a way to break apart our monolith, right? Well, of course, we can look for the bounded context. The bounded context is a part of the amazing book by Eric Evans called Domain-Driven Design. It describes a part of the domain model that stands by itself without any other dependencies. So this is a very, very useful pattern when you are looking for ways to describe these small, singly focused services. So now we have lots of small, singly focused services. These services are bounded contexts, and they have to be deployable. You have to be able to deploy them without the other services, right? They don't need or depend on other services. This is very important because now I can work on my team, and my team can deploy software without waiting for other teams. Well, once we've done this, now we have separated the modules, we've separated the bounded contexts, and they're no longer in the same code base or in the same deployable artifact. They're now communicating over the network. And here's where we get into trouble, because as soon as you build a distributed system, you have complexity that you have to deal with. That complexity is where we are going to find some pain, right? That complexity is, it's not trivial, but thankfully, there are good tools and good frameworks that you can use to address that complexity. And if you understand that you are going to have more complexity when you build microservices, if you understand that you're going to have more complexity when you build distributed systems, then you can get the benefits out of it. You can say, okay, look, I know that there's more complexity, but this move will allow me to move software into production faster and to learn from the feedback cycle of that deployment. I can see the change in production, and I can benefit from that, and I can respond to change in production. That's a wonderful thing, even if there is some complexity. So the question is, what can we do to minimize that complexity? Well, consider when we build services, there are patterns that start to become obvious, patterns that become important as you start to create more services. So today we'll talk about some of those. These are cloud native patterns. And then there's also what we can do at a service level and at the API level to make our life easier. Consider that there are 3 big pain points that we only start to see really at scale. The first point is, how resource efficient are our services? Are the services that we're building wasting precious resources on the computer? That's the first problem. And one of those problems, of course, is that it becomes very clear is the JVM's ability to create more threads, right? And even if you have lots of threads, right? So in hopefully a year, in a year, hopefully, we'll have Project Loom. Project Loom will give us green threads, right? Lightweight green threads. This is wonderful, right? Project Loom is going to make it so that we can create a lot more threads. But even there, if you try and do input and output, you're using buffered input streams and output streams. Each one of these keeps byte array, a byte buffer in memory. So now you've got, 1 million threads. You've got now 1 million extra input streams and output streams, each of which has a buffer, that adds up, right? Several kilobytes per input stream, output stream combination. And so you have to be more resource efficient, even in this new world. That's the first thing. The second thing is I want code that makes it easier to compose, right? Because when I move to a distributed systems world, I've got data coming from databases, from message queues, from web services, all these different things, all these different places, and they all look and feel very different. But I want some sort of programming model that lets me talk about all the different kinds of data, right? I've got data that is immediate. I have data that will take a long time. I have data that is small. I have data that is large or maybe even infinite, right? All these different kinds of data streams. They're all important to me, but right now I have 10 different APIs to describe them. I want a consistent, uniform API. And then finally, the third thing that I care about is I want resilience. I want the ability to, when I make a network call, do the right thing if there are failures. I want to be able to make it easy to add robustness to my code. So reactive programming gives me all three of these things, and it does this all right now. And the benefit is that we can take advantage of this, and this will continue to help us in the future, obviously, because as we scale out, this will become even more relevant. So we're going to talk about reactive programming. Now, reactive programming is it's an idea, right? It's not a particular technology. We're going to talk about reactive programming and the reactive streams APIs. And we're going to talk about a project called Project Reactor, which builds on the reactive streams API. And we're going to talk about Spring, of course. But reactive programming itself is a very simple idea, okay? And it's an idea that gives us an answer to those three concerns: resource efficiency, reliability, and uniformity, right? Ease of composition. So let's take a look at all that. Now that we kind of understand the goal, let's go ahead and see how we can get all that. And of course, to do this, we're going to go to my second favorite place on the internet. Obviously, my first favorite place on the internet is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. It is better than Disneyland. But if you have not been to production, you can begin your journey here at start.spring.io. And what we're going to do is we're going to build a new service called the customers service. And we're going to use Maven is fine. You can use Maven or Gradle. Either one is great. Language, Java, Kotlin, Groovy, all of them are great choices. We're going to use the latest and greatest version of Spring Boot. I'm happy with that. We have the choice of packaging. Obviously, leave the default, make jar, not war, obviously. But then we have the choice of what version of Java we'd like to use. And friends, we have three choices down here. We have Java's 15, 11, and 8. Three choices, but really only two choices. You see, one of these choices is a choice that you could make, but that you should not make. This choice, Java 8, is a non-choice. It's a choice that you could, but you should never, ever select. Java 15 is the current supported version of Java. Java 11 is the current long-term supported version of Java. These are both acceptable choices. Java 8 is, however, technically inferior in every way. It has less features, less syntax, less security, less performance, less robustness, less cloud awareness. It's just a terrible choice in 2020. No, almost 2021, my friends. We're a couple of weeks away from a brand new year at most. Less than 2 weeks, and we'll be in 2021. And so you should avoid Java 8 at all costs. Very bad choice. It's also morally the inferior choice. It's morally inferior in every way. Imagine, my friends, the look of sadness and despair on your children's faces when they find out that you're using Java 8 in production. Don't do this, my friends. Be the change that you want to see. Do the right thing. Use Java 11 or later, okay? So I'm going to use Java 11. That's just fine. I'm happy with that. And then we're going to add some dependencies. We're going to bring in the config client for centralized configuration. We're going to use the reactive web support. We're going to use R2DBC. R2DBC is a relational reactive database connectivity abstraction. We're going to use an H2 database, which is an in-memory embedded SQL database that we'll use to store all of our database code records. We're going to bring in the Spring Boot actuator. We're going to bring in Lombok. Lombok's a compile time annotation processor. And I think I'm happy with my selections here. Lombok, actuator, H2, reactive web, config client. Oh, you know what else I want to bring in? I want to bring in the RabbitMQ support here. AMQP, et voila. Okay, so there's my different dependencies. There's my different libraries, my different jars. And I'm going to go ahead and hit generate. Okay, so I'm happy with this. Let's go ahead and open it up. And we'll open this up here. Okay. Downloads. UAO customers at this. So I'm just going to open this up in my IDE. It doesn't matter what IDE you use. Anything is just fine, my friends, so long as the IDE supports Java 11 or later, and so long as it supports Maven or Gradle. So Visual Studio Code is a good choice. A lot of people seem to be really happy with that. I like it quite a bit. Later, thank you. Visual Studio Code, of course, uses this concept of a language server. A language server is a process. It's a process that's written in whatever language you want that speaks a particular protocol. And the IDE, the IDE like Visual Studio Code or the Spring Tool Suite or Atom or Emacs, they can all speak this protocol to these language services. Okay, and those language servers understand how to analyze and work with particular kinds of code bases. So you might have a language server written in Go for Go code, one in Java for Java code, one in C# for .NET, and so on. But it doesn't matter because they all speak the same protocol. And so you can reuse these plugins across different IDEs. And so we worked on the Spring support for Eclipse with the Spring Tool Suite, and then we contributed that to Visual Studio Code as well. So there's a lot of really interesting opportunities here. Anything works just fine. You can also use IntelliJ, the Community Edition or the Ultimate Edition. Either one's fine. So here's my application.
Hey Josh.
Yes.
Can you please increase the font size in your editor?
Don't worry. I would do this. Okay. So we have now a public static void main Maven application, and we're going to go to our build and we're going to comment out some of the dependencies that we don't need for the moment. Okay, so let's get rid of the Spring Boot starter AMQP. Put that here, and we'll get rid of this. Get rid of that. So that leaves us with Actuator, WebFlux, R2DBC, and our R2DBC implementation for H2. So R2DBC is a set of interfaces that we on the Spring team developed, and then we donated to the Reactive Foundation. So it's now an open thing that people contribute to, of course, and we have a number of different vendors that have already taken charge or control of the implementations for their particular database. So, for example, the Postgres R2DBC driver is being developed by the Postgres team, and there's R2DBC databases for database drivers for Microsoft SQL Server, Oracle, H2, MySQL, MariaDB, SAP HANA, Google Cloud Spanner, Azure Cosmos DB, everything, right? Just all the big ones are there, I think, and so check it out. But I'm going to use in-memory H2. Okay, so there's my build. There's my application. Let's go ahead and build an application that talks to the database. So I'm going to build an application that manages data of type customer, private integer ID, private string name. I'm going to have ID as the primary key there. We'll use data at all-x constructor, no-x constructor. So there's my basic object, right? And there's my private ID. And then I want to save instances of this type into the database. So I'll create a repository, handles the boring read, write, update, and delete lifecycle management methods, right? So I'll use this custom repository. This will be provided by Spring. I don't have to implement anything, but it has methods that are very useful. Methods like save, find, count, delete, etc. What is most interesting to me, of course, are the parameter types and the return values. The first parameter type that you'll see a lot in reactive programming is org reactive streams publisher. Now, org reactive streams publisher is a type that produces data asynchronously to a subscriber. It broadcasts or emits or publishes this data asynchronously to a subscriber. When the subscriber first subscribes to the org reactive streams publisher, it is given a subscription. And this is very important. We'll come back to the subscription in a second. When the publisher sends new records to the subscriber, they are delivered through the onNext method. When there are errors to deliver to the subscriber, they are delivered through the onError method. And finally, when the subscriber has processed all the data that it is going to be given, that is signaled here through the onComplete method. Now, the unsubscribe method is super important because it's in that method that the subscriber is given a subscription. This subscription is what the subscriber uses to ask for more data. You say, the subscriber can say, I want to request 5 more records, please, or 100 more records, or whatever. So the subscriber can request as much as it wants. If it says -1, then the publisher will give it everything it has as fast as it can. But it's important that if you say I request only 10 records, then the publisher will never give you more than 10 records. You might get 10 records, maybe 1 record a week, or maybe 1 record every nanosecond, right? You don't know. There's nothing in the prescription there. Either way, the guarantee is that you won't be given more than you can handle, more than you have asked for, right? And if you're just tired of the data and you don't want to deal with it anymore, you can also cancel, right? You can say cancel. So this has the effect of giving the subscriber, the thing that's actually processing the data, giving that subscriber a chance to control the speed at which it consumes data. This is so very important because it means that the subscriber cannot be overwhelmed, right, by anybody besides itself. The subscriber decides how quickly it should worry about the data. That's very important, very, very important. This is important at the big systems level, right? This is why people use message queues, for example, so that when one side sends too much data to the other side, the extra data gets stored in the message broker, in the message queue. It helps create more robust, more resilient systems. The subscriber can also, the other place where this is very important is also at the protocol level, right? The network protocols that you use all have a state machine that's designed to describe what happens when one side goes faster than the other, right? It's called flow control, and this is a very simple concept. The message broker helps you with flow control. The protocols, they have the state machine to deal with protocols. Flow control is very, very important. And sometimes in the world of reactive programming, we talk about flow control or back pressure, right? So when you hear the term back pressure, that's just another way to say flow control. And all that we have done is we have taken this idea of flow control and put it in this interface. That's all. That's the big important piece here, is this reactive streams type there, okay? So reactive APIs build on these reactive streams types that I just showed you from publisher and subscriber and subscription, but they're very basic. They're very basic. They're so basic, actually, that those types are also in the Java JDK. So Java util concurrent flow dot processor dot subscription dot subscriber dot publisher. So these are the exact same types in the JDK, and you can convert from one to the other using the Java adapters class, right? So flow adapters, rather, using this, right? And this is in the org reactive streams type package, right? So flow adapters, this will convert between reactive streams APIs and Java 9 flow API. The Java 9 flow API came after the org reactive streams one, right? So this is compatible with Java 8, whereas this assumes Java 9. But you, of course, are using Java 11, right? So, right? Right, let's just say yes. So the point is, now we have these reactive types, but they are very basic. They're very basic, and they don't give us a lot of support for data flow composition, for analysis, for processing, for all these kinds of operations that people want to do on streams of data. So we have another project that you should know about called Reactor. Project Reactor is a project that was developed by the Spring team as well, and it is designed to support reactive stream APIs, the same ones that we just looked at, but it provides 2 specialized types. The first is mono. A mono is a thing that produces at most 1 value, and there's a lot of operators. Look at all those operators. My goodness, so many operators. These operators support things like map and flat map and filter, useful things that you might be familiar with if you've done any kind of functional programming, right? Like, for example, using the Java 8 Streams API. We also have Flux. Flux is another specialization, also from Reactor Core, and a Flux is a thing that publishes more, 0, 1, 2, 5, 10, 1,000, etc. It could be unlimited, right? So Flex is a publisher. Mono is a publisher. Mono only produces at most one value. So it's like a completable future, but with back pressure. A Flux supports as many values as you want. So it's kind of like a Java 8 Streams API, but with back pressure, right? So the nice thing about this is that this is all just in the interface here. And you can see the return values are monos and fluxes, but the accepted input types are the basic interface of publisher. So you can accept publishers from different projects. And there's lots of different reactive streams implementations. You can use Akka streams, you can use RxJava, you can use Vertex. I mean, you can use Spring with these other technologies because they all understand reactive streams. Okay, so now I've got my repository, and what I want to do is I want to save some data into the database. So I'm going to create a bean that's going to listen for an event. And when this event occurs, we'll then write some data to the database, and we're going to do so using the customer repository that we created here. And we also want to initialize our database. So I'm going to create a database client, DBC, and we'll use that to initialize the database. Okay, so here's what we're going to do. We're going to say that, first of all, we want to initialize the database schema because remember, it's embedded. So we'll say create table, customer, ID, serial, primary key, not null. Okay. Actually, that's fine. And then name var car 255, not null. Okay. So there's that. And then I'm going to fetch and I'm going to do rows updated. So there's my mono of integer. That's the first we've got Stefan. Okay, we've got Yushin. We've got Dr. Sire and me. I'm on their Spring team too, right? So there's some names. Okay. Now the problem is that most reactive type. And so you use flat map, right? You flatten the curve and you flat map, okay? So let's see, this is step 1 right here, step 2, and then step 3, I want to get the data. I want to say customer repository dot find all. There we go. There's all the data. Okay. So now I want to take all that data and I want to run it. Now, nothing will run right now. If I run this code right now, nothing will happen. You need to activate it, right? What we have done is we have described a pipeline. Water will flow through the pipeline, but we have not turned on the faucet. In order to do that, you must say ddl.subscribe, right? Like this. But of course, the problem is that when you subscribe, there's no guarantee that that will execute on the same thread as the caller, right? So if I say names.subscribe and then I say all.subscribe, well, we don't know when this will finish. It might finish after this is finished, right? Because subscribe will run on a different thread. The work will be done on a different thread. So I need to force DDL to happen before names, and that has to happen before all. So I'll say DDL.thenMany names, and I'll say then many, all, and then finally, I'm going to subscribe to the whole thing to print out each new record that's been written there, right? So I'm just running these things in a sequence like this. So let's see what that looks like. Let's run this and see what we get. ID serial. Let's see here. What did I do? First of all, did I import this correctly? And then second of all, create table customer ID serial primary key name. Oh, huh. Okay. Recompiling. Okay, there we go. There's our 8 records in the database. It's working. Okay, good. So now the next thing I want is I want to create an HTTP endpoint, right? So I'll say that, well, actually, you know what? We can do it this way. We can create a Spring MVC style REST controller, class customer REST controller, right? Private final customer repository. And I'll inject this into the constructor. And we're just going to create an endpoint here called customers. Okay, publisher of customer get. Find all, and voila. Okay, there's my customer repository. And I'm going to go ahead and restart this. So save, restart, recompile, good, localhost 8080 / customers. And there's our data. So it's working. So good. We have now an application with HTTP data. We have, SQL data. We have our records. It's fine. I think we're ready to go to production. What do we have to care about when we go to production? Well, of course, there's a lot of concerns when you go to production. First of all, I want to make sure that my application is observable. And so I'm going to use the Spring Boot actuator to include all these endpoints that give information about the state of my service. I'm also going to deploy to a Kubernetes cluster probably, right? So I want to make sure that my application is ready to support integration with the Kubernetes platform. So we have these health liveness and health readiness probes that we can enable. So I'm turning those on as well. So let's go ahead and run this and see what we get for that. Okay, now the actuator are a set of managed HTTP endpoints that give you information like the metrics, the health, the uptime, thread dump, lots of information about your application that you can use to understand how the application is doing. So you can see here that I've got a health endpoint and it's got 2 probes. Liveness tells Kubernetes whether the service is still alive, right? Readiness tells Kubernetes whether, when the application starts up, whether it is ready to be put into the load balancer and start receiving traffic. And you can change this, of course, right? You can actually change the endpoints. So let's say I create another endpoint here, REST controller class down REST controller, right? And what I'm going to do is I'm going to inject the application context, okay? And I'm going to create an endpoint here, post mapping down, mono avoid down. And I want to publish an event. I want to publish an event in the application context to other components in the context that are listening for it. So here, I'm going to publish an event to tell the Spring application context that something is wrong, and therefore it should change this liveness probe to be down, right? So liveness, okay? And so you can do this by saying availability change event dot publish. And we put the liveness state broken, okay? So I'm just going to publish this event like so. Okay, let's run this again. Actually, just to make my life go a little faster, it's not very restful. Okay, it's not restful, but that'll be quicker so I don't have to use curl. Okay, so go to this endpoint, everything's fine. We go here, Now it goes down, right? I use that event to force this to go down. So what happens when it goes down? Well, you're going to have the heartbeat probe from Kubernetes. It's going to check by default every 1 second on these configured, heartbeat, the liveness and readiness probes. And when it sees that the service is down, it's going to take the service and it's going to kill the container and create a new one, right? But you can tell it that you want to have the container container destroyed after it's been taken out of the load balancer. So you have some time. That time is very useful because just because it's no longer in the load balancer doesn't mean that the pod itself should be destroyed. So you can take it out of the load balancer and then let the existing transactions, the online requests, you can let those finish, and then the platform will put a different instance into the load balancer in the meantime, right? So this is very useful. You have, by default, I think it's like 30 seconds, right? So you can actually enable this graceful shutdown feature in Spring Boot as well. You can tell Spring Boot that I want my shutdown to be not immediate, but graceful. That way, it'll stop accepting new traffic, but it can finish any existing requests and send back, finish anything that's in flight. And we can specify how long it should be, right? We can say that we want it to be 30 seconds. Okay, so this graceful shutdown thing is very useful for that. Now, what else will happen then, right? The service will go down. It'll no longer be in the cluster, and then another instance will be spun up. So already we've got a lot of things that are included out of the box to make it easy to do the right thing with the platform. But now, how do we get to the platform, right? This is the next thing that most of us are going to think about. And so one option is to use something called a build pack, right? We need to take our application and turn it into a build, into a container, right? And so we can use build packs. Build packs solve one of the hardest, biggest, painful problems in the cloud native world, right? Which is Docker files. The first most painful thing in the cloud native world is, of course, YAML. I hate YAML. This is one of my favorite cartoons about YAML from my friend Arun Gupta. I think we can do better. YAML is the reason that people leave IT. Not a big fan. So we can do better. Now, Docker files, that's another big pain point. And so Paketo build packs help you solve that, right? They help you get rid of them because what they do is they take the application artifact and they turn it into a container. So you give it a Java jar, a Spring Boot jar, for example, and it'll download a JDK and create a file system and create the right memory configuration and then create a container for that. If you use Go or PHP or .NET or Ruby on Rails or Python or whatever, there's dozens or hundreds of build packs out there. It'll do the same thing for those languages as well. And so you can actually use a command line tool called pack. You can say pack space build space period, and then it'll take the code, if it's a Python program or JavaScript or whatever, and turn it into a container for you, and you can deploy that. So that's very useful, but we don't even have to use this because we have, this is already built into Spring Boot by default. You don't have to actually do anything special. So I can go down here, Maven Spring Boot : build -image, right? And what that'll do is it'll run, it's gonna take my application and turn it into a container, which I can then Docker tag and then Docker push to my container registry, right? And you can use VMware Harbor, you can use Google Container Registry, you can use Docker Hub, all these different things, right? It doesn't matter what you use. And the nice thing is that because we have a specific version of the Maven build plugin, we have a very specific version configured of the build pack. If you use the same code in the same build pack, you get the same exact container over and over. And of course, you can change these things. You can evolve them, you can upgrade them, but it's nice to know that you get consistent results, reproducible results, right? So you can see it's downloading the Liberica JDK there and setting up everything, and it realizes that this is a web application, and so it's just adding all these kinds of things to the different layers and creating an environment with the different things that we need, and there it is, right? So there's the entire container. Took a minute to do that. Docker run, and there's my application. And of course, it's running inside of an in-memory database. It's got a database that we start up when the application starts up. So there's our application data, right? So that's good. So the container's working. The thing is, I want this to go faster, right? I want this to be, I want this to take as little memory as possible at runtime, and I want it to start up quicker because time is money, right? So one option that we can use is to use GraalVM. GraalVM has support for native images. The idea behind native images is that it's a closed world approach to compiling applications. Basically, we take Java and we shake away all the fun stuff, so all the dynamic behavior, runtime reflection, class loading, proxies, resource loading from jars, all that stuff, throw it away. But if you can do that, if you can identify all that, GraalVM can help you fake it. You can pretend that you've got these things so that your code will still work. That's one option. And then, of course, if you do this, then you get a native image. You get an actual application that is a machine architecture specific binary that runs only on, let's say, Linux or Mac or whatever. And this is okay because in the cloud, everything is Linux anyway, right? And so I like native image support. And you can easily do this with a project called Spring GraalVM. But we need to set up a few things. First of all, we change our code here. We have to do that, right? And then we have to configure a few things in our build. And I've done this already here. You can look at the example for reference, right? And this example, I go here. I'm using Spring Boot 2.41. I'm going to use the Spring GraalVM native dependency there. This is not yet GA, but we can. We would love to have your feedback, of course. And we paste this in here. Okay, so Spring GraalVM native. And then we go down and we go to our build, and we're going to configure the Maven build plugin to change the default container that gets created. Instead of creating a container with the JVM, we're going to create a native image container. Okay, so we go here, and you can see we're going to use a Paketo build pack called Tiny, and that's going to use build pack boot native image, right? So once we have these things configured, I think that's it. I think that's all we have to do. Then we can just run the build. Now this will take a little while, okay? This actually takes a long time. It's not fast. So this is one of those things where you'll probably end up doing it in your CI environment or something like this. So we're gonna go ahead and let that run. And then in the meantime, I wanna build another service, okay? This might take like 5-10 minutes. I don't know, it takes forever. So we're gonna go ahead and create another service. We'll go back to start.spring.io. And here, we're going to create a new service, not called customers, but called orders. So in this case, this is a different bounded context, because even if you have a customer account or a customer record and you delete the data, you will still keep the order service and all the order data because you need to care about it for revenue recognition and that kind of stuff. So we're going to create a new service, and this one will not use HTTP. Instead, we're going to use RSocket. RSocket is a reactive protocol that is natively reactive on the wire. It was developed by the engineers at Facebook and Netflix, and it is designed to get around some of the many limitations of HTTP2 and gRPC and so on. It is flexible in that it supports true bidirectional communication. It's not just request response. It also supports fire and forget and streaming and so on in both directions, of course. It is rich in that it supports things like observability. It has a message frame designed to support metadata about the service. It has headers or metadata header, the kind of thing you need to send, let's say, a token, right? And so because of that, it's very easy to integrate into the Spring ecosystem. The Java client for this protocol was built on top of Reactor. This makes it very simple for anybody using Spring, which is already using Reactor, to take advantage of this. And so we were very excited to work with the engineers at Facebook as they're working on this. And we actually ended up working so much with them that this all got donated to the Reactive Foundation. So the Spring team and Facebook and Alibaba and a number of other large organizations that care about this kind of stuff have all been working together to make RSocket a really nice experience for people who are trying to build high performance, reliable, resilient services. And so we even extended Spring Framework itself to provide a component model for RSocket. So we're going to use that. We're going to use Lombok. We're going to use let's see, we want to use AMQP, right? We're going to use Spring Cloud Stream, okay? And I think we also want the config. I want the config client. So config client. Okay, so that's everything I think. Let me show this in folder, orders, Explorer, download. Okay, so let's open this up in my IDE. Orders application. And so what we're going to do here is we're going to create a simple service, simple RSocket controller that will serve up order data. But we need to create the RSocket server process. So we're going to create this one and have it run on 8181. And then we're going to create the controller. We're going to say, okay, add controller class RSocket order controller, right? Instead of the customer controller. Or maybe we can do, maybe it's the other way around. Maybe we do it like this. Right, order, there you go. So when the application starts up, we're going to create some in-memory data. Okay, you could easily talk to any database; it would be no problem. But let's just have an in-memory database here, and we're going to create a little map. So private final map of integer to a collection of order objects. Okay, new concurrent hash map, and we're going to create a class here, class order. Private integer, whoop, ID, private string. Well, you know what? We want the ID as, which is going to be the order ID as well as the customer ID. It's a dotted line linked to that, right? There we go. So there's my basic dependencies, and here's my map, my in-memory database, and I want to now fill it up. So what we're going to do is we're going to remember I have 8 records. So I'll say for var customer ID equals 1. Customer ID is less than or equal to 8. Customer ID plus plus. And then here, var orders list equals new array list of order. And for var order ID equals 1, order ID is less than or equal to math.random times, let's say 100, okay, or 50. There we go. So we're going to just create a certain amount of data. Okay, I'm going to say orders list, add new order. Okay, and it'll be order ID, customer ID. There we go. So that's the basic order thing, and then we're just going to put that in the database. We'll say this.db.put customer ID orders. So now when somebody comes asking for the data in this RSocket controller, we can just look it up in that in-memory map of data. Okay, so here's my message mapping endpoint. It's going to have a destination string, so I'll say customer ID. We'll say publisher, return a publisher of order. So flux.from iterable this.db.get or default this, and the ID, of course, will be this parameter here that I'm going to inject into the controller handler method. So customer ID collections.empty list, empty list. Okay, so there's my database call. My actual RSocket code is very easy, right? I spent more time just writing this silly data code here. So there's my entire application. Let's go ahead and start this up, and let's go check on our okay, there it is. This finished. Okay, look. So now this took 5 minutes and 10 seconds. You can see it took a while. Run that, and there's my application. It starts up in 0.15 seconds, right? I've got my application. There's all the data in the database. It's got, and remember, this is not just my Spring Boot application. This is an in-memory database. I'm starting up a whole database in the Java process, and it's really fast. And the best part about this is not the startup, because who cares? That's really not, most architectures don't care about that, right? What we care about is the memory footprint at runtime, right? If I am running this in production, this takes tens of megabytes, maybe 50 megabytes or 20 megabytes or 30. It doesn't take hundreds or thousands of megabytes. It doesn't take that at all. It's very, very efficient. So now I have this very lightweight thing. I can deploy many instances of this for cheap. It doesn't cost as much, So it's a wonderful technology to be able to use that and to be able to have it in production. So now I have my customer service and I have my order service. I want these things to, I've got configuration. You saw I have configuration here. I have configuration here. I want this configuration to be stored somewhere centrally. So, one of these things that's really nice in the Spring Cloud ecosystem is we have this thing called the Spring Cloud Configuration Server. And the Spring Cloud Configuration Server is just a Java API that sits in front of a repository of configuration, like a Git repository, right? And the repository, the Spring Cloud Config Server, acts as a proxy to the configuration from your Git repository. It could be on GitHub, it could be local, it could be whatever. And so you can point this config server to the Git repository, and it'll act as a facade, and it'll allow clients to request particular versions of profile data for a particular application. So let's say enable config server. And then here we're going to say Spring Cloud config server get URI equals that, right? Maybe you use HTTPS. Okay. I want the port to be 8888. And that's it. So we can now run this. That's not it. I forgot one more thing. The other thing is on GitHub right now, if you're using GitHub, in the last few months, I think it feels very recent. Recently, GitHub changed the policy so that when you create a brand new repository, the branch is no longer called master. It's called main, which makes sense, right? We're trying to get rid of words that are insensitive, which good idea. But because of that, you have to remember, which is not a big deal, right? Not a big deal. You have to remember that in Spring Cloud for the moment, it'll change in the future, of course, but for now, we have to tell it to use main as the default one, okay? So that tripped me up. I was like, oh, what's going on? This used to work a million times. Oh, okay. The branch is different. Okay, so no big deal. Let's go ahead and restart it. Okay, so now there's our application. Localhost 8888. So now imagine I am the customer's microservice. I go to the URL here, customers. I get the configuration properties called customers.properties. And here I can see the keys and values. I can see that my server port is going to be 8082. So let's now go to our customer service here. And, we don't need all this. We're going to say that the application name is called customers. We're going to say that we want to import the configuration, not from a config tree. A config tree, by the way, is like a volume mounted config map from Kubernetes, right? That's what this is, but that's not what we're going to be using. We're not going to be using files or class path. Instead, we're going to use a config server URL, right? And actually, I could do this. I could say, like this, if I wanted to. That would be okay. But I don't even need to do that because by default, it's going to look for this property called, well, I need the configuration, don't I? I need the dependency there. So Spring Cloud starter config, Maven reload. Okay, Spring Cloud. So it's going to look for this property, localhost 8888, and that's actually the default. So you don't even really need that. It's just nice to know that it's there. So these are the two things I need. And then once I do this, this will start not on port 8080, but it'll start on port 8082. So let's go ahead and restart this. And then over here on the order side, we need to do the same thing. We're going to say Spring application name equals orders, Spring config import, config server colon. Okay. Now, this will start up. Let's see what the configuration is. Oh, did I bring in the build dependency? Config, it's there. Good. Okay, so that'll start up. Now the config server is going to create the RSocket endpoint on port 8181. Okay, so let's try that out. There's a nice command line utility that's kind of like curl for RSocket. So it's called RSC TTP localhost streaming the data. The route is called orders, And then we specify a customer ID. And so there's the data for customer ID 2, for 4, for 6, etc. Right? So we don't have a 10, but there's that, blah, blah, blah. Okay? So there's our services. They're both working. There's the order service, the customer service. We've got the config service. Now I want to build a gateway. Okay, so I'm going to go back to start.spring.io, and I'm going to build an application that will be the edge service, the gateway for the code. So I'm going to use the reactive web support. I'm going to use RSocket. I'll use Lombok. I'll use the config client. I'll use the RabbitMQ stream support. And I think that's it. I think I'm happy with that selection. So then we'll just open this up in the IDE. Now, the gateway is a great place to put generic cross-cutting kinds of concerns. Things like routing and refreshing and configuration and security for authentication and authorization and load balancing and retries and compression and all these kinds of things you can put them here, and this will act as a proxy. So the outside requests will come to the proxy, then they get transformed, and then they get sent to the downstream microservices in your environment, right? And so we're going to create an application that will connect to the config server. So Spring application name equals gateway spring.config import config server. Okay, and so we're going to create a Spring Cloud Gateway application first. Spring Cloud Gateway is a project that allows you to describe how to route requests through the application. So you say rlb.build route, and then here you have routes, and the routes they must match the requests that come into the host and port for the gateway microservice. And then they get matched, and then they get forwarded or they get proxied to another microservice. So here I will say that when a request comes in to the path called proxy, then I want to send it to this service, localhost 8082 customers. I want to send it to the customer's endpoint. The problem, of course, is that the path here is already proxy, and if I add a path here, then what will I get? Will it be 8082 customers / proxy? I mean, we have to get rid of proxy, right? So we can use a filter here, filter spec. We can say gateway filter spec set path customers, right? So the incoming requests will be transformed. That's the power of these filters, is the ability to act on these incoming requests. And this, of course, all builds on the reactive APIs. And you can do really amazing things. You can say, oh, well, I want to add a header like so, right? So access control allow origin. Or I can do a retry, right? 10 times. Or I can do a redirect, right? I can do all sorts of interesting things here at this filter level. There's rate limiting, there's security, I mean, anything you want. Or you can just write your own filter, right? Any kind of generic filter, new gateway filter. So this is a great place to put your generic cross-cutting kinds of concerns. So let's try this out. Let's see if we've got this to work already, right? So it's going to go to this service / customers, and we're going to allow CORS headers. That way, even if this service here doesn't have CORS headers, because it's going through the proxy, this will. So this proxy, the Spring Cloud Gateway, it's great for, if you want to build an ingress controller in Kubernetes, if you want to do a route service in Cloud Foundry, this is a natural thing to do that with. Okay, so localhost 9999 / proxy, right? There you go, proxy. So there's my data on port 9999. It's calling the downstream customer service on port 8082. Okay, so that's very generic, right? I don't really know about the data that's going through here, but what if I want to create a view on the data, right? I want to create a materialized view of something that showed me the orders and the customers in one page, one thing, okay? So I'll go here, CRM client, and I'm gonna copy and paste the DTO types, the data types for the customers and the orders. So go to the orders, copy and paste this to the gateway, paste, window, customers, okay? There we go. Good. Alrighty. So there's that. Maven. Oh, there we go. So there's my basic arrangement. Now I'm going to create a client to talk to them both. Okay. And this means I need to make a network call using HTTP and another one using RSocket. Okay. These are both, I'm going to use non-blocking reactive clients. Okay. So for HTTP, I use the Spring Framework web client, which is a great non-blocking HTTP client. And so if you want to do any kind of network calls, HTTP network calls, use the web client. It is awesome, right? It's really, really built for this kind of stuff. I prefer it over the REST template by a lot, these days. Really, really powerful. You can use the web client even, of course you know this, but you can call non-reactive services using the web client, right? So very, very convenient. So let's say publisher of customer, okay, return. So how we got to make this? We've got to make this network call. What's the easy way to do that? Well, we say return this.http.get HTTP localhost 8082. Okay, customers. The data will come back as JSON. I'm going to convert it into a reactive stream of customers, like so. Okay. There you go. Okay, there's my customers. I want to get the reactive stream of RSocket data as well. So here I'll use the non-blocking RSocket client called the RSocket requester. And except the difference is that we don't actually call this a client because it's not, right? In the RSocket world, you have two sides that connect, but one side, once connected to the other, stays connected, and they can do whatever they want. Either side can send a message at whatever time it wants. So there's no real client server anymore. We say requester, responder. I can be the requester and you the responder, but later you can become the requester and I am the responder. It's true bi-directional communication. So we don't, it's a different name, but logically we use it to act as a client, okay? So RSocket requester.builder. And one of the nice things is that with RSocket, the connection is established at the very beginning of the life cycle of the application, and it stays connected. You don't have to reconnect each time, so that makes network calls a lot more performant, okay? So you specify the host and port when you build the client, right? You just do it once. You can also make it easy to specify how to reconnect, and all that stuff is very easy to do, but for now, let's just get moving on. So we here, push order, get orders for integer customer ID. Return this.rsocket.route orders customer ID. Right, so I'm going to say, give me the stream containing orders data. Right. So there's the network call across the wire there. Now I've made two calls here. I'm making two calls across the network here using the get customers endpoint and the get orders endpoint. Now, is this going to work all the time? I think not. Of course not, right? There's going to be issues. Things will fail. Of course they'll fail. So it's the network, right? You've got to be aware of the risk that you have there. So what I want to do is make my code a little bit more robust. One thing I can do is to configure a retry. Maybe I retry 10 times. Maybe I retry and then do a back off, right? Of seconds, 10, that kind of thing. Okay. I can also do on error resume. I can say when something goes wrong and there's an exception, then let's say instead of sending a stack trace, I can do an empty stream, right? I can just return an empty collection, basically. Okay. What about timeout, right? Well, timeouts are useful, right? So we can say timeout duration of seconds 10, for example. Okay, so lots of different things we could do here, but let's talk about this timeout. Why do we use timeouts? Well, timeouts, we use them because they give us a way to say when this has spent too much time and we are at risk of violating our SLA, then stop the work and then give us another chance to try again. So for example, maybe a client makes a request to the gateway. and the gateway has to make a call to another service, and that other service has to make a call to yet another service. Well, let's say at the gateway, we have a really, really generous, crazy nice, very generous 20 seconds, which is an eternity, right? That's forever in computer. But for simple math, we have 20 seconds at the gateway, right? For SLA. Well, the gateway calls the customer service. Well, that's 10 seconds, right? Is the SLA there? Because that way, if it fails, and we can time box it to 10 seconds, then if it fails, we can still try again and make the SLA for the gateway. Now, the customer service, in turn, maybe it calls another service. And so that takes 5 seconds. It has to be less than 5 seconds, right? And if that if that calls another one, then that calls another service, right? It has to take 2.5 seconds. You see the problem here? It decays very quickly because we're further away from the origin of the request. And so the further we are away, the harder it is to scale, to manage that response. So what we want is some way, and by the way, what does this give us? Well, if it takes 10 seconds, that means we can only try it 2 times, right? 2 times for this, 2 times for that. So that's not many bites of the apple, right? It's not many opportunities to succeed. What we want is more chances and less waste, right? So one pattern that is very common is called hedging. And with hedging, Google and Uber and Netflix, they've all used hedging, right? Hedging is very convenient. And the idea is that you want to diversify the risk. In English, when we say to hedge your bets, we're saying don't put all of your money in one stock, or you might know the expression, don't put all of your eggs in one basket, right? Basically, don't risk everything on one possibility. Instead, split it across a number of possibilities so that if something fails or something goes wrong, you still have backups, right? And the same idea is here. Instead of calling one service and then hoping that you get a response and then timing out, why don't you call the same service on, let's say, 2 hosts or 3 hosts, 3 different hosts, right? Same exact microservice, same API, but it's on different hosts and ports. Okay, and that way, even if one of them fails, or worst case, 2 fail, you've still got one that'll give you a response. So maybe the service, this happens a lot, right? Maybe the service is garbage collecting. Maybe the service is, out to lunch. Who knows? Maybe it's the power just went off. Things will fail. So this pattern is very simple. But think about what you have to do to make it work. You want to make the same network request to the same service on 3 or 4 or whatever different hosts and ports. Well, that's not easy, right? Because now you've got network calls. You've got 3 concurrent calls that have to be done at the same network, at the same time. And then whichever one is fastest, you keep. You keep the fastest one and you throw away the other 2, right? So you've got kind of a race condition. This is not easy code to write with regular Java threads and executors and runnables and all that. Sorry. This is difficult threaded code to write. And yet with reactive APIs, it's easy, very easy. You can just say, let's say I have, I have a network call for host 1, host 2, and host 3, okay? And obviously, you already know what this is, right? You know how to do this now, right? So imagine it's just this. This is host 1, and then I change host 2, host 3, right? So imagine I've got now 3 pipelines. I haven't launched them yet. And what I want to do is I want to say, okay, I want the first one to respond. I keep that one and throw away the other slow 2, right? So this will give me the fastest of the 3, and it'll apply back pressure to cancel the other 2. See how easy that was? Try imagining what you would have to do. Count down latches, maybe cyclic barriers, runnables, phasers, executors, and threads, and runnable. I mean, just not fun code to write in multi-threaded Java. Remember, there's only one person who truly understands how to write multi-threaded Java code. And it's not you, my friends. It's definitely not me. I don't know who it is. But the point is, we shouldn't risk finding out. Let's let the framework do the work for us. And this is a good reason why people use Reactor, why Facebook used Reactor when they built RSocket. It's why Microsoft, for all of their Microsoft Azure APIs and clients, recommends using Reactor for their Java APIs, right? So this is a very good idea, and you can see it. It makes a lot of really complex stuff very easy. This pattern, of course, I should say, this only works for the HTTP endpoints where you can call the same thing multiple times and not get a bad result. So it's idempotent, right? You should not use this practice on the charge the customer credit card endpoint. Not a good idea, right? But very, very useful pattern. It's trivial to do this in a reactive fashion. So we've looked now at how you can make your APIs more robust. We looked at different patterns that you can use to support that. I've got my RSocket code and my HTTP code, and you can see they're both just publishers. It's a publisher of customer and a publisher of orders. And so now let's say I want to compose both of these. Okay, so class customer orders, private customer, okay, private list of orders. Okay, so I've just got like an aggregate type, a view on data. Okay, so I'm gonna make network calls to both services at the same time and get as much data back as I can, and I'm gonna stream it back into a materialized view of the data. So customer orders, get customer orders, return this.get customers, and for each customer, I want to call the microservice for the orders. I want to get all the orders for each customer, but I need to keep both of them in memory at the same time. So I want to accumulate, I want to keep the customers and all the orders for that customer in memory at the same time. So what I'll do is I'm going to create a tuple, right? A tuple is a type that has named, it's got typed parameters, typed index position. So type 1, type 2, or position 1, position 2, etc. And the benefit is it's just a great way to store data when you do these functional kinds of transformations. So I'm going to say flux.zip, and I'll store the first item from these two monos. Okay. So I've got on the left, I've got the mono for the customer, and on the right, I'll say, give me the orders for customer.getID. I'm going to turn this into a list. Okay. Okay. So now I've got this, and then for each one of those tuples, I need to create a new customer orders type. So I'll say tuple dot get T1. You can see T1 is equal to customer. Tuple get T2 is equal to list of order. Right? So customers, oh, is this just map? There you go, map. Okay. Okay. So this is my reactive pipeline. I'm making a network call for each customer. I'm calling out and getting all the orders. But remember, this isn't one after the other. It's going through all the customers in concurrence at the same time, and then as it gets each customer, it's going and launching all the calls for the orders. So I might have 5 threads running at the same time getting different orders. Even though it's an n+1, it's still acting concurrently as much as it can. So we're getting the most efficient, most resource efficient code, and we're never blocking the thread. We're never sitting on a thread waiting for something to happen when we could reuse the thread, right? This is one of the big benefits of reactive programming, is that we're making sure that the runtime has access to that thread and that others can use it. So now we've got this customer orders endpoint. Let's go ahead and create a functional reactive style. So I showed you earlier how to use the Spring MVC style HTTP endpoints, right? But you can also use this functional style, which I quite like as well, right? So here, build.get customers. Actually, we're going to call it COs. New handler function. Okay. Server response .ok.body, and we're going to use the CRM client that we built. I'm going to say CRM.get customer orders, customer orders.class. Okay, there we are. Good. Good. Okay, so this is my HTTP client, my HTTP endpoint. Let's go ahead and start this up and see what we get. And you can see that this functional reactive style, by the way, is very, very lightweight, right? Like this is it. That's the one thing, and it's a builder DSL, so I can do things like this, whatever, right? It's fluid. Okay, this will probably fail because that's already running. So let's close conflict on the of the port there. Okay, so now, there we go. Olga, and there's the orders for Olga, right? And if I go down here, Marcin, there are the customers for Marcin, or the orders for Marcin, right? Go down here, Spencer, there's all the orders for Spencer. So you can see I'm able to make these network calls really quick. It's obviously very fast, and I get the data from these two different services at the same time. And it looks like a view. This is a great, great thing for clients, because a lot of times your clients, your Android and your iPhone and whatever, they don't have a lot of bandwidth. So they go to your service. Your service does the composition on the server side. And with reactive APIs, it's very quick. It's very, very scalable and so on. So it's not a very big deal. Now, I've done a read here. I'm reading the data from the downstream services. And by the way, I'm using RSocket and I'm using HTTP, but we don't care. All we know is that we have reactive stream types, right? We have reactive publishers and monos, and fluxes, right? We're not spending time trying to merge or glue together different APIs. Over here I've got Kafka, over there I've got application JSON, over here I have RabbitMQ, over there I have server sent events or WebSockets, and they're all totally different APIs. Well, with reactive APIs, they're all publishers. It's the same thing. So it's very easy to glue things together, to integrate, to compose different reactive streams in this way. And you've seen, I just did that with RSocket and HTTP, right? The orders and the customers. It doesn't matter at the end of the day what protocol they speak. At the end of the day, I'm getting a reactive type. Now, I've got a view of the data here. But what about a write, right? In a microservice environment, I'm going to want to write. I'm going to want to update data. But of course, what am I supposed to update? I've got two services here. So when I send an update to the proxy, to the gateway, what should happen? Well, there's no such thing as distributed transactions in a distributed system like this one, right? Where the XOpen protocol, the one that is the protocol is the basis for JTA. That XOpen protocol requires that all the transactional resources that participate in the transaction support the XOpen protocol. Nothing, except for maybe H2 that I've shown you today, supports XOpen, right? And this is just the way of the world. Almost nothing does support XOpen, right? So it's not a solution, right? What we want is, instead of trying to force everything to synchronize, which is a huge loss of resource efficiency, instead of trying to do that, what we want to do is tell each service what to do and have them update their own state, their own view accordingly. So we can use a message. We're going to have an update endpoint here, and then we're going to publish that message. As soon as that endpoint gets hit, we're going to broadcast a message notifying the other services of the change. So maybe we have a delete endpoint, right? So let's go here, and we're going to create a new endpoint called delete. COs, new handler function. Say server response. Okay. Body. Okay, and here I'm going to use Spring Cloud Stream. Spring Cloud Stream will make it easy for me to send a message using the Java2Days function types, right? And then I can broadcast that message to a Spring Cloud Stream binder. I'm using RabbitMQ, but there are binders for Kafka, for Kafka Streams, for Redis Streams, for Google Cloud PubSub, for Azure Service Bus. I mean, for anything you can imagine, there's a binder out that you can use that's really good, right? I'm just using one that's local, and it's easy to get on my local machine, but whatever you want, right? So the benefit of this, of course, is that you write your code using generic types. You're not tied to the Spring Cloud Stream binder API. So here's how that would look. I'm going to create a supplier that's going to create a reactive stream that has all the data about which customers should be deleted, right? So customer deletion supplier. Okay. Return new supplier. My job here is to return a flux. So I'll say publisher of integer deletions. I gotta sneeze again. Excuse me. Sorry about that, friends. Okay. So I'm going to say syncs mini dot multicast dot on backslash short. Okay. So okay, that's my deletions. Store that here. I'll say deletions dot as publisher. Okay, I want to get rid of the oh, it's this right here. Yeah, sorry. Integer. There we go. Make this a method reference. Okay, so there's my basic code. This is a supplier. It's going to return a reactive stream. This reactive stream contains the integers that we want to delete. We're going to broadcast those messages to everything in the cluster. It's the tell, don't ask pattern, right? So here I'll say deletions, try next. I'm going to get the current. I'm going to get the delete, the customer ID that we want to delete here. I will say request path variable customer ID, and we're going to turn this into an integer, right? Integer parse int. There you go. All right, try and emit that. And is it a success? Let's see. Okay. There's my basic messaging, consumer, my producer rather. Now I need to do the same thing on the other side. I need to be a consumer, and so this is this bean that we created, this customer deletion supplier. That bean has to be configured in the code, right? So here in the gateway configuration, it says I've got a Spring Cloud function definition called customer deletions supplier. Let's make sure that's the same thing. Yep. And it's going to point to this destination in the RabbitMQ broker. Okay. Now, what about the consumer? Let's say I go to the customer's endpoint. I want to consume the event. So it's looking for a consumer, customer deletions consumer bean. So let's go ahead and restart the gateway. Okay. And here, I'll go to my build. I've got to remember to bring in the Spring Cloud Stream binder. All right. Alrighty, now in consumer publisher of integer deletions, right? And the idea is that Spring Cloud Stream will give you a callback when the application starts up, and in that callback you're given a pointer to the stream, and so you can just subscribe to it and do whatever you want with it, right? You can say, okay, for each deletion, I want to then take the customer ID and I want to call delete on the database. So customer repository, okay. Delete by ID, customer ID. And then finally, with that done, subscribe, right? I want to log out, which just happened as well. So I'll say do a next. customer ID, deleting customer ID. So you can do the same thing for the order service, right? And each microservice knows what to do. It knows what a customer deletion event means for the order service versus for the customer service, right? So very natural pattern. Okay, so let's go ahead and restart this one. I don't have enough time to do both, but I think you can see the point. So we'll go ahead and now run this. Here's the customers. What about the gateway? Whoops. Oh, it's the database table. It's fine. Who cares? We're fine. So now go to the gateway. Let's see if this works. Curl -x delete HTTP localhost 9999 /COs / now let's go here for a second. So number one is Olga. We're going to delete number one. Okay. There's no more number one. Well, number two now is number one, I guess, right? So there you go, my friends. We've looked at a few things today. We looked at reactive data flow with Reactor. We looked at building reactive data access with R2DBC. We didn't even look at all the other NoSQL reactive options like Cassandra, Elasticsearch, MongoDB, Redis, Cosmos DB, Neo4j, all these different things. But we don't have enough time. We looked at reactive HTTP endpoints. We looked at RSocket. We looked at the Spring Boot actuator and the integration with Kubernetes. We looked at Docker builds and native image support with GraalVM. We looked at building using centralized configuration with Spring Cloud Config Server. We looked at what else did we look at? We looked at Spring Cloud Gateway. We looked at how to do reactive service orchestration and composition. We looked at patterns for reliability like hedging and on-error resume and retries. We then looked at using Spring Cloud Stream for messaging. All of the while, all this time, we're just thinking about the world in terms of reactive types. You didn't see me writing all this very different code and trying to make it all glue together. It just works together. I want to thank you so much for your time, my friends. I am very happy that we got to spend some time together. I hope you enjoyed it. Let me know who enjoyed it, right? I'm here to stick around. I'm not leaving. If there's any questions, I'm happy to answer them. And I hope we get to meet again soon, right? So there's that. And thank you so much, of course.
Thank you, Josh. We can wait for questions for a bit.
I see that some people caught my mistake earlier with the closing bracket. I appreciate your pair programming with me. Yeah, Warner said that nice Bulgarian chicken soup would help cure this cold, and that's true. I miss that. And skembeche, is it? What's the stomach, the spicy stomach soup that we used to drink or have after a long night? I hope you had fun. Happy holidays, Merry Christmas, Happy New Year to all of you. Code. Okay, so the code, by the way, I showed you Reactive Revolution earlier. The other talk you might want is this one. The other code is Cloud Native Java. Let me share my screen one last time. Here. This has all the code that we looked at. This is actually the more recent one. I would use this one. Use that Git repository. Shkembe, yeah, is that the soup? Is that the animal stomach and spice and milk? That was delicious. Well, All right. You have my email, josh@joshlong.com, and my Twitter @StarbucksMan. Say hi on Twitter, would you? Always happy to make new friends. It's it's 2:30 in the morning with here in San Francisco. 2:30. I wish I could be in Bulgaria.
A bit off topic, but would you like to join the discussion about Java ecosystem evolution, which is starting right after your talk? Everybody likes to see you.
I was kind of hoping to go to bed. How long is it? It sounds like fun. How long?
It should be 1 hour, but you can drop early, of course, because I understand it's 2 a.m. in the morning for you.
Yeah. Yeah. Is it okay if I don't? I'm beat. I see this. This is I because I've been fighting this cold, so this is coffee. Trying to stay awake for this. I'm sorry. Please forgive me. But I wish I could be there. I wish if it was earlier the night, maybe I could have been there. I'm sorry. I'm gonna
No worries,
pass.
Josh.
I'm so sorry.
Get better.
Oh, thanks. This is so much fun. I miss you all. I love this conference. I don't know if people maybe Werner he knows, but and some of you know, but this conference I'm a huge fan. Right, 11 years or something like that at this wonderful show.
You've been with us for most of those 11 years, especially in the beginning.
Yeah, exactly. Especially in the beginning, and it's just been very hard to get back there. I didn't get to go last year, and then stupid pandemic this year. So I'm glad it's not COVID too. It's just a cold. I'm sneezing. That's not COVID, right? I'm fine. Don't worry about me. But it is a cold, and it's. But anyway, I miss you all. Have a great night. Let me know if I can help. If there are any questions, whatever, let me know. Okay. Thank you again.
Thank you, Josh.
Bye.
Have a great.
You too. Great day.
You're live.
Hello. Hello, everyone. We are here to talk about the evolution of the Java ecosystem. And the first question is, it's not the question, but in fact, I would like to ask our speakers here to define Java ecosystem. What can we understand behind that? Which are the main components, like JVM and the other components of the ecosystem?
There's a long silence. No one wants to come step forward to name the
Exactly.
components.
Yeah.
All right. Go on, Nicholas.
Yeah, thanks. There must be somebody first. Yeah, well, thinking it's a huge question actually, and it has changed quite a lot in the last few years. So of course, as you mentioned, like at the core of Java, there is JVM, and for a long time, the funny part is that people said that the language would like slowly die, and they would keep the JVM. And that's very interesting because, yes, there were like new languages coming in, such as Scala or Kotlin. And people started to look outside Java itself to develop. But in the last few years, Java came back in force with like these 6 months release cadence, which, to be honest, is also for us quite hard to keep up with. But now Java is back in full force, and on the other side, the JVM is not super, let's say, adapted to the clouds because you need like startup times that are longer. And now we are looking at other stuff such as GraalVM, which takes the bytecode and makes it native executable. So that's completely opposed to what we were thinking, that Java would die, would keep the JVM. Now we seem to like be like loving Java, and the JVM like loses some of its polish. So that's the first lesson. So don't do any forecast because it will probably be wrong.
Thanks. We already have the first questions, the first question from the audience, but
perhaps I will let somebody else, like younger, tell about his experience.
So I'll answer the initial question of what makes up a Java ecosystem. Now, since I started learning about Java, it's been many years now, I noticed that there are two main components, and of course now we can look at them as many different components. It's the language and the platform. So initially there was only Java and the platform, that is the language, and the platform was the JVM, and the language ran on the platform. And over a period of time, in fact, just very recently after that, there were other languages that were born out of it. So the language and the platform make the two important components of the Java ecosystem. And then, of course, there are many other things that grew out of it, connectivity from other languages to Java, Java to other languages. And as Nicholas pointed out, that over a period of time, we had all kinds of different concerns, like recently, or not so recently, it was being able to make it cloud ready, and then that problem was solved in a short period of time. And even more recently now, we have the advent, and I'm saying recently, but it's been a 7 years development. If many of us are following, it's the GraalVM, which is Java on Java, or Java written in Java. And what the project is going to do, or is poised to do, is try to theoretically replace every component of the JVM that's written in C++ with Java. And they've already started doing that. Like, for example, C2 compiler, which was written in C++, has been rewritten in Java, and it's called the GraalVM compiler. And they're going to be doing that to the other components as well, the garbage collector, and you name it. So slowly, the ecosystem will be replaced by Java itself, and there'll be very little or very less of non-Java components in there, like things written in C++ or assembly. And now you're able to run programming languages that were, or write programming languages, or rewrite them that have been outside the Java ecosystem and bring them into the Java ecosystem. So you can now run Python, R, Ruby, Shulong, which is a C++ component. So the Java ecosystem is actually broadening quite a bit. It used to be just the JVM and Java the language, and then it became Java the language and other languages like Groovy, Scala, Kotlin, and JRuby and Jython. These were the replacements of Python and Ruby on the JVM environment, but it was still a bit close. You had to still write things that the ecosystem understood. And so now the ecosystem is broadened more than that. So if you see there's a third layer coming out, which is languages written in Java using the Truffle framework that runs on the JVM. And again, the problems of small footprint, of high performance, all of this is resolved with the advancements of the JVM, but also the new technologies that Graal VM has brought in. So we no longer have two components. I think there's a third component that is actually built on top of the two components. And that's where the ecosystem is going. So slowly, before we even know, all of the programming languages that we can visualize and think of, the current ones and the future ones, could be rewritten using Truffle framework and run on the JVM. And so the JVM becomes ever more powerful and important component. And the JVM is getting smaller and faster as well, given that all the components of the JVM is now being rewritten in Java and rewritten with performance and footprint in mind. So it's not only going to get smaller and faster, but also able to help you interoperate with other programming languages that we weren't doing so well in the last era. That's my kind of understanding of the Java ecosystem from my perspective.
Okay, interestingly, I think let me start with the fact, like I think the first time I heard about Java was with the news that Java is outdated in 1998, when I had not even written my first program, interestingly. And we are here more than 22 years later, still using Java day to day. And also, another fact I would like to bring in here is that when Java started, of course, it started as a platform independent thing. Though Java could run on multiple operating systems, Java was the only language what you could make use of. On the other side, .NET started with multiple languages, but it would run only on Windows operating system those days. And from then, we have seen how, say, Java has become a true platform. Initially, we would use the term Java to refer to the language because that is more important to the developer. Of course, there is a JVM which has to run on multiple operating systems, which is for very special people who develop these, and majority of the developers would use Java. So I think Java from then till today. Today, we mean the entire ecosystem. Anything that runs on Java, we would call as Java, not just the Java language. So I believe when I use the term Java, it refers to the Java ecosystem. And if I want to talk about Java, the language, I would specifically say Java language. Another important part I would say is like, I started with Java like in maybe 2001. When Java 1.3 was just out, I guess, but I started with 1.2. Typically, when way to boost the productivity of developers, though dynamic typing was the approach followed in those days. over a period of time, we have seen Groovy embrace both. It can be statically typed as well, and we have seen more modern languages like Kotlin and some functional programming influenced Scala, and Clojure on the other side has a very highly opinionated small community, which is pretty useful in certain places, as long as you stick to those opinions. One language, I believe, there were also efforts to bring in Haskellish, coding into Java in the form of Frega and Ita, but I'm not sure if those have grown beyond the initial experiments. So with that, yeah, I would say, of course, Mani has already mentioned about Graal VM and cloud readiness, those aspects, which make Java very rich and very useful for today. Yeah, thanks.
Yeah, let me also add a few words. So it has been very rich across multiple aspects of the platform, because especially for Jakarta EE and on the server side, in many cases, the platform is much bigger, although there are more trends in recent years to go serverless and become smaller. So almost everything that runs on a desktop could also host a server, like Spring Boot or Microprofile and similar approaches. We also had Java on very small devices. I think the Java card and credit cards is still predominant and probably the biggest number of deployments out there all the time, even in the cloud. But for example, Java ME embedded has almost vanished and died, mostly because devices got a little stronger, and you can have something that runs on a Raspberry Pi Nano or some way small, almost credit card sized system on a chip, but you can run at least Java SE, especially from Java 9 onward, that allows to make the JVM itself as compact as you need. So there was almost no need to have something that's even tinier, because hardware was evolving and was cheaper and was more available. So that's, I guess, why Java Card will definitely be important, even though that's probably one of the few parts. We talked about open source yesterday, and Java Card is one of the few areas that's never been completely open source and probably never will be. But below that, or between Java Card and SE, the need for the mobile and compact embedded Java has almost vanished, probably to some extent because of Android, and on the other hand, of course, because SE and desktop has become cheaper and smaller, and you can usually you may have more power on your phone now than you did on a giant server cluster or blade a few years ago.
I think when you mentioned Java Card, it's something like this, right? I was given this at a conference.
Mhm.
It's called Code Card,
We have
but
questions.
you can run.
Can you hear me now?
Yes.
Let me start with the first question.
Eva has gone.
Did something happen with our connection?
Yeah, it seems she has a bad connection.
The question sent her into the rabbit hole.
That's funny because I have a lag between the sounds and the video.
Is his screen here still, or is he?
Oh, he also has bad connection. Okay, so on Slack, she says that we should answer the first question, which is how was the ecosystem when we started? So I will try to answer that. And as for me, as I wrote in the chat, I started playing with like Java 1.1, but I didn't really start coding professionally until Java 1.3, or perhaps it was 1.4, but Java EE 1.3. And at the time, you must understand that it was interesting, but no fun at all. Because, well, if you are used to Maven as a build system, or Gradle or whatever, at least you have dependency management. So at the time, you had no dependency management. There were no open source frameworks to speak of, really. Every company, at least in France, started to develop its own framework to just not reinvent the wheel in every project. No unit tests. And I mean, the first time I was shown something like unit testing was like, hey, look, what you can do is into the main method of each class, and you can run it, and you can see the output, and oh, crazy, you can already check a bit if the code works or not. As I mentioned also in the chat, we didn't have Eclipse. The only IDE which was free at the time was Borland's Java Builder, I think it was called, with version 4.
JBuilder.
Yeah, JBuilder, thanks. Borland JBuilder. And actually, yeah, after version 4, it was paying again. We used the IBM IDE at the time, and the code was not, when you imported the code in the IDE, it was not stored as individual files on the file system, but just one gigantic blob called the registry, and the registry got frequently corrupted, so you had to copy the registry from your friend. No Git, no Subversion. I think we used CVS at the time, but yeah, that was, imagine it was like you were trying to create a plane with only stones. Very, very interesting times. At least that's how I remember that time. And now you just open your IDE, you just use Maven, even if you are using IntelliJ, or you go on like Spring.io, start.spring.io, you click the dependency you want, and everything is done for you. I mean, now I feel more like an integrator of bricks with just some configuration than a real developer, which is also fine with me. And perhaps now I have talked enough. Somebody might want to give his version of his history.
Yeah, maybe I can pick up. I was quite lucky that I was exposed to Java almost when it started. So I think the first version that we also worked with professionally for my main client at the time was at least 1.1. I think 1.0 was probably still a little experimental, but we worked with 1.1, and among other things, we were involved in creating an EJB-based application server for a big customer, some pension fund, I believe, and that was also when that customer, thanks to some people that we knew back then, actually my ex-wife is now in Sofia, and she also attended Java2Days once or twice as a guest, but at the time they lived in the US, and so we were able to stay with some friends during Java 1, because back then I think Java 1 alone had somewhere around 20,000 people in '98, and that was literally the year when J2EE was born and first introduced. So that client sponsored part of my Java 1 trip, mostly the ticket and probably also some of the flight ticket, but we didn't have to pay for the hotel because we were allowed to stay with somebody in San Francisco. So I especially witnessed the birth of Java EE, or Jakarta EE as we now know it. And the client also had some of their projects that involved creating J2EE1 and EJB1 compliant application server, which of course also was a lot of fun and gave us a lot of insight that helps me almost all the way until now. So one of the major differences was, of course, back then, except JBoss starting under the name EJBoss, and I also looked at it when it started, and I think it was changed. Even then, they changed several times the code base and names and lots of things, so that has continued almost until today. But there was a lot less available in open source, especially on the enterprise side. So JBoss was probably the only really serious competitor that also still survived until today. And other than that, most of the others were WebLogic with BEA back then, and IBM WebSphere and several others, but they were all closed source, so you had very few things to compare, and there were a lot of things that we actually had to learn very hard, and that's why visiting Java 1 was a very welcome opportunity to learn some things from the source. I think I even got one of those Java rings, which is also the Java card compliant technology, but unfortunately, because I moved dozens of times all around the world, I don't have the ring with me anymore. But yeah, that Java 1 was definitely a nice experience, and it took me more than a decade until I came back. With JBuilder, there's probably also an interesting story that at another client a few years later, we were supposed to replace some legacy products that had very big license costs involved with a big bank, and we had JBuilder, but somehow the license server was broken and didn't work properly in Austria, so we couldn't get it to run. And then with very fierce concerns, and they were almost afraid of that open source technology back then, but somehow, especially because of the deadline, myself and a few colleagues managed to convince the client, a large bank in Austria, to try out that new Eclipse thing, because it was free and it was more easy to use, at least until they were able to fix the JBuilder license server bug. And that was one of the reasons why we actually met the deadline and helped them save, well, leaving aside the license costs, but the project itself, we helped them save, I guess, at least several million. I think it was already starting to be euros, but at the time it was still Austrian shillings. But even in euro, I'm sure we helped save them $1 million or more by using open source at a time when it was still considered very radical, and many of the banks had policies that prohibited it. But a few years later, at an Eclipse demo camp, that very same bank had a speaker sent there, so they actually ended up also contributing to Eclipse, and the IDE that a few years earlier we had to almost force them to use in order to meet the deadline of the project. So yeah, back then I sometimes ended up learning a lot of things by doing them and learning them from the source, but that's also because because of that I'm now also sometimes in lucky position that I've been involved in some of these ecosystems for quite a while.
Interestingly, when I started, I mean, at least learning and trying it out, not professionally though, mostly I could use the IDEs like NetBeans, Eclipse, just for a few minutes. Maybe beyond that, those days I used to have like 128 MB RAM on my PC, but the IDEs wouldn't work beyond first 10 minutes, so I had to stick to plain text editor, something like JEdit, I believe what I was using. And interestingly, due to that, I had a lot of the APIs fluent, and I could use without really, requiring auto completion or anything those days. And even before I started my professional career, I had a chance to use JUnit. Because the reason was that I was looking at design patterns, and somewhere I had read that JUnit is a good place. It's a good open source library to look at the use of design patterns. That's how I started looking at JUnit and started using it. Even before I started writing code professionally, but I think that helped me very much later on when I started my professional career. Thank you.
So I'll try to pack in that question and maybe the other following 3 questions in one go, so that the next time I speak, I have another different question. So I quickly started using Java, around the first version when it came out. And at that time, there was no IDE. All I used was Notepad and a command line editor. And I actually was using it on Windows and not even Linux or another operating system. And then there was a short pause. And before I could next start using it was only when I started looking at Java 5 or Java 6, maybe even. And at that time, we had Eclipse. There was less command line usage, but nevertheless, a lot of IDE usage, and Eclipse was good enough to give us enough of the auto-completion and other IDE goodies. And at that time, I also practices that a lot of Java developers did. Luckily, I was able to liaise with a lot of, like being in London, I was able to liaise with a lot of the community, including the London Java community and the other communities that sprung out of it. And so, as Naresh mentioned about JUnit testing, and Nicholas mentioned as well, that became a de facto work method in the Java ecosystem. And so you can understand that starting from no test unit, like in the early versions of Java, not many libraries, all the way to when I started looking at Java 5 and Java 6, there was a vibrant community and people were talking about garbage collection and performance tuning, and there were lots of open source libraries. So that was a massive boom and people also, like when I started looking into Java again, that's when I also got introduced into the community that I could contribute back to Java. So if you'd like to know how to contribute to Java, look at the OpenJDK project, look at a lot of the open source projects like Spring. In GraalVM itself has a massive contribution opportunity there. And so it's really hard to tell you how to really start contributing to Java, because it's such a huge ecosystem. No matter where you look, you'll find an opportunity to contribute to your library, maybe just the documentation part of it. Just start a pull request to improve the documentation of a library, or raise an issue saying you have found this problem in the library. And that could basically help you also get started with your contribution aspect of your career. And if you have to answer the question, what were the roles of the tech giants in the evolution, I would say a lot of big companies opened up their open source their in-house projects and in-house libraries. And also at the same time, like if you look at some of the major contributors to the OpenJDK project, there are some of the big companies like SAP, Microsoft, Red Hat, IBM, Oracle itself, and the list just goes on, and they are not just contributing to the JDK as a JVM, but they're also contributing with other libraries, and Red Hat especially is taking on the job of hardening some of these open source libraries and making them available open source to the public, and doing even more service to the rest of us in the ecosystem. So I'll sum that up to some of those questions, and just want to have a quick look at what programming language compared Java changed with the other programming languages. So Java has been maybe different and slower in its evolution, and the maintainers and the architects of Java have a good reason for that. And there are lots of talks on that, and maybe we should share that as a separate link. But the advantage of coming up with your own language on an ecosystem like Java is that you are allowed to share your ideas and your methods of working and your ideologies of how a language should work in an open ecosystem like Java. And so Java, the language itself, may have taken a different course than many of the other languages. And slowly Java, the language, is adopting a lot of the goodies of other languages, but the pace is much slower than many other forward languages. And sometimes they have even crashed. And I wouldn't name any of them because they're probably fans on this channel. But you can follow them up to see what they could be. So I'll rest my words here because I must have covered all the 3 questions. If not, Eva will point out to me anyways.
There is an interesting question in the chat. Alexei asks, what does it take to become a speaker like us? Well, the thing is it takes just the willingness to take some risk, to go out of your comfort zone. I started talking just by going to my local user group, and yeah, they accepted my talk, and then I never stopped. And I believe that everybody can do it. I see a lot of people having very interesting experiences, and the same people, they are very afraid to go on stage and say, but I have nothing to say. Well, it's not up to you to decide that. It's probably up to the conference organizer or to the attendees. So don't be afraid, take some risk. It's perhaps not comfortable the first few times, but after a couple of times, it's very energizing. I mean, of course, if you are online, it's not that energizing, but to get feedback from a room full of people is very, very interesting. There was another question, how Java has changed over the years compared to other programming language. That's also an interesting question. Like, for a long time, like, it was mostly like by bits and pieces with Java and .NET. Like, Java got an advantage, and then it didn't evolve for some time. Then .NET added some interesting features, and let's say like Java, like for a couple of years, tried to get like again added benefits, and it went pretty well, as Manny mentioned. It was I think that's the huge success of Java is mainly because it is very stable. It is backwards compatible. I mean, you can run pretty much any version of all application on modern JDKs. And when the people behind Java changed it was like with Java 8, 9, 10, and you can see that it has a massive impact. Of course, the language itself is evolving faster, but the adoption of the latest version is much, much slower. So it remains to be seen whether it was a good idea or not, because it's a tension between your release cadence to please the developers, to provide new features, and the adoption rates. Like, at least half of the developers in any room, they still use Java 8. They didn't move to Java 9. And we are nearly at Java 17, which is crazy. So, I mean, I'm a bit worried about that. Also, not to mention that the Java 9 with the module systems probably didn't help things. And as you can see, also the adoption of modules among libraries is quite, let's say, sparse at the best. Another question, and then I will shut up because I also need to let other people know. Yeah, about contribution. Contribution is very interesting. Also, the step is not that huge. You go to products or to frameworks you already use, Spring, Java, whatever. And for example, on GitHub, you probably have labels like good first issues. These tools are quite easy to use. I mean, even if you are not, if you are a junior programmer, which sometimes I feel like right now the pace is so fast, I cannot cope with it. You can check some good first issue, then you go to the community Slack or Gitter or whatever, and then you can ask for help if you don't manage it. But most community I've been part of are very, very helpful. You can see in the Spring community, in the Kotlin community, Java community, of course the Hazelcast community as well. And yeah, just go on GitHub, find good first issue. Also, as many mentioned, you don't need to know how to code. Documentation, it's always good stuff to make improvements.
Okay, let me share my story of becoming a speaker. So back when I was working, I kind of realized that there are a lot of common, Java-related knowledge which could be shared between the projects. I mean, between people working on different projects. Hence, I started a Java user group within my organization. Usually we used to have like 2 meetings per month kind of, and sometimes the speaker who I invite would say, okay, now I'm a little bit busy, can I speak in the next slot? So I didn't want to really postpone that meeting, so I used to have a backup talk ready by myself. So I think over a period of like 1 or 2 years, I was the one who spoke most. And later on, like I was attending some conferences pretty often, and some of the people, regular speakers there, they saw me that, okay, I'm pretty regular, and they knew me, and they encouraged me to, okay, why don't you submit a proposal? That's how it got started. And regarding with respect to the question on contributions, I think try to create value. Of course, whenever you are say using a framework or library, you might want to understand certain things with more depth. So in that case, since if it is open source, you always have the chance of looking at the source. That's how I ended up looking at source code of several projects. Once that you might see that, okay, certain improvements might be very helpful to you, in the sense to your current project. For that sake, you could make certain changes, and once it is useful to you, I think you can always contribute it back to the project, apart from the other points people have already mentioned. Thanks.
So I'll chime in about my speaking career, and I would say that writing blogs. Well, I can't say if there was an order, but I would say starting to contribute to an open source project led to me writing blogs, which led me to speaking, and then there was a cycle that was not in any particular order, because when as a developer you're also a sort of a evangelist. You're sort of a spokesperson who speaks about the project you're passionate about, the contributions you've done to it, and so you end up going onto the speaking circuit. And so luckily I was part of the LJC speaking circuit, where we would constantly speak at various events and conferences, and that's how I came across Java2Days as well. This was about 5 or 6 years ago, and I'm thankful to many such conventions and conferences, including Java2Days, for giving me the opportunity, including the one this week, to speak. And that's, and once you break the ice, then there is no stopping you. Then you want to speak at as many conferences and submit papers at as many places. And so there is that just one, as Naresh was mentioning, and Nicholas also mentioned, you got to just take that first step, and then there is no recipe or procedure or process. We don't even remember. I don't even remember when I took my second, third, and the remaining steps. But I do know that the first step was just stepping up and saying, okay, I want to go. We had to go and stand in front of 10 people and say something for 5 minutes. So you want to do something shortest and simplest first, because you can imagine in 5 minutes you can speak a lot. Like you can already see in the last few minutes I already said so many things, and each one of us has many things to say. It could just be a small feature in the Java language, or a small feature, or something you learned on the command line, or some flag you know of that you think it could have been improved, or some documentation issue. And every bit of these things, contributions you make back, similar to opening a pull request with just a documentation change, is similar to doing a talk, which is just talking about a line in the code or a documentation issue, or an improvement in documentation, or how good a certain documentation of a certain library is. There are umpteen number of topics to pick from, and so there is no one recipe or one process to do something. And Java2Days is a great platform because they are very open to all kinds of submissions. You can already see we have a full panel the last 2 days and tomorrow as well. And so just jump forward and pick your poison of choice or nectar of choice, whatever you want to, and just speak about it.
Okay. So yeah, let me also add 1 or 2 words to this. So since I worked for clients who were way early adopters of Java, I started occasionally speaking already before the turn of the century. So this was roughly around the same time as my first visit to Java 1, although talks then were not as big. But it was to some extent out of our boss and the boss of the client that I worked with, a local consultancy in Vienna that started using Java way early, and he was also tutor at the Vienna Technical University. I actually also helped as a tutor for database systems, so I was exposed to Oracle DBMS even before Java existed, and helped other students there. So this was definitely a very good way to get into teaching other people by helping them as a tutor while I was still studying myself. And because our client was also giving lectures at the same university, he was invited to several talks, and I think that on one occasion I actually met all or most of the famous Gang of Four that defined the Gang of Four patterns when they gave a talk in Vienna. And on another occasion, Erich Gamma also presented SWT for the very first time, and I had a booth there. I didn't even speak, but I had a booth at a conference that I think was called Java2Days, and later they changed the name. It was a little bit like Devox, that they tried to broaden the focus. So I believe then they called it Net Object Days. It was near Erfurt in Ilmenau in Thüringen in 2000, and that was the first booth I ever had at the conference, trying to sell a couple of Java-related products, for example, the internationalization of Swing, many years before Sun actually integrated that into the JDK. And I had a tiny booth with 2 people, and on one side IBM had a giant booth, and on the other side Sun had a giant booth, and we were right in the middle. So that kind of activity, helping the clients to either promote their products or occasionally also promote my own smaller helped me to get to several of those conferences. So Java 1 was probably the only one where I was simply attending and watching and not actively participating, but there were other conferences in Germany and Austria. I believe one was either in Munich or in Vienna. I can't exactly remember, where our boss simply said, okay, sorry, I have a meeting, I'm too busy, I can't speak there, please, Werner, go there. So that was one of the first chances that I got to speak. And the others came up, of course, from working as a tutor at university. So it's nice to see that some of my successors in the JCP executive committee are now also fostering Java in education, because if it wasn't for education, I would probably not be here, and I would probably not have learned Java as early as I did.
I think we are missing more questions. We want more questions. We need more questions. We beg for more questions. Don't feel shy. I mean, we don't see you.
It's the big data question, or what exactly was that?
Yeah, there's a big data question.
The question is like in big data, it seems that Java seems to be the language of choice.
I think yesterday we also heard that when it comes to analyzing data, it's probably a lot more Python. But when it comes to hosting some of these systems, including Spark and a few others, I guess they all run at least on a JVM, and many of them run Java. So except there may be a little more Go here and there, but that's also more on the infrastructure side. And I read a Medium post a few months ago that also said, like, yeah, Go is evolving a lot, but in some cases it's not yet as mature and ready for the enterprise world as, for example, Java is. So it definitely has a lot of important use cases, including the containerization. But it seems when it comes to data representation, that's definitely one of the areas where Java is still a bit stronger. So hosting some of these object and data level, I guess Java is definitely quite strong. When it comes to analyzing the data, sometimes Python may be more the language of choice.
So I'd like to say a bit about the big data question. Is it appears now that Python is the de facto and R are the de facto languages for data processing, and of course, as Werner rightly said, a lot of the other systems that are used to do the rest of the pipeline in the process, whether it's data, it's parallel processing or handling data at large scale. Java and JVM based systems seems to be more reliable and stable, and are able to handle that at production and enterprise level, as opposed to Python and R, which are not suited for those kinds of environments. But this space is changing, and Java, the language, is now the only that appears like that. But it's more the JVM that's going to be continuing to be playing a big role, or a bigger role in the big data space. And you will notice that Python and R are not going to go away, because if you're following the Graal VM project, like some of us here, there's Graal Python, and there's R already available, faster R already available on the JVM. And then just there's a version of Ruby has been worked on, and other programming languages can be quickly written. And then all the code that you've written in your, what we so used to call legacy code, which no longer should be called that anymore, because you can then rerun all of that. COBOL has already been rewritten for the JVM, for the Graal VM. And so you could run all of that on the JVM without even writing anything in Java. And so then you could be doing a lot of big data. We are saying big data on Java now, but we'll say big data on the JVM in time to come. And so all of that work that's been already been done in the so many years to come, they can all be running on the JVM. And you will not see any difference. You will definitely notice an improvement in performance and interoperability, which will make the big data world work much more seamlessly.
There is a question in the chat: how the education systems influences the Java ecosystem? I have a personal experience with that, which is very funny. So when I graduated, I didn't study computer science actually, but still I had a few lessons about C and C++, and it was really hard for me. I mean, it was really, really hard for me. Then I learned Java when I started my professional career. And 2 years afterwards, I came back to my engineering school and asked if I could teach Java. So the first year it was an option, and the second year they replaced the C and C++ teacher that had taught me that, and it was only Java. So I just made my previous teacher obsolete. I'm sorry for that if he listens now, which probably he doesn't, but still I just apologize. But now we see that Java in some universities is being replaced by Python or JavaScript. So I think it's just a hype curve. And yeah, now Java is not hype anymore, which is perhaps a good thing, perhaps not a good thing. But yeah, we have been reading the death of Java since like 2 decades, and it's still there, and it's still living and kicking. So yeah, I think it's a safe bet to continue your education in Java. As we have talked about it already, even if you know Java, and you want to deploy on the cloud, just use GraalVM, make your application native executable. You can steal the same tool, you can keep the same ecosystem, all the libraries that you know, all the syntax that you know, and be happy. So Go and Python, yeah, they have some benefits, but if you are a Java developer, life is really, really good.
So Java is like Mark Twain. The news of its death is highly exaggerated.
With respect to the education, I think, I mean, this is equally applicable to any other languages as well. I think one important distinction I would like to see is like typically programming is taught as if like it is done once. You write perfect code once and you run it and it is done. But I think, you know, what is very important is the ability to evolve from how it is today and accommodate the newer requirements and make it evolve. I think that skill to evolve the program over years is something that is lacking in the current education, I think, which is something very important. Say, for example, having some personal projects could, you know, you develop it over years can really help to address this issue.
Yeah, I would say I would plus one what Naresh and Nicholas just mentioned as well. What I'm noticing is that when I am actually informally mentor people, I notice that there are so many, not just soft skills, but so many hard skills that are missing in their tool chest that I thought they would have had because they spent 4 rigorous or 6 or 8 rigorous years in education. And I haven't even gone through some of those. I had to learn through the hard ways, through other strong developers around me. And it has been a lot of sacrifices of weekends and after working hours. But I learned those things that they are not even reading about or learning about in the university. I mean, I don't know what they are learning. A lot of it is theory. And I'm sorry to say that theory is important, but it is also not important if you don't know how to put it into practice. And it doesn't really matter whether it's Java being chosen as a language in that university or in that curriculum. It is choosing all the ways, all the pragmatic thinking, all the best practices, you know, the approaching the things top down and not bottom out, and when to do top down and when to do bottom out, all those important nuggets. And it's actually the whole way of working is not taught, which when they graduate out of whatever degrees they do, and they say they are a computer engineer or a software developer, they are not still ready. Some of them are still not ready for the real world. And that's not very pleasant, because then you have to handhold them for a number of months, weeks, years, and then bring them up to a level that they can then be ready and productive at their workplaces, and then start loving the joys of the language like Java and the JVM. And I'm not sure if that journey is at all pleasant for both sides, the mentor and the mentee. And I think that can be improved and can be made much better.
Hey, Manny, I think I was not ready for a couple of years either when when I went out of studies. So I understand that yeah, it takes a long time to have somebody who's productive. Whether you have been at a university or you did a boot camp or you learned everything in books, but we are in the fast-moving technologies, and I believe that even seniors like us, I mean, we need to regularly relearn stuff because stuff that was done in one way before is not now done another way. I mean, regularly I write stuff, I fail, I rewrite it, and well, I think that's life. I mean, I cannot expect for a long time. I did teach at school and universities and stuff, and I try to like bring industry understanding in those like organization. But most of those schools, they are like the lessons they are taught by professors who actually are very interested in theory and in their research, and they are mostly not interested in industry and how it works in the real world. So some of them are, and that's real good. I mean, we need more bridges between those higher education organization and the industry, but most are not. And yeah, that's bad, but that's how life is. So I will need probably to a question. How do you see the Java?
We have another question from Bongo. He's asking about how do we see Java ecosystem in 10 years?
I believe that anybody can tell you anything and it will be wrong in 10 years. I mean, yeah. I mean, even 2 years is a bit far. In 1 year, we can believe that yeah, it will be more about like more evolution from the language and more native image stuff. But like beyond that, all bets are off. All bets are off. Remember, at the time, there was a technology called Flex. It was super great because I mean, you could develop once and it was displayed in every browser in the same way, regardless of the implementation. And still just kill it by saying we don't want Flash on the iPhone, and they just kill Flex like that. So everything that can be said, it will be like probably wrong in 10 years. It's conjectures.
Yeah, I think I'll totally agree with Nicholas on that, because look at it. For how many years have people been saying is Java dead? I know there's a very brilliant but also funny guy in the LJC who keeps every year we have an unconference. He would come up with the talk, is Java dead? It'll be like a 5-minute talk, but he'll still bring it up. Of course, lots of people wouldn't vote for the talk because people knew he was joking, but also that we knew Java wasn't dead, right? And it's been going on for so many years. So there are new variants and new languages coming up on the JVM, but Java, the language, is still persisting, and you can already see the progress it's making, and we are already expecting a new version every 6 months. So that means there is a lot of force being put on there. And the platform that we now have to develop on, like the Graal VM, and as Nicholas was mentioning, native image is bringing a lot of progress. That itself it's going to take a life of its own. So we don't know where all Java will go and what it'll become, because once it becomes a native image, is it Java? It's debatable. I mean, you can say there's some Java in there because there's still a garbage collector and a very tiny JVM running inside a native image. But then there are many such innovations and developments that will happen that will make it hard for us to, as Nicholas says, come up with even conjectures and prove that it's going to be right.
I think I remember predicting back in 2005 that XML is going to be the center of all application integrations, and I'm happy I'm wrong. I think what's important, or as an alternative, what we need to look at is how our technology is evolving to the demands. Slowly, we need to take smaller risks and keep embracing new things or keep experimenting with new things. If we don't take small calculated risks over a period of time, I think that is the biggest risk we are taking.
It seems this is the last question, so whoever hasn't stepped in with their last words, please do, and so we can close off and wind off really quickly. Werner, did you have to say something? You didn't say anything.
No,
I think it's time
can you
for
repeat the
time
question?
off.
Because I have a better connection than Iva and Iskren, but I do sometimes see the questions up to 10 minutes later in the chat. Last time Nicolas answered one, I saw the actual question probably 5 minutes later. So can you repeat the last question? So I'm sure
Yeah,
that I either
the question
overlooked
is,
or I didn't see it.
question is, how do you see Java, the Java ecosystem in 10 years? It's a common interview question.
Ah,
That
now I see. Yeah.
Yeah, I just
So,
repasted that question again.
well, I definitely think that Java is here to stay. If unless there's any giant big issue coming out of a Supreme Court decision next year, but hopefully, at least looking at some of the decisions they made around the election, not all of them seem to be always exactly as tragic as some people had feared. So let's see how it comes out. But unless any of that was to completely derail the participation of some of the major players or kill or stifle the Java community process, I guess both Java and the JCP are likely to exist for at least another decade or more. So we'll probably see the JVM maybe even exist and evolve longer than that. But at least for the next 10 years, I definitely see Java still around. The popularity may shift in some cases between Java, JavaScript, C, and a few other newer languages. But I definitely think it's going to be around at least for another decade or even more. So if you look at C and C++, especially, some of these languages are 50 years plus old in a few cases, and I guess so. With 25, Java is only half that age. So I'm quite confident that it will also be important enough, at least for another 25 years.
Okay. All right. Good words from Werner. So that was the last question. I think everybody got to chime in into that last question, and we more or less agree with where we think Java will be in the next 10 years. I mean, we could also be wrong, as Nicholas pointed out. So let's hope for the best and prepare for the worst. So with that, I have been given the task of closing this discussion. Thank you very much for all the speakers, and especially the organizers, Eva and her team. I think it's they've done massive amounts of hard work in bringing this conference together, and this happening for the next couple of days now. And thank you very much for being here. And enjoy the rest of the sessions today, and hopefully see you for the next discussion that will take place in a couple of hours from now, or an hour from now, actually. All right. Thank you very much.
Thank you.
Okay.
Take care. Bye-bye.
Thanks,
You too.
folks.
Bye.
Have a good day.
You too. Bye.
You too.
Hi, folks. Welcome to this talk about easy improvements in your microservices architecture. I'm Nicolas Frankel. I've been a former developer, team lead, and architect. I started my career 20 years ago, and for like 18 years of them, I those roles. And now I'm a developer advocate, and I'm quite used because I was a consultant to enterprise tax. I work for a company called Hazelcast. Hazelcast has two products. The main one is an in-memory data grid, and I will talk about the in-memory data grid in this talk because I will use it. And the other product is Jet, and it's a stream processing in-memory engine so that you can manage your data, transform it just like you would be, for example, for Java 8 streams, but distributed over the network. Microservices. Who doesn't do microservices? I guess a lot of you do microservices. And in general, the problem is that those microservices initiatives, they are driven by technical considerations. So here is the definition of microservice architecture. It's not from me, it's from Martin Fowler. So if you disagree with this definition, please bring it up to him. But since it's a good reference, I just copy-pasted this point. And you can see that you can, if you already have a microservices architecture, then you probably go from one step to the other, and you say, yeah, check, 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 check. And you see the 8th point is organize your microservice around business capabilities. Now, it's different than just technical stuff. You can still check. The last point is about products and not project. And I believe this is one of the main issues. A lot of people want to say they do microservices, and again, they see it from the technical point of view, but microservices are an organizational solution to an organizational issue. And in general, if you just manage the technical stuff, you are not doing microservices, which is fine. I mean, you don't need to have microservices on your resume. And the last point here is product and not project, and the difference being that projects that have start time and they have end dates. And between these two dates, you need to spend some budget and to deliver some functionalities, where our product, it's the same, but the budget is probably yearly, and of course you still need to deliver something, but there is no end date, so it goes unlimited in time. And when I do this talk on site, I ask, hey, who is doing microservices? At the beginning of this slide, probably there are 50% of people who tell me, yes, we are doing microservices. And when I describe this issue that it's about product and not project, then at the end, it's probably 1 or 2 people in the room, whatever the size of the room. Generally, it's a 50-person or 100-person size room, and yeah, only a few of them are organized around products. Again, it's fine. You don't need to do microservices. You can just do like service-oriented capabilities. That's perfect. But since everything is about microservices, that's also in the title of my talk, it's just to attract you, to trap you. Let's talk about one of the benefits of microservices. And promoters of microservices, they say that, yeah, one of the benefits of microservices is scalability. So imagine I always use the same example of an e-commerce shop. And an e-commerce shop, you will probably have like a catalog browsing service. You will probably have a checkout service. You probably have a cart service. You probably have a payment service. And since an e-commerce microservices architecture like implements a shop, then there is a sales funnel. So you will have a lot more people using the catalog browsing service than the payment service. And if you have a monolith, if every one of those capabilities, they are in the same deployment units, and you want to scale according to the most used capability, which in this case is the catalog browsing one, then you will need to duplicate your whole deployment unit, your whole monolith, just because of the scalability issue that you encounter on the catalog browsing capability. Whereas if you have separate deployment units for each capability, then you can scale them accordingly, and probably the catalog browsing capability needs to be scaled much more than the payment one, because a lot more people will be using the first than the later. Makes sense, I hope. And this is also a joke that I do in general. Of course, here it's less interesting because I cannot see the look on your face, but on the left you have a UML diagram that describes something, and on the right you have the same UML diagram. And actually you can say, yeah, on the left it's a UML diagram for an API call, and on the right it's a UML diagram for a microservice, or at least a HTTP service call. And yeah, from a design point of view, from like an abstracted point of view, they are both the same. An architect will say, oh, you know, we just do the data diagram. I can tell it because I've been an architect. We just do like the boxes and the rows, and it's up to the developers. It's an implementation detail. But actually, it's very wrong. It's not only an implementation detail, it has huge consequences. So it's an implementation details, but it has huge consequences on your performances. Because once you start like going outside your JVM, when you start doing network calls, then your application becomes a distributed system. And the problem of distributed system is, first, they will be slow. Anyway, they will be slow. So if you start having performance issues and you say, great, I will just like migrate to microservices and now I will be able to scale horizontally, you are in for a rude awakening, because you will actually decrease your performances. I mean, it's not hard to understand that if you make a HTTP call, it might be 2 or 3 orders of magnitudes longer than a call inside the same JVM. And probably you know about those fallacies of distributed computing if you don't know about them, but even if you know about them, it's very good to just print that and put it in your office, or now on your door, in your like private office at home, if you have one, or where you work, because that's very easy to fall into this trap that, yeah, we do a distributed call and everything is fine. The first point is the network is reliable. You make a call inside your JVM and it has 2 outputs. Well, you get the result, or you've got an exception. And in both cases, you know how to handle that. But the problem is, if you start doing HTTP calls, then you can make a call, and of course you can get the results. Of course you can get, well, not an exception, but an error message, an error payload. But what can also happen is nothing. So you make a request and you will never get the response, or the response will come back too late. And the hardest problem is that if you make a request and you will never get the response, is you are not even sure that your request reached the server and it's starting doing its job or not. And that's the problem with the network. It's not reliable. As I mentioned, latency is not 0 and blah, 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 and so forth and so forth. So now you can see that my nice diagram that I just used before becomes much more complicated. And because now we understand that we have a lot of layers between A and B if you are using the network. And it can be like layers in your application, it can be layers on the network, and it can be ISO layers, it can be a lot of stuff. And it's even worse than that, because now we must also get the response. So that is really what you need to design. And at every layer, of course, it can fail, it can succeed, or it can be just lost. So because we are in this world where we don't know what can happen, we need something that needs to be reliable. And the issue, as I mentioned, is if you make a request, you have no response, can be a problem. Imagine you have a customer, commerce shop, he has put everything in the cart, he has gone to the checkout page, he has entered his payment details, and just before that, you need to do some pricing, just to be sure that the price is correct. You cannot just say that the pricing microservices fails and the customer is left hanging. I mean, that's the worst you can do. In e-commerce, you need to sell. So the idea is when you get the prices, and probably it will work at some point in time, well, at least I hope for you, because if it doesn't work, it never works, you have other issues. If it works at least a couple of times, the majority of the time, we will keep this data locally. And so if the next time we try to get the data and we don't receive an answer, a response, then we will just read the data from the local cache. So that's something to understand. Caching is helping a lot, but you're making a trade-off. You're making the trade-off that speed of accessing the data is actually more important than the data to be up to date. And most engineers, including myself, we don't like that. We say, no, we want the exact data. But then you come to the business and you ask them, hey, do you prefer to sell at a slightly wrong price or not sell at all? And yes, the idea will be that they will probably want to sell at all costs. And of course, even if the price is slightly wrong, it's not that important because, of course, sometimes you might sell a bit lower, sometimes you will sell a bit higher. So at the end of the day, it will be averaged anyway. But that's very important to understand. If you want to make mathematical computation, caching is not good, well, in most cases. If you want to improve your performance, then caching is good. And of course, you know that there are two hard things in computer science, cache invalidation, naming things, and off by one error. So that's an issue. Caching is hard. I mean, cache invalidation is hard. If you are like me, if you are an engineer, and you probably wanted to use cache at some point, you probably thought about using a hash map, and you used a hash map. And that's what I did, but it's really, really bad. Why? Because the problem of the hash map, it has no limits inside. So you put stuff in your hash map, it grows and grows and grows. If you put enough stuff, you probably get an out-of-memory error at some point. So please, if you want to use a cache, if you want to use a hash map as a cache, don't do it. That's the first service you can give yourself. You just use a professional caching solution. It can be Hazelcast, it can be another one. I don't care, but please just make your life easier. So now we use a professional caching solution, and not only does it able to set a limit so that the hash map is bounded, but actually there you can probably plug and play an eviction strategy. So you have a limit and you have reached the limit. So you have put every item you needed into your hash map, but there is still one more item that needs to go into it, and the limit has been reached. So which item do we remove from the hash map? So that's where an eviction strategy comes in. And an eviction strategy tells, hey, which item do we remove from the hash map? Is it based on the least recently used? Is it based on the least frequently used? Do we have some additional priority metadata that we want those items to stay more in the cache than other? It's up to you. Again, professional caching solutions, they all provide something for that. Also, when you want to put an item into the cache, probably you don't want it to stay there forever, because at some point you want, for example, the price to be refreshed. So the idea is to say, how long will the item stay into the cache? So that every time you put, you need to attach it a time to live. And there is a background thread that wakens at a regular interval and say, oh, it has lived too long, I remove it from the cache. And that's where an in-memory data grid comes in, because an in-memory data grid is just like distributed data structure over the network, so as hash map, queues, list, whatever. We've added power, because distributed compared to local means that you can do some replication, so that if you have one single JVM, you have your cache, for whatever reason, the JVM crashes, the cache is gone because it was in the memory. Now, if we replicate it over several nodes, then we can guarantee that there are at least X, Y, or Z nodes that contain the same data. Another capability of an in-memory data grid is that you can actually shard the data, because perhaps the data is too too big to store to fit into a single JVM, even if you have a lot of memories. So you will need to short across several JVMs, and you can have both. So you can have like shorting and replication. So this is the benefit of an in-memory data grid compared to a local cache. And in a microservices architecture, we can use cache in a lot of different places. So here is a choice of three. First, database access. Second is HTTP calls. And third is session data. So let's see how it works. First, I believe that if you are a Java developer, even if a junior one, you have been probably, you know about Hibernate. Even if you don't like it, even if you don't use it, you probably know about it. And Hibernate make the mapping between your objects, your classes, and the tables and the rows. It's super widespread. It's so widespread that it's a GPA implementation, that it's the default implementation in Spring Boot, for example, if you want to use GPA. And Hibernate has two caches, two levels of caches, and they are named, well, without any imagination, level 1 cache and level 2 cache. And the problem is that the level 1 cache is implemented by default, so you get it for free, but it's bound to the session object. How does it work? Every time you will do something, like get the data or whatever, then you will like use this cache, which is good. The problem is this session object is probably very short-lived. Like if you are using a web framework, what generally happens is you make an HTTP request, you've got your filters, whatever, and you've got the session factory that is, I don't know, a bean, for example, in Spring. Then from the session factory, you get the session object, you do the request that you wanted to do. Now you create the HTTP response, and your session is gone because the next HTTP request will recreate a session object from the session factory. So this is very useful, this cache. It's implemented by default, but actually you don't cache much. There is very, very low chances that you actually use the cache. The second level cache is actually much more useful, but it's not on by default. You need to enable it. And there are multiple integrations available. And how does it work? It's a read-through cache and a write-through cache. So read-through is very simple. If you want to load something from the database, Hibernate will look if the cache contains the key that you want to load. And if it doesn't contain the key, it will load it from the database with the value and put that into the cache. If it contained it, it returns the key and the value. And write-through is the same, but it's even simpler. It's just like when you update the database, you update the cache value. So let's have some demo. And here I've created a project. And there is something that I need to ask is how long do I need to talk? Because otherwise I will talk and talk and talk and talk, never ending. So please, I didn't check. Can you, Eva, tell me how long I can talk? Don't be afraid to tell me. I don't see the chat. So please, I am listening to you. So I've created a Spring Boot project here. It uses Spring Boot Starter Data GPA. It uses Spring Boot Starter Web. I'm using Hazelcast for the cache. I'm using the integration of Hazelcast and Hibernate. And I'm using the H2Database, which is an in-memory database. So that's pretty stupid. That's probably what you don't want to do in real life, but it's useful for me because everything is self-contained. My caching in memory, something that is read from memory, not useful, but again, very useful to demo it. So I have this person controller, and I can get all the persons, or I can get one single person by its ID. Then I have this person repository, and it just extends this GPA repository. That's the super cool with Spring Data GPA is I have a lot of default implementation that I've written for me. And I will start the application. And I will curl HTTP. Curl HTTP local hosts 8080, and I will make P1. So the first thing to check is that actually I have enabled the Hibernate statistics. So when I start the application, well, the Hibernate statistics are completely empty of anything. And that's how I want to prove you that it works. So now I make my first requests. Oh, it's D, it's not P. Here is my first request. And yep. How long?
Hello, you have 30 minutes.
30 minutes from now.
Yeah.
Perfect, thanks a lot. So here I have, nothing was in the cache. So actually I did some like SQL requests. There was nothing in the cache, so I have a miss. It did the request and there is a put. Now if I do it again, we can see in the log that actually I have a hit and I didn't do anything regarding SQL, which is pretty cool. That means that, yes, I read directly from the cache. And what is even better is because there is something in Hibernate called the query cache, we can query all entities, we can query all entities, and now everything is in the cache. So now if we check, for example, the third one, there is a hit, even though I never queried explicitly for the third one, which is pretty useful, I believe. Now, if you want to be even faster, right now we are doing read through. So every time it's synchronized and we need to go to the database. What we can do is we can remove completely Hibernate and GPA. You can only interact with Hazelcast itself. And then Hazelcast will have some kind of listeners to write or to read from the database. And you can make it async. Of course, async will make it like faster for you, but there is no guarantee about the data. So again, it's a trade-off. Do I want to be consistent or do I want to be fast? And where do I put the cursor? Second improvement, HTTP cache, which was my talk about the microservices architecture. You could say every time I make an HTTP call, I will cache the results. And you can do that manually, but actually there is a Java API for that. There is something called JCache. This is a specification, and you have multiple implementation. Hazelcast is one of them, but you have others. And the good thing is that the JCache is integrated with Spring. So again, my e-commerce architecture example, I want to cache the pricing in the checkout microservices. Every time I want to keep it. So let's have some demo. I will stop it. I will just use Git. So the first thing that can be said is here about the Hibernate example. The configuration is pretty easy. You just say, I want to use a second level cache. Other thing that you want to get all the data and put it in the cache when you do a query for find all, you use query cache. And here, this is the Hibernate configuration for Hazelcast. And the only thing that you need to do afterwards is to provide something called config, which basically tells Spring, hey, like here you see I put into the context a config object, and Spring will detect that, and it will create a Hazelcast instance out of this. So this is by default. If you prefer XML, we have XML configuration. If you prefer YAML, we have YAML configuration. So now I will showcase it. So I won't showcase it through JCache. I will directly use Spring Cache. So there is also an abstraction in Spring called Spring Cache. And what it can do is is you can use Spring Cache and say that the implementation of Spring Cache is Jcache and that the implementation of Jcache is Hazelcast, which basically makes it like too many layers to be really interesting. So what I do, I just say, okay, I will just use, like here, I will use Spring Cache and Hazelcast is also a Spring Cache implementation. So that's very easy. I have added another controller, and this controller uses something called a caching service. And the caching service like uses the person repository, and every time I do a get, it will put the entity in another cache called the service cache. So it's just a proxy controller, and this proxy controller like has a cache between itself, like the controller, and the repository. So now I will start this application. And I will need to query. So I need to remember that this is OR now. So I will query for R3. Now I am a bit of an issue because I want to prove you that there is some caching involved. So in all the rest of this code, of this talk, everything is free and open source. Here, what I will show you is not open source. It's free up to 2 nodes, and it's called the Hazelcast Manual Center. I hope I remember the context correctly. No NC start, NC start. It's 8081, not 81. Nope, it's P. I need to bind to a port that is not 8080 because by default it's 88. And now I can get here on localhost 8081, and I can log in. No, I don't want to set the password. And here we can see that we have 3 maps. We have the database one, of course, but I already showed you that it was used because of Hibernate statistics. And I have this new one called service one. And we see there is 1 entry. There was 1 get. There was 1 set. And now if we start like calling the same entity, after some time, we will see that there will still be 1 entry, but there will be 2 gets. And of course, there will not, the set hasn't been changed, but now there is 1 hit. And we can see also here the number of entities in this map. Now, I cannot do the same trick as I did before to have all the entities into the cache. Here, there is an issue about the Spring framework that is like tagged as onefix. And the issue is here, with those annotation, it's easy to say here, the key is the ID and the value is the person. But if we have the get all persons, then because we are not using Hibernate, there is no way to know about the form of the data inside the lists. And right now, Spring won't fix this issue, so there is no way to have like a find all, get every entity and get it into your cache, unfortunately, but that's life. And the final improvement is session data. We all know and love stateless applications, but unfortunately, most applications, they are not stateless. Most applications, they store something in the session. Like, again, with the e-commerce example, the cart in general is not stored in the database because it would be too long to every time there is a request to make a query to the database. In general, the cart is stored in the session and it's accessed instantly. And so because the application is not stateless, because we want our user to always be directed to the same node that has the cart in memory, then we have a load balancer in front, and the load balancer is configured with session affinity. So the first time there is a request, there is an association when here the Tomcat returns the response, then it returns as well a JS session ID. And so the load balancer in front associates the JS session ID with this specific Tomcat. So if there are subsequent requests, then they are all directed to the same Tomcat. And we are very happy, and it works as expected. It works as expected until Tomcat goes down, because again, we are using an infrastructure. Even if it's the best infrastructure in the world, Tomcat will go down at some point. And so if the customer gets back to here and Tomcat has been down, the load balancer will direct us to another Tomcat, which unfortunately has no session data, has no associated, so has no cards, and the customer will see his cart empty, and probably he will be very unhappy, and we will go to another e-commerce shop. So how do we solve that? Well, the idea is to replicate the session data across all nodes in the cluster, all Tomcat nodes. And if there are any standards, well, no, there are no standards in that case. So what do? Well, we have integration. Hazelcast can help you there. We have different levels of integration. The first is if you are not using anything standard, you can use a web filter-based integration. So in your application, you define a web filter, you configure it, and we will do session replication. If you are using already Spring Session, then you know about all I've told before, and Hazelcast is actually a Spring Session implementation, sorry. Or if you are using Jetty or Tomcat, you can integrate Hazelcast through configuration of Tomcat or Jetty directly, which can be cool because that means that during developments, the developer doesn't care that there is session replication. It's completely transparent to him, and it's the ops part or the DevOps, if you want to call them DevOps, that will do the configuration in production or in the environments that they need to do. Of course, if you are using Tomcat embedded or Jetty embedded with Spring Boot, you can also configure it inside the code, which I will be doing because it will be easier for me. So let's get to the latest stuff here. So I've added additional class. I have a session data controller, and the session data controller, every time it receives a request, it will use a session data handler, and I will show you what is a session data handler afterwards. This session data handler will actually get data from the session data stuff. It will read one attribute and it will increment it. So this is my session data handler, and I will check that I will have an existing session data object in the session, and if I don't have it, I will create it, and I will increment its counts, and I will put it again into the session. And session data is very easy. There is one stupid counter, and there is a string, an ID, which will be the G-session ID. And meanwhile, I will do I will try to deploy this application, 2 nodes application, on a Docker Compose file. Docker Compose file, there will be a load balancer, and there will be two Tomcat nodes. And because I don't want to switch off one of the Tomcats, what I've created is a HA proxy load balancer with a specific configuration. And basically, this configuration allows me that every request goes to one node, then to the other node, then to the first node, then to the second node. So I'm actually forcing the fact that there is no session affinity, that it will always be like round robin. And so if it works as expected, which I hope, because our demo that fails are already hurting to me, well, if it works as expected, I will go to the load balancer and ask, hey, give me session data. It will give me 1. And the second time, it will give me 2. And the third time, it will give me 3. If I didn't configure it correctly, if there is no session data replication, then I will ask the first time it will go to one node, it will tell me 1. Then it will direct me to the other node. And the other node will tell me 1. Then I will ask a third time, it will tell me 2, and then 2, and then 3, and then 3. So I hope it won't happen. So let's see how it goes. And here I should have stopped that. And now I will be doing this Docker compose up. So now it's starting the whole, well, infrastructure, even though it's very small infrastructure. Both applications that are starting, they are just like the application containerized. I containerized them through the G plugin, but that is not very interesting to you. I didn't create no Docker file. Now both servers are up and everything should be going as expected. So now I will go here and I will do local hosts, and I must remember that it's the load balancer and not section. Now count 1, and now if I refresh, it should be count 2 if everything is fine. Count 2, count 3, count 4. Yes, I have session replication. And how did I achieve session replication? I achieved session replication very easily. I just went to my main application, and here, as I mentioned, I will use this customizer to customize the web server factory. And I add a context customizer. So I create this Hazelcast object, Hazelcast session manager. Here, because I have explicit randoming, I set it sticky to false, but normally you shouldn't do that. And then I say, hey, I will use the Hazelcast instance that's already existing and sets the manager, and it's done. And that's the only thing that you need to do actually, which is pretty cool. Like in a few lines of code of configuration, we just implemented session replication. So this is what I wanted to tell you. As a reminder, please, there are a few key takeaways from this talk. The first is, please don't do microservices because you have performance issue. You do microservices because you have scalability issue in your organization and perhaps scalability issues regarding the technical stuff, and you want to scale horizontally. But you will lose performance at first. If you lose performance, then caching is fine. And of course, there is a trade-off, and the trade-off is data will be stale. So you need to think about, hey, how much stale do I accept my data to be? Hazelcast can help you in 3 different areas at least. Database access, we have integration with Hibernate. HTTP calls, we have integration with JCache and Springcache. And session data, we have integration with at least Spring Session, but you can also do, as I showed you, and do direct Tomcat customization. So thanks a lot for your attention. You can read my blog, you can follow me on Twitter, you can read more about Hazelcasts. If you are interested in the codes that I showed you, of course, you're welcome to do so. So here is the link to the GitHub repository. And if you want to know more about Hazelcast, or you are happy or not so happy Hazelcast user and you want to interact with us, please join our Slack. And so now is the end, and perhaps there are some questions. So I will just go back here and go back here and stop sharing my screen. And I will be happy to have your questions now. Are there any questions? If there are no questions, that's always a bit disturbing, because either it was a very good talk and it doesn't deserve any question, it was very clear, or it was very bad and you don't want to shame me publicly. So Stephen, thanks Stephen, I appreciate that. Stephen said that was excellent, so which is good. That's good feedback. So feedback is appreciated, even if it's not a question. But we still have a couple of minutes, so if you have questions, I will be happy to try to answer them. So I will count to 5. Would Hazelcast help with caching in conjunction with MuleSoft API environment? So to be honest, I don't know about MuleSoft at all. But Hazelcast is just a cache. So if you want to put something in the cache, well, we have API for that, REST API or Java API, or we even have C, C++ API, Go APIs, Node.js API, Python APIs. It's up to you. So if MuleSoft integrates with any of those, then you can use Hazelcast caching, yes. Nicoletta, thanks a lot. It was indeed very clear talk. Really enjoyed it. Thanks a lot, Nicoletta. I appreciate that. I appreciate your feedback. Bongo also, thanks a lot. Any more questions? No more questions, so I will count to 5. And if at 5 I don't have more questions, I will thank you a lot for your time, and I will wish you to enjoy the rest of the conference. 1, 2, 3, 4, 5. Thanks a lot. Have a great day. Stay safe, and yeah, enjoy your vacations if you have. Probably you have. And yeah, I hope to see you in person at some point in the future, even if it's near. Bye-bye. Yeah, enjoy your vacations if you have. Probably you have. And yeah, I hope to see you in person at some point in the future, even if it's near. Bye-bye. Yeah, enjoy your vacations if you have. Probably you have. And yeah, I hope to see you in person at some point in the future, even if it's near. Bye-bye.
that's amazing to be here again one more year. Unfortunately, this year virtually, but at least we can stay together somehow. Please tell me where you're from. So that's time to do interactions. Please put your name. Tell me where you're from. My name is Otávio Santana. I'm from Brazil, and right now I become kind of European. Today I will cover architecting cloud computing solution with Java. The whole scope of this presentation is to talk more about, okay, we have Java and we have cloud. How can we merge these two words in just one place? Okay, my Twitter handle is @Java, and I'm working right now at Platform SH. Basically, if you want to put your application smoothly in the cloud, you can use us. Platform SH is a PaaS, therefore a platform as a service, where you can put application that you wish there. So microservice, monolith, whatever you whatever. I'm Debbie Helm Engineer. My Twitter handle. I'm Java Champion, executive member from JSP, Apache committer, Eclipse committer, Eclipse product leader, and also on my free time, I write books and blogs about mostly technology. Therefore, yes, I need to have a more healthy social life. So let's begin. So today, as I mentioned before, we will gonna cover the both boards, right? And how can you merge in just one? Let's start first with cloud. What is cloud? That's a hard question because if you go to several articles, you're gonna have a different answer to that. But let's try to keep it simple. Basically, cloud is somebody else's computer, somebody else's server. Why did I say that? Basically, is when you are a soft house or you are a soft company and you don't care about keep or maintain hardware. Therefore, you're gonna take this hardware complexity and pay to somebody else handle that to you. That's why cloud exists to simplify any kind of service. Yes, we have different flavors of service, like we have different kind of pizza servers. And when I usually talk about cloud and this kind of service, I prefer this analogy because I love pizza a lot. And right now I'm close from Italy, so that's a nice opportunity to talk more and more often about pizza. And let's try to keep it simple. Let's try to do a analogy between pizza and cloud. Okay? The first one is when you decide to make pizza at home by your home. Basically, you need to prepare everything. You need to have the whole hardware. You need to have the whole know-how because yes, if you decide to do everything at your home, you need to handle the complexity and the risk as well. Therefore, cheese, topping, tomato, pizza, fire, oven, electric gas, and yes, finally prepare the table and the drinks. When you do need to do everything at home on the cloudish, that is traditional on-premise. Can we simplify that? Yes, we can. Let's move on to the right. Okay. In the pizza language, we have stay and bake. What does that mean? It's basically when you decide to go to the grocery, buy a pizza, and then return to your home. You don't need to handle the pizza anymore. You just need to put in the microwave, and that is it. We still need to prepare the table, you need to prepare the drinks if you want to, but you decreased the number of complexity when you go to this way. You don't need to handle the infrastructure. And the cloudish, that is infrastructure as a service, where you don't need to handle the hardware anymore. Basically, you have the hardware, and you need to, usually you have the system operation, and usually you need to put your software there. Sometimes you install Docker, install any kind of application that your application needs, database, firewall, this kind of thing. you still have complexity, however, lower than on-premise. Okay, and let's move on. Let's make it even simple. It's simpler. Right now we have pizza delivery. What does that mean? It's basically when I call or use any kind of application, Uber Eats, iFood, whatever you want to use, request a pizza. We don't need to handle the electric gas, microwave, anything. You just need to handle the dining table and the drinks if you want to. If you prefer, for sure, you can eat pizza while you are watching Netflix or something like that. My whole point here is you don't need to handle the pizza anymore. Yes, and there's a platform as a service. Basically, you don't need to handle the complexity of installation, the complexity of security. Usually don't need to handle with firewalls. You don't need to handle about upgrades, backups. Usually the whole thing is on your platform as a service, or it's supposed to be there. And the last one, in the easiest way to handle pizza and also cloud is dine out. For sure, we're not possible to do that right now, but you can imagine the future or maybe the past, like 2 years ago, where you can go to the restaurant. You don't need to handle anything, right? So you don't need to prepare the pizza, you don't need to prepare the table, you don't need to clean the dish after they eat something. You just go to the restaurant, sit down, order something, wait, eat, pay the bill for sure. Please do that. Try to, if you don't, try to run faster than the manager in the restaurant. Uh, and then you leave. Okay? The whole complexity belongs to the restaurant. And that's the whole idea of software as a service. Okay? Uh, the whole point here is everything has a trade-off. Because if you decide to go to dine out, less complexity, the blue point here is basically where you don't need to handle anymore. For example, in dine out, you don't need to handle anything. It's like your Gmail, right? In pizza delivery, you have less, more complexity than SaaS. And my whole point here is dine out is amazing because you don't handle anything. However, you usually pay more for that because when you decide to use software as a service, you're not using this just the hardware. You are using the knowledge to make everything done. You need to handle the software as well, and that's the whole trade-off about cloud. You need to choose. Okay, if you want to go do everything at home, probably it's gonna be cheaper somehow. However, you need to handle with more risk. You need to have the knowledge to handle that. You need to think about security. You need to think about where to keep the hardware. And if you go to SaaS, probably is a little bit harder to tune in or do any kind of uh, fancy configuration size. Usually you need to use what they offer and period. Okay, that's the whole trade-off that I'd like to show. Less complexity means less risk, and more abstraction, and probably gonna pay more for that. Okay. Finally, you discussed about cloud. What does that mean? Finally, yes, there's a huge discussion about around buzzwords because in the past we had cloud friendly, cloud ready, and right now we have cloud native. And there is a huge discussion where my friend Karin and I did a discussion in Joker conference that was like 1 month ago where we explained about the history about cloud. Right now, I will just focus on cloud native. Cloud native is a new term, and if you go to several articles, you're gonna have a different approach, different buzzword, different terminology. Please let me show to you these different kind of topics. Okay, the first one is cloud native from Pivotal. Cloud native is an approach to building and running applications that exploit the advantage of the cloud computing model. The next one is a book, Architecting Cloud Native Application. Cloud native is a different way of thinking and reasoning about software systems. It's embodied the following concept, and it talks more about infrastructure, is where you don't need to handle the whole complexity of operation. You need to embrace the idea of use infrastructure as a code, GitOps integration, and so on. The whole point of this book, the definition of cloud native from this book is, okay, you finally embrace it globally. You can scale easily thanks to automation on the operation side. Let's move on. From InfoWord, cloud native is more about how the applications are created and deployed, nowhere. It looks like when you take more advantage of this kind of model, when you go deeper and deeper on the cloud. Okay, that is cloud native from InfoWord perspective. Let's move on to the next one. This is a book, Cloud Native Development Partners and Best Practice. And from the author, Cloud Native is more about tools, deploy, update, replace, and scale. It's more about operation than software development. And that's fun because to this book here, Cloud Native is more about methodology. When you finally insert cloud in your whole methodology. If you think about the whole history of the software development, in the past we had waterfall, where you need to handle everything in your home. That's included deploy. Probably that's why we take at least 1 year to deploy. You have a deploy window that is forbidden to use Friday because deploy on Friday is forbidden. It's terrible. It's not good idea. Right now we are living in the agile methodology where you can do more often deploy instead of just once in a year. You can do more like twice, 3 times in the week, much more faster. And the next generation is cloud native transformation. So it englobes architecture perspective, operation perspective, methodology perspective, management perspective, and yes, operation perspective. So cloud native from this book embrace everything around the software development. Okay. Finally, we have the cloud native from Cloud Native Computing Foundation. Cloud Native Computing Foundation is an organization. It has several huge companies behind, and they are working to keep and maintain several amazing projects. I can tell you Kubernetes, I guess, belongs to Cloud Native Computing Foundation. I'm not sure about Docker. Today, Cloud Native is more about a soup of buzzwords where they said some samples like containers, service mesh, microservice, multiple infrastructure, and declarative APIs to this kind of approach. However, when I usually say this approach, my question is, how about monolith? It's not possible to use Cloud Native with monolith? I don't think so, right? Because microservice is not a silver bullet. Therefore, you can use different kind of approach. That's why I usually don't recommend this approach from Cloud Native Computing Foundation. However, they are relevant. and I guess it's important to say their opinion about the cloud native approach. Okay, I went through several articles, blogs, books, and usually that's a common answer about what does mean cloud native. And usually in general, you're gonna see something about, okay, if you create application that is native in the cloud, that is based on the container, congratulations, you finally have a cloud native application. My whole point to you is it's uncertain. What does cloud native mean to us, to the whole IT community? As you saw, I went to several articles, several books, and several companies as well. And each one has your own opinion about that because it is a green area and everybody is working right now on this. I create my own definition about cloud native that I'm using right now. However, I'm still reading about it. I'm still working on cloud native, and probably it's gonna change next year. I'm not sure. Probably yes. And to me, right now, at this moment in December 2020, cloud native to me is a set of good practice to optimize your application, an application through the cloud, through 3 points. Actually, the most important points are containers, orchestration, that's where you're gonna handle the containers, and automation, where you're gonna use infrastructure as a code to automate everything. You're gonna put this script of deploy on the Git and so on. Okay, that's my definition about cloud native. However, as I mentioned before, there is a amount of cloud native. My recommendation to you is go and use wide words, read articles to take your whole opinion about that. Containers and Java. I like to say that because there's a huge relationship between container and Java. First, uh, Java is package owns running time. Oh, sorry. Container is a single unit of your application. Therefore, it's a package owns running time. And Java was born with the approach of, okay, I will create application that's gonna run anywhere. That's why we have water right on running time anywhere. Okay, let's go to the next step, and that is best practice. However, if I'm not sure about the cloud native approach, what does cloud native mean? How can I be sure about the best practice inside cloud native? Indeed, we don't have. We're gonna use the old and gold practice. The first one for sure is the 12-factor application. Yes, the 12-factor application was born first than cloud native approach. It's based on the Martin Fowler book that is partner of enterprise application architecture. The whole point here is to explain to you the 12-factor application, the 12 commandment, where you can have a good and a safe and a health application to avoid any kind of nightmare in the future. For example, I usually explain to you use the first three. So code base. Please don't use code base as don't put your code base in the zip code and then send by mail. Please use any kind of source repository management, such as Git, Mercurial, maybe SVN. Right now, the most popular one for sure is Git, perhaps because the GitHub. Dependencies, please put your dependencies outside your code repository. You have several managed build applications. In the Java world right now, we have Maven, Gradle, and so on. If you are PHP, you probably have, I guess, Composer. If you are Python, you have Pipe. JavaScript, NPM, and so on. The whole point is don't put dependencies inside your code base. Configuration. Please don't put credentials such as user and source and password inside your code. You have one good and easy way to make that possible, thanks to configuration. If you think about Eclipse microprofile, you have one specification that is Eclipse microprofile configuration, where you can override the whole configuration. My whole point here is you as a developer don't need to even know about the user and the password of production. Okay, again, you as a developer don't need even to know about the credential on production of your database or any kind of critical information. And yeah, we have more practice here. I don't want to go deep on that because that's not the topic today. But my whole point here is you can take advantage of the good practice. Okay. And let's move on. Right now, I have 4 amazing books. The 3 one is recommended if you are a developer in general, and if you are a Java developer, you need to take the 3 and then the effective Java. The first one is Clean Code. This is become popular because it's tell you how to write a readable code. And then Clean Architecture, where we explain we know Robert Martin explained about one good way to you split your application and infrastructure in what matters to you. When he said about what's matter, you think about your business perspective. Okay. DDD is domain-driven design, where you need to put your code closer and closer as possible to your business. For example, if you have e-commerce, please, you're probably gonna need to use car, order, nt, user nt, and so on. The effective Java right now it's a 3rd edition where you can go deep on the Java good practice such as collection, how to use lambda, magnifying factor, when and how, enum, singleton, and so on. Okay. There's a huge discussion about microservice. Is microservice a silver bullet? And to be honest, I don't think so. Right now we have a couple of solutions, but there's not a silver bullet solution to us in IT area, at least right now. Okay. My whole point here is we have several books. For example, Sam Neiman, he has 2 books about microservice. One migrating, one about introduction to microservice. And in both books, he has an intro when he explained when you should not use microservice. Okay. And also, I have this book here from a friend of mine, Ed Soyanaga, who explained the migration microservice database. And he has a cool approach. He said, okay, just because Netflix and Amazon you use microservice, that does not mean that you need to use microservice as well, because you are not Netflix and Amazon. There is an amazing tweet from Edson Moraes, also a friend of mine. He said that based on Calvert's law, microservice is about scalability of people, not about application itself. My whole point here is monolith is still one. There's nothing wrong if you decide to use monolith in any kind of application. Okay. I explained to you cloud native, and let's go to the Java cloud native. What's going on? Let's try to merge these 2 words, Java and cloud native. First, what's going on to make Java even close to the cloud native perspective? The first one is mandatory to say for sure is the JVM, because right now we have several optimization of the garbage collector. We have an incredible improvement on containers and to make better and better integration. And yes, finally you have 6 month release each 6 months, therefore twice a year. What does that mean? Instead of you wait like 3 years to get a version of Java, right now you have the option to take one Java version every 6 months. Oh, Tav, that's too fast to me. Don't worry. Uh, Java, the OpenJDK works with LTS, long-term support. If you are an Ubuntu user, you probably know about it. But if you're not, don't worry, I'm going to explain to you briefly. LTS, long-term support, is a version that you can have support to at least 2 or 3 years. The last LTS was Java 11. Before that was Java 8. If you want, you can keep with Java 11 until the next LTS version, probably Java 17. And then you can keep with Java 17 until more 3 years to the next LTS version. Okay, so go LTS to LTS. On the specification word, we have Jakarta E. Jakarta E, if you can think about the history of Java E, is generation number 4. The first Java E generation was when they decided to put everything inside the JVM. That's why we had COBOL, we had XML processor, we have web service API inside the JVM. That you can say the generation number 1, the first generation. The second generation was when the Sun decided to put this kind of environment outside the JVM. That time was born Tomcat, any kind of servers. That is the second generation. The third generation was when Sun was acquired by Oracle. The time was the Java EE6, where we had CDI. And the last generation was when Oracle gave the whole code to Eclipse Foundation. Okay, and we got a new name. Right now it's Jakarta E instead of Java E. It's under the Eclipse Foundation umbrella. The whole point is to make agile methodology. Therefore, instead of wait like 2 years, 3 years to one single version, we're gonna have a version every year. Okay, and the whole scope right now is to deliver our Jakarta E application through make easy to you as Java developer delivery cloud native application. Besides Jakarta E, we have Eclipse microprofile. That's a small piece of Jakarta E. Say briefly, is much more than that. But just to summarize, we have Jakarta E. We take a small piece of Jakarta E where we have CDI, JAX RS, and JSON bind. And based on these 3 APIs, we create several frameworks and API to work with microservice. Microprofile is under the Eclipse Foundation umbrella as well. It has the same idea of agile methodology. So every quarter, usually it has a new version of Eclipse microprofile. Yes, it is faster than Jakarta E. Okay. Yeah, that's amazing. I need to update this slide. But right now, Eclipse Foundation is offering Jakarta E9 instead of 8. And microprofile is coming up to Java version number 4. And we have a couple API to make the Java developer life even easier. So open tracing, open API, REST client configuration, fault tolerance, metrics, JWT propagation, health, CDI, and so on. So As I mentioned to you before, the first line here with CDI, JSON-P, JAX, RS, JSON binding belongs to Jakarta, okay? A small piece with more APIs focus on microservice. And yes, both platforms are working and they are growing up. So we have released Jakarta E9. There is a huge amount of work inside the Jakarta E10. Okay, let's go to the demo time. Let me check how long time do I have. Okay, I have 30 minutes. As I mentioned to you before, okay, let's close here. Cloud Native Foundation provides to us a huge amount of solutions. So you can take a look here. That's Among Us, right? So right now it has 1,550 cards with a couple of solutions. So we have database, stream message, application definition, image build, CI, CD. My whole point here that I usually want to show is Cloud Native is much more than Kubernetes. Okay, we have container runtimes, and as I can show to you right now, containers are much more than Docker. Okay, that's my whole point to you. And as I mentioned to you before, Cloud Native Cloud has different kind of flavors and or types where you use service a definition. As you can see, you have tools to make you to handle everything by your home on the premise. You have Kubernetes because if you want to run it on infrastructure as a service, that's up to you. You have PaaS, a platform as a service. There we have a couple of solutions, and I'm not sure. Yeah, we have Kubernetes certified service providers as well. Service mesh and much more. And yes, we have platform as a service. That's include the company that I'm working right now. That's a platform.sh, where you can take a look here. That's their website. And we have a couple of solutions. Don't worry, that shall link to you if you want to know more. The whole idea of the platform SH is to decrease you the complexity. So let's take a look here to any kind of GitHub project. So I can go to the GitHub. Okay. 1 second. Let's take the link here. GitHub platform sample. Platform templates. If you want to run, for example, Quarkus, you can run with a single click button. For example, here it's my GitHub project, right? That's my .xml. As you can see, I don't need to put any kind of new dependencies to avoid the vendor lock-in. It's basically Quarkus dependencies. As you can see, Quarkus, REST Easy, Quarkus with the Unit 5, REST Assurer, Quarkus Maven plugin, and so on. And basically what you're gonna do is deploy my application with a single click button. Hello, Java2Days. And yes, if you want to, you can choose the region that you want to use to select. In this case here, I'm gonna use United States. But if you want, you can use Europe. You can use a huge number of options. So basically, I click on deploy my application, and it will build my application based on that GitHub repository. Why? Basically, Platform SH is a cloud native solution where you can put everything in just one place using the infrastructure as a code approach. Okay. While it's building, let me show to you one more way to build your application. For example, if you want, you can go here to platform message and create your first product based on the template. So Java2Days Spring. Just show to you that's possible. United States. This time here, I'm gonna use application from template. You can use the language if you want. So .NET, Elasticsearch, Go, Java, Node.js, PHP, Python, Ruby, and so on. Let me use Java because I'm a Java developer. And I'm gonna choose for sure because the name is Spring. So how we create a product that is Spring with Spring MVC, MVC, and Spring MongoDB. Okay, let's wait to build. It's built, and as you can see, it's based on Git. I push from the master. It's building my application, and as you can see, I have two containers. One to define the halt, and another one to define my application itself. I have my URL to access. I have my Git repository if I want to, but if you want, you can use just a Git. You have integration with GitHub, GitLab, Bucket, and so on. And yes, you have the access by XSH. You need to configure to have access as well, but there's nothing different than usual, right? So security matters. As you can see here, right now it has 3 containers. One to define the host, another one to define my application, and the last one is my database itself. Okay, let's wait the build. Why does that happen? Let's show to you why I usually talk about platform SH when you talk about cloud native. Because the whole point of platform SH is to decrease the number of risks in your application. Because, okay, yes, you have the option to do everything by your home, but you need to handle the whole complexity. Complexity is cost and sometimes it's risk. Because when something goes wrong, you usually don't have anybody to help on that. Okay? You need to think about that when you need to choose between the service. And a huge challenge today is because cloud is so complex. You probably saw several presentations around Kubernetes, Docker. Those are amazing, but how about database? Do you still need to handle with database, right? Is container a good way to handle with database? If so, how to handle with backups? I mean, there is a huge complexity that usually nobody tells you when you go through the cloud, okay? And the whole point of platform SH is to decrease this kind of complexity in a cloud perspective. And it's basically a polyglot multi-cloud PaaS, platform as a service, with CI/CD, and you have support to any kind of architecture decision. So if you want to run monolith, microservice, stateful, stateless application, go for it. We have support. We have support to several languages: Python, PHP, JavaScript, and so on. As I mentioned before, it works with infrastructure as a code. Okay, you want to use MySQL, Postgres, MongoDB, whatever you want, don't worry. You're just gonna put that on the file, a service file that I'm gonna show to you soon, and that is it. You don't need to handle anything else. You don't need to handle with backups. You don't need to handle with how to upgrade my service to anything else. The whole complexity belongs to the cloud providers. In this case, platform as a service provider, platform as SH. Okay. As I mentioned to you before, basically you need to handle 3 files to build your application and platform SH. The first one is my application file, where we have a couple of configuration in just one file. As you can see here, I need to set my name, my type, in this case, my language and the version, my disk space, how to build my application. As you can see here, I'm using Maven Clean package. The relationship, because security matters to us. The whole point here is make sure that my application has granted access to a database. In this case, a Postgres. And the last one is my command to run my container. In this case, is Java/jar, any kind of Java configuration, my credential to override my user, my database, my password, this kind of thing. If you remember, right, as I mentioned before, the 12-factor application, the configuration is something important because on the real world, you as a developer don't need to know about user and password. Service. The whole idea here is to, okay, you define the name, you define the type, the version, and the disk space. Oh, Tavan, right now I want to do the upgrade. Don't worry. You change the version, push your code, and that is it. It's gonna do an upgrade to you automatically. If you want to, you have the option to create a branch, push that branch, activate this branch to test your environment. If everything is okay, you can merge this branch. My whole point here is if you want to have like 3 environments, a production, a staging, and development, that is it. You have one branch to each environment. If you want to, each developer has your environment, that is it as well. Just make sure that each developer has your home branch, and that is it. It decreases the whole complexity. Okay. Again, application to define the configuration of my application, the service that my application needs, such as database, cache, queue, and so on. And the root is the last one where you define the root where your application is going to be public. As you can see here, I use my default URL to deploy my application through HTTP. And that is it. The whole point is platform message is going to handle everything, and then you can rest. Here is just the overview, the web console, the integration with API. You have CI if you want to have such operation. We also provide app runtimes with a couple of languages: PHP, Java, Node.js, Go, Python, Ruby, C#, and so on. We provide several services such as MySQL, PostgreSQL, Kafka, Redis, Solr, Atomic, Elasticsearch, MongoDB, Memcache, and so on. Okay, and we orchestrate the service to you. We have the continued deployment. Therefore, if you push the master, push to the main branch, it's gonna build the application to you. And as a pass, we have support to several infrastructure as code as a service, where we have support to Amazon, Google, Microsoft, Orange, and so on. That's the whole idea of the platform message. That is GitOps. Basically, everything that your application needs, the configuration that your application needs, goes through Git, and you have the integration with GitHub, Bitbucket, and so on. And right now, platform message have over 1,000 clients. And the most famous are The Economist, British Council, Unity, and so on. And yes, we have support to several Java frameworks. So Helidon, Micronaut, Quarkus, Microprofile, Turntail, Spring, Maven, Payara, Tomcat, Wildfly, Cradle, Maven, and so on. And if you want to know more, if you want to get the links, the reference, here you go. That's your time. So you have the QR code here. Please take your phone, take a picture, where you go to a link where you have a couple of references about this presentation, the sample code, and also how to you build application easily in the cloud. Okay, if there's any question, please let me know. Okay, my application finally is built. Let me check here. Finally, I have my user. Let's use here Java2Days java@gmail.com. Let's add the second one, Otavio@gmail.com. Finally, I have two. If I want to, I can play with backups. And that is it. Yeah, I did one from, okay, right now it's building my backup. As you can see, I have the option to see the logs. I forget to say that to you. Let's go to overview here. I have my build. Let me show to you. Basically, it's a Maven project, right? Therefore, I will download the whole internet because it's Maven. Okay, let's check the question. Really interesting lecture. Thank you. That's my pleasure, Flamen. Actually, can platform message be integrated with Microsoft Azure? Yes. You have the option to integrate with Microsoft Azure. If you have any kind of application in Microsoft Azure, you can run with platform message if you want to. That is not a big deal with that. Okay, this one here is the Quarkus, right? Where we build a deploy based on the GitHub. This one here is my backup. I did my backup, and then I can delete my whole information. Okay, right now I don't have nothing in my sleeve. And let's do the restore. Let's restore the application. Just to show to you, because usually nobody tells you about backup. And yes, backup still matters on the cloud native perspective. And yeah, they're still using database on the cloud native. But my whole point here is you have the option to decrease the complexity with platform message. Basically, it's gonna close the connection for a while. You're gonna have the option to do a backup where we don't stop the service. But right now we are looking for consistency. Therefore, we request you close your application, do the backup, and then start up your application. But soon, probably next week, you have the option to, if you don't want to stop your application, you have the option to unsafe backup if you want to. Okay, it's loading by the backup, and soon you have the option. But my whole point to you here, just say that's a huge word around cloud native. Please let me know if you have any questions. So let me share to you the landscape cloud native link.
Attila Hairula has a question whether platform message can be integrated with Microsoft Azure.
Yes, you have the option. You can run your home application if you want with Azure. Okay, as I showed you on this slide here. So right now, platform message is a platform as a service, right? So it needs infrastructure to handle that. And right now we have support to Amazon, Google. Oh, come on, Amazon. Okay, wait. Amazon, Google, and Microsoft Azure in orange. But if you want to, there's no big rush if you want to use Oracle Cloud with platform message. If you have any kind of application in Microsoft Azure and you want to have another one in platform message where you can integrate those, that is no big deal because you can do this kind of security to organize your application. But yes, you can run your home application at Microsoft Azure at platform message. Okay, let's check if the backup is over. Okay, the backup is over. Let's check here. Let's refresh. Oops, something goes wrong. Let's check what's going on here. It is starting. Hopefully, okay, it's starting. Basically, as I mentioned to you before, it will stop my application, do the backup, and then start my application again. The restore is basically something you have the option to do that. If doubt, stop your application. In platform message, we call that of unsafe backup restore. That's on you. And if you want to, you have the option as well to upgrade the database if you want to. As I mentioned, you assure the backup, and that is it. So if there is no question, thank you. We also have the Deploy Friday on YouTube. Follow us, and we have Twitter handle that is platform message on Twitter. And thank you. Hopefully you enjoyed this presentation, and see you soon. If you don't, I wish you a happy new year, and stay safe, stay at home.
Thank you, Tavio, for your great presentation.
That's my pleasure. Bye.
Bye, everybody.
Okay, hello and welcome to this session. This is how variant analysis helped secure the fight against COVID-19. My name is Álvaro Muñoz. I'm also known as Pwn Tester in Twitter and GitHub. And I'm a staff security researcher with GitHub, specifically in GitHub Security Lab that I will describe later. So apparently I'm having some problems with the camera. I don't know if you will be like switching, the camera will be switching between the camera and the avatar. So I will just disable the camera, probably because I have a weak connection, and I will connect it later for the Q&A session. So also I will be checking the chat and the question tabs from time to time. So feel free to interrupt me and ask any questions about the presentation or anything else. So back to the presentation. Hopefully today we will learn about what variant analysis is, and also how you can perform variant analysis using a language called CodeQL. In order to learn a little bit about CodeQL, we will be writing some simple queries, and also we will be writing a simple query that was used to find this remote code execution vulnerability in this software that backups the Corona Warn app, which is the German application for contact tracing. Okay, so let's get started. I don't know if you can see the presentation. Let me check the chat window again. Can you write something if everything is okay, the sound is okay? Should I start? Apparently there is like 15 to 20 seconds delay. So I will wait a little bit to see if any messages appear in the chat. Okay, good. Thank you. So let me go back to 2012. That year, if you remember, the Curiosity rover was on its mission flying on its way to Mars. So that year, NASA JPL, which is the Jet Propulsion Laboratory, did some kind of code review of the software, the programs running the Curiosity Mars, and they found a very critical bug in the module that was responsible for the entry, descent, and landing of the probe that was carrying the Curiosity rover to Mars. So this piece of software was written in C, and it resembles something like this. So it has this a function similar to these fire thrusters, which takes an array of coordinates, really, which is basically represented by an array of doubles. So this function was looping through the 12 different coordinates, and it was reading these coordinates and doing something relevant or something critical with these coordinates in order to manage the landing of the probe. So later, there were some calls to this function, and in particular, there was some function calls that were invoking the fire thrusters function, which an array that was shorter than expected, right? So if you are familiar with C, C++, this 12, the size of the array here, the 12, is really an annotation that is removed at compile time. So at runtime, there is no way for the function to know if the array that was passed into this function is of this size or is larger or shorter. So this was the problem here, right? So this function was being called with an array only containing 3 coordinates instead of the 12 that was expected. So at some point during this loop, it was reading past the boundary of the memory allocated for these coordinates. So it started reading coordinates or doubles from this allocated memory, and after the third one, it was not reading coordinates, it was reading some arbitrary data from the memory that was adjacent to this array. So the JPL department in NASA partnered at that time with code analysis startup called Semel from Oxford, which was a company that was later acquired by GitHub. And together they wrote a query in order to detect the similar pattern all across the code base of the Curiosity rover. So bear with me. I know that you are still not familiar with CodeQL. This is a brief introduction, and we will see later what are the specifics of this language. So basically, you will be importing some modules, some libraries, as you do with other languages. And then in this case, we will be declaring some variables, in this case, a function call, and some expected and actual sizes, which are integers. And then there are some logical conditions that are asserted. First of all, that the function being called is actually the function that we defined in the variable statement. And then we are basically getting the size of the array as defined in the function declaration, and also the size of the array at the actual site of the function call, right? So the actual size versus the expected size. So by comparing then, we were able to find if there were function calls to a function which were taking an array that was shorter than the function was expecting. So as you can see, this is very similar to SQL, but instead of querying a database, we're actually querying your code base, right? So using this simple query, the NASA was able to find 30 similar errors, which they fixed remotely while the probe was still flying on its way to Mars, which is kind of awesome. And we all know how the story ended. Curiosity rover landed safely on the surface of Mars, and it was a little bit thanks to CodeQL. So this is a typical example of what variant analysis is, right? So there is a manual process of reviewing some source code and finding a bug. It can be a security research in order to find a vulnerability, or can be a debugging process that leads to find a bug, or can lead some peer review of somebody else's code. The thing is that this process is kind of costly and expensive in terms of time and money, because time is money. So variant analysis is the process of trying to find more variants of the same bug or the same vulnerability without involving this manual process. So the idea is to somehow code the pattern that led to finding the original vulnerability, and then be able to express that in a query language that can be run across multiple code bases very efficiently and very quickly. So with this approach, we will be able to find more instances of the same kind of bug within the same code base that the original bug was found, but also in different code bases. And here we have the idea of sharing, right? If you take the time to find a bug or find a security vulnerability, you want to code that into some kind of query that can be reused and shared with the community. That way, we can all benefit from what other people is doing. So let me fast forward 6 years, and the year now is 2018. There was this bug that was reported in Sonatype Nexus Repository Manager, which, according to the description of the advisory, it was a Java expression language injection in Nexus Repository Manager 3. Right, so there are no additional details, no details about how an attacker could inject expression language expressions, or what was the API that was taking untrusted data that led to this kind of vulnerability. So early this year, I performed a root cause analysis of this vulnerability. And I found out that this EL injection was caused by an insecure use of the bin validation API. So if you are not familiar with the bin validation API, JSR 380, basically it allows to define some constraints that you can express with annotations, right? So if you have, for example, a price that cannot be bigger than, I don't know, $100,000, for example, you can enforce that by annotating that bin property with an annotation, and then it will be enforced. And if there is, if it's violated, then there will be an error reported. So the reference implementation of this Beam validation API is the Hibernate validator. And it comes with a rich library of annotations to perform this kind of validations. However, there can be cases where you need to define a custom validators. And this was the case with Nexus because, well, in the front end, there was a form which allowed the admin to create and modify existing users of the Nexus repository manager. So when you create a user, you can assign some roles to this user. And when these roles are received by the backend, then they needed to be validated against existing roles and valid roles. So because they were using the Beam validation API, they wrote a custom validator, which is this class that is called roles exist validator, which extends from the constraint validator support. Okay, so basically, this is an interface which defines an isValid method that you need to override, and where you are going to perform the validation of the Java Bean property that is being validated. So in this case, what was being validated was a collection. And what they are basically doing is iterating the collection, and if they find that any of the roles that the administrator was assigning to a user was missing, was not valid, they were pushing them into a list called missing. And later on, they were basically constructing or building this constraint violation error message by invoking the build constraint violation with template method. So as you can see here, they are basically passing concatenating the missing roles string literal with missing, which is a list which contains untrusted data. And the reason that contains untrusted data is because what you normally validate is something that is normally outside of your control, which means that it's normally something that you receive from, I don't know, from a client or from the network, and you need to validate. So normally that's untrusted data. So if you find that this untrusted data flows into this build constraint violation with template, then there can be a problem here. So does anyone know what the problem can be? I will wait few seconds because I know there is some delay, and I will be monitoring the chat window. I will give you a hint. So the name of this function, of this method, is build constraint violation with template. And the with template is the important part here. Okay, so apparently this was this is a non very well known vulnerability, as it was the case when I found it. And the problem here is that this template allows expression interpolation, right? So this is kind of a template engine, like something, I don't know, similar to FreeMarker or Velocity or Pebble or something like that in the Java world. And basically it allows to interpolate EL expressions. So if we go and check the documentation for the Hibernate validator, which is the reference implementation of the Beam validation API, you can read that it's possible to use unified expression language expressions in the constraint violation messages. So this is designed to be used in cases like the example down here, where, for example, we are annotating the price, which is a big decimal, with the decimal max annotation in order to validate that this price is no bigger or higher than 100,000, right? If that's not the case, then an error message is going to be generated, and it's going to say price must not be higher than, and this EL expression with the dollar and the curly brackets is going to be resolved using EL expressions to this 100,000 unit here. So this is completely safe because this message cannot be controlled by any user or any attacker. However, if we go back to the build constraint violation with template, the problem here is that we are building the error message with some data that can be controlled. So they can put some EL expressions here and they will be evaluated. And if we go back to, or if we go and see how this vulnerability could be exploited, we can see that if we send a request to the endpoint to create a new user, in this case, the user is test123, and we are assigning some roles, in this case, just one role, and the role is NX admin and then $, and then we are adding some numbers here. So if we get the response, we will see that the results contain some errors, and the error message is missing roles and then NX admin and then 10,000 here. So this proves that the EL expression was evaluated, and this is just a simple and innocent example, but EL expressions are very powerful, and being able to control an EL expression basically means that you can run arbitrary Java code. So you can run a system process, or you can, I don't know, do whatever you want and fully compromise the server. So at that time, I wrote a CodeQL query in order to look for this exact pattern, not just in the Nexus code base, just to verify if there are other instances that were like maybe ignored at that time in 2018, but also in multiple open source projects. And I found 4 new instances in Sonatype Nexus. 2 of them were post-authenticated, so they required administrative privileges. So you need to be an administrator like the one that was reported in 2018, but 2 others were pre-authenticated. So just by having access to a Nexus server, you were able to compromise it and run arbitrary system commands. So we didn't just found vulnerabilities in Nexus, but we ran it across multiple open source projects in GitHub, and we found many of them to be vulnerable to this same insecure beam validation vulnerability, including things like Drop Wizard or some container orchestrators like Netflix Titus or Netflix Conductor. So later, I merged this query into an open source repository where you can check all the queries that exist and also run them against your code bases. And this open source repository, which is GitHub so github.com/GitHub/CodeQL, powers lgtm.com and GitHub code scanning. So if you are not familiar with lgtm.com, you can see it here. It's basically a platform that allows you to run CodeQL queries against any open source project, no matter if it's hosted in GitHub, GitLab, Bitbucket. So you can run all the security vulnerabilities and quality queries against any open source project for free, right? So you can see, for example, some projects here, or we can go and check, for example, this coronavirus server that I was talking about before. In this case, it only contains 1 error, but as you can see, you can query the project and perform any analysis on these open source projects. So the other thing that I was mentioning is GitHub code scanning. So I don't know if you are familiar with GitHub code scanning. It was enabled back in September. So it basically enables you, if you go to the security tab in your GitHub repo and enable code scanning, then every time that you submit a new pull request, this is going to be a scan for security vulnerabilities, and then it's going to fail the build if it finds any vulnerability. So it prevents security vulnerabilities to enter your code base. And this is completely free for public repositories. You can start using it right now in your public repos. So let's see if we have any questions. No questions so far. So this was early 2020. Then I went on paternity leave for some months, and when I came back, I ran this query on multiple open source projects in GitHub, and I found that one of the new affected repos was this Corona Warn app server in GitHub. So the name of the project is Corona Warn App /CWA server, and it's basically the server that serves the Corona Warn app, which is the mobile applications that the German government use for contact tracing, right? So it's the application which share the information about who tested positive in COVID-19, and then it allows other people that was close to these infected people to know that they were exposed to the virus. So this was the largest open source project ever implemented in Germany on behalf of the German government. And in June, that it was, I think, 1 month after it was made public, it was visited by more than 100,000 visitors, and it was participated by more than 7,000 community project members. So that means that it was reviewed by a lot of ABLEs. Most of them were making sure that there was no privacy concerns with this application, that the mobile applications were not getting any private data from your devices. So there it was completely anonymous. But this is a good example of how open source, because the German government and SAP, which is the main maintainers of this repo, made this project public. It enabled other people like the GitHub Security Lab to look into your application and find vulnerabilities and report them privately, so they were fixed very quickly. So that was the case. We reported this issue privately to SAP, and it was fixed within 4 days. And as you can imagine, it reached the media, but as you can see, US media and German media. But the interesting thing here is that it's all these news, all these headlines were highlighting this fact that because it was open source, it could be the vulnerability could be identified and reported privately to SAP without making it public, and in a way that if it was not open source, it could never been reported to SAP. Okay, so this is how the source code looks in the vulnerable Corona Warn app application. So basically, as we saw in the Nexus example, we have this isValid method that we override from the constraint validator interface. And then in this case, what the attacker can control is the submission payload, which is basically what you send from your mobile application when you say, when you state that you tested positive in COVID-19, right? So your mobile application is going to send something that is called the diagnosis key, which is basically a unique key that is provided by your doctor or lab who performed the test, and then it needs to be validated. So there are multiple checks, and one of them is this check origin country is valid, right? So this one is basically passing the submission payload down to check origin country is valid, which is basically getting the origin string from the payload, and then is concatenating that with a string literal, and then passing that into the add violation method. And the add violation method is basically just invoking the build constraint violation with template method that we saw before. So as you can see here, there is a direct flow from untrusted data into the build constraint violation with template, which enabled an attacker to evaluate arbitrary EL expressions and run arbitrary Java code in the server that was hosting these services. So if you think about it, that's normally the case, right? So there are no vulnerabilities that are only specific to a code base, or if they are like very few of them. So normally, if you find a vulnerability, is something that you can that is probably affecting other parts of the same application, but not just that. It may affect other applications that are not related with the original one. So being able to scale the process of manually finding these vulnerabilities is very costly and very expensive, because we don't have like enough I don't know, secure or code auditors in order to review all the open source applications that we can find, for example, in GitHub. So we really need to automate this process. And to automate this process, we need a tool, right? And what makes a good tool for variant analysis? Well, we think that it needs to be efficient because it needs to scale to hundreds and thousands of repos and projects very quickly. It needs to be expressive in the sense that, for example, in the case that we saw with NASA, or also this vulnerability affecting this insecure use of the beam validation API, it's kind of simple, right? So the queries are kind of simple, but if you want to express more complex patterns into a query, you need to have an expressive query language that allows you to somehow dump all the knowledge you have about that vulnerability that you found and express that into a query that can be later reused. And that is the third thing that I wanted to highlight. We need to be able to encapsulate or encode this expert knowledge in a way that can be reused by other people. Because if we have to write these queries every time that we write a new application or a new program, then it's going to be as much expensive as the original approach. So if you think about it, this really resembles like a programming language, right? So it looks like writing a program. So when you write a program, you need it to be efficient, to be quick. You need to write your program in an expressive programming language that allows you to express all the operations that you need to do with the data or whatever you are doing. And it needs to be reusable in the sense that it needs to be executed not just on your machine, but also in this production server, maybe in some containers, and so on. So if we are going to write a program, we need a language for that. And that's CodeQL. So CodeQL is an expressive query language. It's not a programming language. It's a query language. And also the engine for the analysis, and also the CLI and the ID tool. So we refer as CodeQL to the language, the engine, and all the tools around these engines. And the main idea behind CodeQL is to be able to treat your source code as data, right? So actually what it's going to do is going to build the AST, the abstract syntax tree of your source code, and it's going to dump that into a database so that you can later run queries on that database, right? So before going any further, let me check the chat window. Okay, so if you have any questions, just feel free to interrupt me, and I'm ready to the chat window. Okay, so what can I do with CodeQL? So we already saw that we can find bugs like the one in the NASA lending module, or we can find security vulnerabilities, that the one that I found in the Corona Warn app or Nexus. And what it makes CodeQL so great is that it enables you to perform this analysis very quickly, and also to reuse these queries later on other projects or in anyone's project. Because if you contribute these queries to the GitHub query repository, then everyone can benefit from those queries. So yeah, a new language. So what's new about the new language, and why do we really need a new language when we have, like, I don't know, hundreds of them? So, well, CodeQL is not a regular language, right? So first of all, it's logical. So it's composed of multiple logic conditions that you can combine together in order to write some kind of logical theory that you want to prove. It's also a declarative language. So as opposite to imperative language, what we are going to do with CodeQL is basically define what we want to find, not how we want to find it, right? So we are not going to see anything like if-else statements or for statements or anything like that. We are going to see something that is more similar to SQL, where we define what we want to find or get from the database, and we are not expressing how we want to find it. We are not saying how you want to go through all the database tables, columns, rows, and join them and union them. So that's something that is left for the engine to decide, and we only care about expressing what we want to do. So third, it's object-oriented. And this is kind of special because other query languages are normally not object-oriented. But for us, it's very important to be object-oriented because, first of all, it allows you to write classes and modules that can be reused later in your queries or in other people queries. Like, for example, if you define some classes to model some aspects of the Spring framework, for example, like, I don't know, a controller, then that can be reused in multiple queries, not just your queries, but also in other people queries. And also to benefit from object-oriented paradigm features like, inheritance, composition, and so on. So it's also a read-only language. There are no things like assignments, so there are no side effects in the language. Also, the database itself is read-only. When you want to perform an analysis of a source code, of a code base, you need to extract the database, and that's create some kind of a snapshot of the source code, but you cannot update that snapshot or insert any data into that database. If later you modify your source code and you want to run your queries on this new version of your source code, you need to actually extract the database again. And also it's equipped with a rich standard libraries. So basically you don't have to reinvent the wheel. It already provides you with all the different constructs and elements that you need to query the language that you are querying. So by the way, CodeQL supports, so far it supports Java, JavaScript, C, C++, C#, Python, and Go. And probably Ruby will be supported next year. That's yeah, I think I'm not missing anyone. Yeah. So what does a query look like? So we already saw a query for the C++ module of this Curiosity rover. This is an example in Java. So as you can see, we are importing the Java module. And because we are importing the Java module, we can use some expressions or elements such as, for example, the method access. Method access is nothing else than a method invocation. Or, for example, the expression is also imported from this Java module. So as you can see here, it's very similar to SQL. We have a from statement, a where statement, and a select statement. And what we are saying here is like, okay, declare these two variables like method access, MA, and the expression. And then from all the tuples of a method access and an argument, or sorry, and an expression, constrained those tuples to those ones that are satisfying the following conditions. So the first one is that the method access is accessing a method which is named build constraint violation with template. And the second one is that the expression needs to be the first argument of this method invocation. So for those tuples that satisfy these two conditions, select the expression that is passed as the argument of the first argument of the build constraint violation with template, and also this string literal, which is basically describing what this expression is. So with that, I want to write some queries with you, but let's see if we have any questions. So if you have any questions, just before I jump into the terminal to write some queries, let me know in the window, in the chat window or in the questions window. Okay. So no questions so far. Let's move. Let me stop sharing this and so hopefully you can now see my terminal. So by the way, I'm gonna use a plugin for NeoBeam, for Beam, to write and execute or run queries, CodeQL queries, but this is not the official extension to build or to write CodeQL queries. So the official one is the one for VS Code. So if you want to play with CodeQL, then you will need VS Code or NeoBeam, and then one of these two extensions. So let's start with something simple. So first of all, we need a database to query, right? So I have here the source code of the Corona Warn app server. And in order to extract a database, what we need to do is invoke CodeQL command with these parameters. So basically, we are going to create a database for the language Java, and this is going to basically build whatever build system is being used. So things like Gradle or Maven, and it's going to extract the database. So I have already a query here, a database here. So I'm gonna set the database, as you can see down here, to the Corona Warn app database. Okay, so now let's query some simple stuff. Like, for example, I want to query all the method access. Let's call them MA, where MA get method has a name which is equals to this build constraint violation with template. Okay, and then we are going to select all those method invocations. So far so good. If we run query, this is going to compile the query. If you reuse this query for multiple projects, you only need to compile it once, and then it's going to throw the results. So as you can see here, we have only one result, which is a place in the source code where this build constraint violation with template is invoked. So far, we don't know if this message can be controlled by the user or not, if it comes from the validated object or not. So it's not telling us too much. So let's write something maybe a little different. So for example, we may want to know how many Spring controllers we have. So what's the surface of our application? What is the attack surface? So let's look for classes which have an annotation which have a name, which have type, which have a name matches something. Okay. So what I'm querying here now is, okay, look for all the classes which are annotated with an annotation whose name matches this kind of regular expression that ends with mapping. So I'm looking for request mapping, get mapping, post mapping, and things like that. So if we run the query, you can see that we have three different elements here, like this callback controller, which is a REST controller that is validated. Then we have this fake request controller, which is also a REST controller, which is not validated, and maybe this submission controller. So as you can see, the attack surface of this application is not that big. So going back to the application, to the query, we can try to use some of these object-oriented properties. Like, for example, we can say that we have an unvalidated string controller which extends from class. So it's a specific type of class. And if we set the constructor, we can define what our conditions are going to be. So let's reuse this piece of code here. So we have and a class which extends from a class, basically specifies a class which is annotated with mapping, but it's not annotated with validated. And then what I'm going to do here in the query, I'm going to say C is an instance of this unvalidated controller. So now if I run this class, this query, I should get only one result, which is this controller that is not annotated with validated. So this is just to get you an idea of what kind of queries you can construct with CodeQL and what you can use this for. It's not just for security vulnerabilities, but actually for querying your source code for anything. So now let's run a data flow analysis, which basically we are going to use CodeQL to find if some data flows from one part of your application to a different part of your application. So we need to define some metadata for the query. So this is going to be test. And what I want to specify is that this is a path problem, which is a data flow problem. And basically, I'm going to reuse some snippet here. So this taint conf basically is going to import the configuration of the taint tracking analysis module. So I don't expect you to understand everything that is going on right now, but we are going to define a taint tracking configuration. Let's call it bin config. And basically, we need to override two different predicates. One is the source of the data flow, and the other one is the sink. So here we care about things like is valid first argument. And here we care about this build const. And this the sink here is going to be the first argument of this function call. Okay, so let's clean this up a little bit so we don't get any errors. And now let's start building our data flow query. Right, so for the source, what we want to find is that we want to find some method, let's call it M, which is called is valid, and M get parameter 0. So the first parameter is going to be our source. So let's say that source parameter, and then closing this parenthesis here. So basically, what we are looking for is our basically methods called is valid, right? So we can just query this little piece of predicate here by running quick eval command. And this is going to just check for results that satisfy this predicate. So as we can see, there are 6 places in the application where this method is implemented. Okay, So far, so good. Now let's go for the sync, right? So in this case, we want to find a method access. Let's call it MA. And this method is basically accessing or invoking a method that is called build constraint violation with template. Build constraint violation with template. And then what we want to do is say that the first argument of this method invocation is our sync. So again, we can just run this query, this predicate, and see all the places in the source code where the beam validation, build constraint violation with message is invoked. And we can see that we only have one result. Okay, so now if we want to run the data flow analysis, we just need this query down here. So basically, what we want to find here is a beam taint tracking configuration with a source and a sink, so that the source flows into the sink. And if we find it, we are going to report the source, the sink, and then a message like, I don't know, insecure beam validation. If we run the whole query, not just the individual predicates, we should see if we are able to find a vulnerability in the Corona Warn app server. So now it's compiling the query. It can take a few seconds, and now it's computing the results. So we get one result. And as you can see here, this is a path. So this is a data flow. The first element is the source. As you can see here, the source is the submission payload. That is the first argument of the isValid method as we defined. Then this one flows into the check origin country is valid. And from there, it flows into, well, it's defined as the local variable in this method, and then flows into the string format, which concatenate with a string literal, and then flows into the add violation method, which finally flows into the build constraint violation with template. So with this simple query, which we are basically just defining one source, one sink, we were able to find a remote code execution vulnerability. Okay, so let's go back to the slides. Okay, so back to the slides. You can see here's more or less what we define in the terminal. So we wanted to model the source that was the isValid method from the constraint validator interface. And this is the more accurate predicate. So it's not just checking the isValid method as I did, but it's also checking that is declared in this case in an interface called constraint validator, and that there is a different method that is a validator impl, which overrides or instantiates this method. Same thing for the sink. We are basically just checking that the first argument to build constraint violation with template is the sink of our data flow analysis. And the happy ending, or this story has a happy ending, basically is that 12 days ago, the Hibernate validator, which is the reference implementation of the beam validation API, decided to finally disable the expression language by default on custom constraint validators. So it's still enabled in cases like, for example, if you have the message in a built-in annotation, like the decimal max that we saw at the beginning of the session. But if you invoke the build constraint violation with template, then EL interpolation will be disabled by default, and you will have to opt in order to enable that. And I wanted to leave you some links. If you are interested in learning CodeQL, you can go to codeql.com. Also, if you want to learn more about this insecure beam validation pattern, you can find more about my research in this securitylab.github.com link. Also, the whole story about how we found this vulnerability in the Corona Warn app servers and how it was fixed, and the whole story can be found in that link. And last but not least, if you want to learn more about how to use CodeQL, I recommend you to play some capture the flag games that we have created for you. So basically, we have one for C++, we have another one for Java, we have another one for JavaScript, and we are now preparing new ones for Python and Go. Also, if you want to learn more about CodeQL, you can, if you want to contribute to this repo, which is basically the repo that hosts all these CodeQL queries which are open source, by the way, you can actually contribute to them and get bounties, right? So last year, we gave $100,000 in bounties this year, 2020. So basically, those were like developers and security researchers, which took some time, maybe less than, I don't know, a week or a couple of days, to write a CodeQL query to model some security vulnerabilities or some patterns, and then they contributed back to the community. And if you do so, go to this securitylab.github.com, get involved, and you will see how to opt in for getting a bounty. And these bounties are normally in the range of $1,000 to $4,000 for the more complex or the more complex ones. So I really encourage you to learn more about CodeQL. Find bugs and security vulnerabilities in your applications, and then contribute those queries back to the community and get some extra money. So with that, I think that's all for me. If you have any questions or comments, I will be glad to answer them. So apparently there are no questions, so I will be closing. Thank you all for attending, and see you next time. I will be closing. Thank you all for attending, and see you next time.
Hi everyone. So this is Java E on Azure Mystery Magic Show. I'm Reza Rahman. I'm in my day job. I'm principal program manager at Microsoft. That means really I work with many different teams at Microsoft. Sometimes almost 20 or 30 different teams that all do bits and pieces of Java here and there. But you know, me being somebody that's been in the Java EE ecosystem for a very long time. Actually, a large part, some part of my job is to support Java EE developers and Java EE vendors and Java EE runtimes on Azure. So this is basically what this talk is about. To see what are the different flavors and what are the different things you can do with Jakarta EE these days on Azure, and there's quite a bit of that. This is not actually going to be a talk where I'm going to be doing any lectures whatsoever. It's these days I've switched over to what I call like slide-free mode. So no slides whatsoever. I just try to get online and try to do some stuff. So that's what I'll be doing in this session as well. So basically, what I'll be showing is there are a few different ways on most major cloud providers to move your workloads onto that cloud provider. And I'll be showing on a hands-on fashion how that is done. Actually, this talk, I'll show you the material in a second, but basically everything that I'll be doing is already provided in as a step-by-step directions, and that's on GitHub. I'll show you the GitHub repository in a second. So although I'll be doing the demo here in about 50 minutes or so, you can actually take your time and do the step-by-step instructions. I've done this as a workshop before, and it takes roughly about 8 hours to get through the content and really understand what's going on and what are all the different trade-offs. Some of the trade-offs, obviously, I'll be talking about here in a second as well. So sit back. Hopefully, you'll enjoy the session, and I hope it goes glitch-free. It's always a little bit adventurous to try to do this kind of live coding stuff. Sometimes things, most of the time, things are okay. Sometimes you kind of have to do live debugging on the fly, which is not too much fun when you have a big crowd watching you. But yeah, hopefully everything will be fine. So we'll get started here and start doing some hacking and talking about the different options for Java EE on Azure in a little bit. I think the other sessions may be running a little bit late, so we'll give people just a little bit of warm-up time here. In the meanwhile, let me share the URL for the materials, which is on GitHub. You guys can take a look at it at a later point in time, and I'll also give it to the conference organizers so they can take a look at it also. The last thing I want to mention is there's no reason to sort of hold back questions until the very end. Probably I'll be hacking code until the very end is my guess. So if you have questions, just feel free to ask them, and I'll answer them throughout the session. Okay, I think we're good enough. We're about 5 minutes past, so I'm going to go ahead and get started and see what happens. So I'm going to turn my video off and share my screen. Okay, so hopefully at this point everyone is able to share my screen, see my screen. Let me hide this button here, and also able to hear me okay. So this is the GitHub repo that I was talking about. It is basically, again, about a day-long workshop. I'll be going through this in about an hour, so obviously I won't be able to go into the entire workshop. But what I'll do is just show you enough so that you can go and take a look at this workshop by yourself in a bit later after I'm done here. That's actually the objective, is to enable you to do that and give you enough of an introduction of the materials so that you can go ahead and do that. So basically, this talk is about showing you the different ways that a Jakarta EE developer could, or Java EE or Jakarta EE developer could move their applications, could move their workloads onto Azure. So we'll be starting with basically, as things always start and is always relevant, even if you are working on the cloud, and that is getting everything running locally. I'll show you the setup for that. Then we'll be talking about various different ways of moving to the cloud, and these are the four main ones. Right? These are not limited certainly to that, but these are the four primary ones for Jakarta developers. The first is IaaS, or Infrastructure as a Service, and this is really nothing much more than running a Java application server on a virtual machine. Very old technology. We've been running VMs for, I don't know, since at least the 2000s, running technologies like VMware. So this is very much like that. It's sort of that stereotype of your computer on somebody else's machine. In this case, the machine is going to be Azure. So we will take a look at this. This is the easiest path of getting onto the cloud. It's, like I said, it's very, very similar to what you may be used to in your data center, and you'll see that as I go through the steps. Then there's PaaS, or Platform as a Service, and this is a situation where you only are dealing with your artifacts. So everything else is created for you. So really, in this case, you would just be deploying your WAR file and doing just a few wizard steps to set up your PaaS environment. Azure does have one, so we have JBoss EAP as a managed service on PaaS. I probably won't be showing you the PaaS too much. The PaaS is the highest level abstraction, if you will, and IaaS is the lowest level abstraction, if you will. What I do plan to show you, though, is Kubernetes, which is another way of getting onto the cloud, probably a very, very popular one for Jakarta developers these days. So I will be showing you step by step how that works. Kubernetes, I think of it as sort of IaaS, but one layer up, where you don't have to deal with operating system level concerns, and you're dealing with infrastructure as metadata almost. So you're describing your infrastructure in YAML, and you'll see what I mean by that. So there's a reason why Kubernetes is so popular, and I'll be showing you that path as well. And you can compare and contrast with how that looks like with, for example, a virtual machine-based setting. If there is time, I'll show you another thing called Azure Container Instances. It's very interesting in the sense that you're able to use containerization, namely Dockerization, and Dockerize your application. If it's a very simple application, you're able to do that and deploy it onto Azure without necessarily dealing with Kubernetes. So we'll see if there's sufficient time for us to do that or not. If there is, awesome. If there isn't, I don't think it's going to be a very big deal. So let's go ahead and get started and get things running locally. So to save time, I have cheated and I've done a few things ahead of time to save us time. So again, these are the step-by-step instructions that you can follow by yourself. We'll basically be doing a very simple CRUD application. You'll see the application in a moment, but it does have all of the bits and pieces necessary for a Jakarta application. The majority of the technologies are there. I'll be using Eclipse for this. You can use any IDE that you want. I'll be using Pyara as my Jakarta runtime, but you could easily use Wildfly or OpenLiberty or what have you. I'll be using Postgres. Again, you can use any database server that you want. So there's some basic setup steps that I've already done. So I have Zulu JDK8 up and running on my machine. I've downloaded and set up Pyara ahead of time. I've downloaded and set up Eclipse IDE for enterprise Java developers ahead of time. I am using Docker. I don't necessarily have to use Docker, but I'll explain why I'm using Docker in a moment. But most certainly, we will be using Docker for the Kubernetes portion of this talk as well. And of course, I have this code downloaded. So because it's a CRUD application, the first thing to do is that you need a database up and running. So I'm using Postgres. I could have installed Postgres locally if I absolutely had to. I prefer not to do that because I have no use for Postgres. Otherwise, there's no purpose for it. So a very easy way to get around this is to just run a Docker container. And what Docker will allow you to do is just run the image and download and run the image, Postgres image on the fly without an installation on my own machine. And when I shut it down, the image goes away and I don't have any Postgres installation on my machine anymore. So it's a really nice, easy way to get things started. Hopefully you can see my screen. I'm going to just maximize this so you can see it. I'm going to explain the Docker syntax to you, just in case you haven't seen Docker before. So this is Docker run, which is run a Docker image. IT stands for interactive. I do want this to be interactive. RM means when I shut down this command, don't bother keeping around a copy of the image. I don't need it. I'm giving the image a name, in this case, Jakarta Cafe DB, just in case something goes wrong and I need to resurrect this. I need to be able to refer to it by name very easily. The -v portion is important because we're running a database. So one of the things to understand about Docker when you're using it is how the Docker file system works, as well as how Docker networking works. So because this is an image, as soon as I shut down the image, all of the file system will go away. So I can't have that for a database. It's kind of inconvenient. So what I'm going to do is, with the -v command, I'm literally mounting my own local file system onto part of the image. So I can begin storing the data there under that path that you see there. So as such that the data is always stored on my own machine. Even if I shut down and restart the image, the data will still be there. And then finally, it bears to explain the -p 5432:5432 syntax a little bit too. So when I'm creating a Docker image, it is running in its own little subnetwork within my own machine. So it's different from the network system of my own machine. I cannot, and that entire network, all of the images are sort of in their own data center, surrounded by their own little firewall. So in order for me to access this database, I need to open ports. So that's what the -p command is doing. It's literally saying, open up this port on this image, so the person from running on the local machine can access it. Okay, and finally you have Postgres, and that's the name of the image on Docker Hub in this case. So I'm just going to run that image from Docker Hub. So let's run it. So as you can see, no installation really necessary. I already had Postgres up and running, and I reran this command a bit earlier in the day. So that's why Postgres, the binary is already downloaded into a cache, and I was able to very quickly start up. So now this database connection is listening on 5432, and I can refer to it that way. So let's close this down in a second, and here's my application. It's a very simple CRUD application. There's really nothing fancy to it whatsoever. I'll just show you the POM file real quick. And as you can see, it's a very typical Java EE application. It really has just one dependency. This is the one right here. And that is a dependency on Jakarta EE API. As you can see here, the new one, 8.0, that's all. So I won't go over the details of this application. You can do that by yourself. It's basically a Maven-based application. It has all of the bits and pieces of Java EE, like CDI, JAX-RS, CJB, JPA, even a JSF facade. So I'm going to just go ahead and clean this installation. Okay, it's cleaned. I'm going to build it. Okay, it's built. So I have my WAR file. If you look up here, here is the WAR file that was generated as a part of my package command. So I have a WAR file ready to go and deploy. I do have a server configured. In this case, I have Payara 5 configured here. I'm going to just go ahead and start this up, run this application, and it's going to start up in Payara 5. Oh, I've had my IDE running a little bit while, and it's gone idle. So it's going to take just a moment for this to get started here. So while that's going on, these are all the instructions to set up the IDE and set up Payara. You can do that essentially by yourself when you can. And then finally, when I have the application up and running, it's going to be running on localhost port 8080 Jakarta EE Cafe. I'll show you that hopefully momentarily. Hopefully my Eclipse is unfrozen. Yeah, there we go. Okay, so there's my application. It's deploying, and it deployed. Okay, so for some reason, the internal browser of Eclipse doesn't handle the CSS too well. I'm just going to load this up onto a local instance here. As you can see, this is just a CRUD application. Let me just delete one of this data here, and I'll re-add something back. And that's it. That's the extent of the application. It's not supposed to be fancy. It's just to show you that it's a real Jakarta application that has some real components to it. Okay, so that's it in terms of all that we're going to do locally. In fact, I'm going to go ahead and shut down Eclipse just so that it's not in the way. I don't need this database instance anymore, so I'm going to do a Control-C, and the database is shut down, and we're ready to go and ready to move on to our next step, which is to move it into the cloud. So we'll start with the easiest way to get into the cloud, which is infrastructure as a service. I'll show you the basic moving pieces to this, but it's not really that complicated. It's largely very similar to what you would do on your own local data center, as you'll see in a moment. So just like we were running Docker locally, you will need a Docker instance over here. So rather, a Postgres instance locally. You will need a Postgres instance on the cloud as well. You need a database. So there's many different ways that we could do this, but frankly, the easiest way to do it is just to use a managed PaaS on Postgres, which we do have a Postgres offering on Azure. Again, just to save us a little bit of time and to be able to get through this a little bit quicker, I've already created the database instance. So here's the database instance. And hopefully you can read this. Let me increase the font size a little bit. It says Azure Database for PostgreSQL Server. Okay, so it is already up and running. It's up and running on this server name, as you can hopefully see. So this is where I can connect to the database. So it is already up, already ready to go. So you can go through these steps and do it yourself, and you don't need to pay anything. You can get a free subscription for Azure for about a year to try all of this stuff out by yourself. So next thing we're going to do is go ahead and start the VM or the virtual machine to get all of this up and running. So I'm going to go to the Azure portal. You can provision resources many different ways on Azure. But generally, I find that the easiest way for me is just to use the Azure portal. And it's also a more user-friendly experience as well. It's a beginner-friendly experience. So I'm going to go ahead and create my VM. So in order for me to do that, I'm going to be using Ubuntu. I just prefer Ubuntu for these sorts of demos. But you could use pretty much any Linux server, and it should be perfectly fine. Red Hat is actually the most popular one on Azure. So we'll do a create resource, and I'll enter in the VM image that I want, which is Ubuntu Server 20.4 LTS, and I'm going to hit create. And here I'm presented with some options of how I want to go ahead and create my resource. First of all, I'm going to create a resource group. So think of it as a logical grouping of resources on Azure, sort of like your own little data center. So I'm going to go ahead and create a new resource group and give it a name specific to myself to disambiguate it. Okay, so we already have that. So I'm just going to select it. Jakarta eCafe Group Reza. So there we have it. I'm going to give the virtual machine a name. So I'm going to need to refer to it with this name. So I'm going to give it this name here. Jakarta eCafe Server Reza. And ECS is fine with me. I don't want infrastructure redundancy. The image is the one I want, Gen 1. I'm going to see, I think the size is perfectly fine. It's about $30 a month. That's a reasonable for a server. I do need to access ultimately this machine, right? So I'm getting a VM, but I need to set up the VM. So I will need to SSH access onto this machine. Normally in a production environment, you would use a SSH public key to do this. This is just a demo. I'm just going to use a simple password. And I'm going to give it a username. So Pyara is the username I'm going to use. And I'm going to give it an appropriate password. I'm just copying the password from here. If you're doing this, please do me a favor and either delete your resources right away or please use a different password. Okay, so we do want some selected ports. So in this case, we're going to select port 22. We need SSH access to this machine. And we're going to be using both the HTTP and HTTPS ports. So we'll leave that open as well. So let's just go through this for a second. Disks, premium SSD, that's fine. The defaults are fine. Let's look at the networking. Virtual network, subnet, public IP. This is the IP that I'm going to be given. Yeah, I just want a basic NIC. I do want both AT, HTTPS, and SSH open, so that is all fine there in terms of its settings. Let's move on to the next one. Management. Not much here to worry about. I think all the defaults are fine. Don't need any advanced settings. Gen 1 is fine in my case. So moving on to tags, no tags necessary, and I'm going to review and create. I'm going to take a final look at all my settings. It should be perfectly fine. Okay. Preferred phone number, all right. Validation passed. And resource group name. So let's take a look. Okay. East-US, Ubuntu server, 2 CPUs, 4 GB of memory. That's plenty. Password Payara, public open ports, SSH, HTTP, and HTTPS, premium SSD, virtual network, and so on. So I think we can go ahead and hit create. So when I do this, it's actually, for me personally, pretty amazing. The reason for this is that this used to take weeks, to deploy a machine. So it's pretty amazing that we can do that a lot more quickly these days using Azure. But it's not instantaneous, right? It still takes a little bit of time for the deployment to happen. You'll see in a moment, just how long it takes to go ahead and provision a basic machine, and to deploy it. So obviously, this would be normally, frankly, be fine, in a realistic scenario, but in a demo, it's obviously a time killer. And this is why the reason that I was taking a few of the shortcuts just to get us moving a little bit quicker along this path. So we'll allow this to happen. And while this is going on, I'm going to take this time to tell you what is going to happen next, what the explanation of what we're going to do next as soon as this deployment is complete here. So let's take a look. Okay, and you can see the deployment steps of what exactly is going on as well. So first thing we're going to do is go ahead and SSH onto this box from my local machine. So once this process is done, I'll be given a public IP. I'll be able to access this machine from the public IP using SSH. I can actually set up the environment. This will just be Ubuntu. There's nothing on it, so there's no Java by default. You will need to install Zulu. So in order to do that, I'll be doing just a little bit of manipulation of APT, which is a package manager on Ubuntu, adding the Ubuntu server configuration and some keys, and adding Zulu as a repository. And then finally, I'll be able to do an installation of Zulu. Okay, so that's going to be the sudo apt install of Zulu 8. I'm using JDK 8 for this app. You could probably use JDK 11 and still be fine. I will be installing Maven locally on this machine as well. Normally, you wouldn't be doing this. Normally, you would really be having Maven running on a CI/CD server. But just for this demo, I'll be downloading the application locally and building it using Maven, very similar to what you would do on your own local machine for a local development machine. So I think our resources is actually created already. So we can go ahead and actually log on to this machine and begin doing the setup for real. So let's go ahead and do that. Clear this so you can see this a little bit easier. This is really nothing much more than logging onto the machine. So here's what I get the machine IP address. Let me blow this up a little bit more. So here's my server, the instance that was just created. Here's the public IP address. I'm going to copy this over and hopefully be able to connect. Yes, I want to connect. Yes. Okay. And password. I think I mistyped the password. Okay, let's try that again. All right, so I'm now on this machine. So basically, this is going to feel exactly like my own server. This might as well even be local at this point, and this is really as simple as that. So we'll go through the rest of the steps to set up Fire to validate that yes, you can do that, and it is really as simple as that. So let's go ahead and add the key. Okay, key is being added. We're going to go ahead and do a apt add the repository in apt. It's done. We're going to do a apt update. Okay, that shouldn't take too long. Should be pretty quick. Yeah, it's done. And this will get us ready to install the JDK. So we're going to go ahead and install Zulu 8. Okay, so we are in a little bit of trouble. So to be upgraded, let's do that for a second. Okay, and let's try apt update Zulu one more time. Okay, so it's a little bit of trouble we're having. I'm going to have to debug this a bit later. Let me see if the rest of the commands went okay. Yes, that was fine. That was fine. Okay, did I skip a step? No, I did not. Okay, this is where live demos are always a little bit of an adventure. Let's try Zulu 11. Interesting. So that it also did not work. So let's try installing OpenJDK. Okay, so hopefully everything will be fine here. All right, let's try this. Sudo apt-get update. Okay, that should be okay. And sudo apt-get install JDK8. Open JDK8 should be almost exactly the same thing as Zulu. Yes. Okay, and this will take just a moment to install. So as you can see, it's always a little bit of an adventure, and hopefully we'll be able to get things up and running properly here. So one thing I did want to note is, although you can do this way, and it's a very old school, reliable way of doing things, it is not automatable, right? So I'm needing to install all these packages and run all these commands one by one by myself. You don't actually need to do that on Azure because of two reasons. One is you can automate all of this using something called ARM templates. So you can script all of this and just run a simple script, and the script will take care of all of these details for you. And I'm going to actually go ahead and fix the problem here that I was encountering. Or what you can also do is that you also have these solution templates on Azure, so that do all of these things for you behind the scenes. So you don't have to do really any of this stuff. All of this stuff is automated for you. It's just point and click in the UI. In fact, we have solutions for most of the major application servers this way. WebLogic is one of the key ones that we're working on with Oracle. So if you really wanted to create some a WebLogic server, even with a cluster, even with different integrations, you can just do that via point and click. So you don't have to do this sort of stuff that I'm doing right at this moment. So let's see if our Java install was successful. Could be. Okay, yeah, I think we're all ready to go with our Java install. So I'm going to go ahead and fix this or try to debug what exactly is going on in here. So we're going to go ahead and install Maven next. Yes. Okay, and that should have gone without any problems. We're going to go ahead and download Pyara. Pyara is as simple as just download and run. So we're just going to download Pyara from a location. Now, zip is not installed on Ubuntu by default because of some IP reasons. So we will need to explicitly install unzip. So we'll go ahead and do that. So we can unzip, go ahead and unzip Pyara. So that is done. We're going to now unzip the Pyara zip. And that's it. We're get ready to install. We're all set to install Pyara. So now let's get the application itself. So I'm getting it from my own GitHub repo. Okay, the application is downloaded. We're going to unzip the application. Okay, the application is unzipped. We're going to go ahead and do a Maven install of the application itself. So let's take a look at the application and see where it is. So it's Jakarta.ee master, and we're going to go into the IaaS directory. There is a copy of the application there. Okay, and we're just going to build the application right here. Okay, so we have our WAR file ready to deploy. Now, for the rest of the steps, I will need to be super user because I'll be opening up some ports on port 80 and doing some change to the Pyara install. So I'm going to need to log on onto SU. So I'll go ahead and do that real quick. Okay, so now I'm logged on as SU. I'm going to go ahead and start Pyara. I will need to start Pyara in order to make some changes. In particular, Pyara runs on port 8080 by default. We can't really do that because we can only open up port 80 on these VMs. So I need to basically get Pyara to run on port 80 instead of port 8080. This is the command to do that. Don't worry about it too much. You can just take a look at it. It's an ASAdmin command that basically is saying, hey, please start listening on port 80. So I'll go ahead and execute this command. So we're done there. It's executed successfully. Now we can, we'll need to add the database driver. So I do have the database driver downloaded here. I'll need to issue another ASAdmin command, add library, as you can see in the command line, to add this jar file to Pyara. So I'm going to go ahead and do that. So that's executed successfully. Now all we really need to do is deploy the WAR file, and really we're ready to go. So we're going to go ahead and deploy the WAR file now onto Pyara. So it's ASAdmin deploy. So we're doing the deployment. Okay, and we should have a Pyara instance up and running now with our application, and it's running on Azure. So it's always interesting for me to when I do that. So let's try just with no arguments whatsoever, and we'll get the Pyara instance, and now we'll run the application itself. Here's our application, and I have I reused, as I said, I created the database before. I was testing it around, so we have a few record entries here. Just because we lost some time trying to install Zulu, I'm going to move things forward and not really do very much here. But basically, that's your VM story, right? It's as simple as as that. It looks very much like what you would potentially do, in your own laptop. Right? It's as simple as that. So I'm going to go ahead and go on to the next steps. So I do have this code downloaded locally, and that's where we're going to go. That's sort of where we're going to go next. And where we're going to go next is actually in our Kubernetes directory. Right. Okay. All right. So let's begin to move around from there. So as I said, let's move on. The next, as I said, I can show you PaaS. I can show you Docker ACI. It's going to take a lot of time, but I think what I would like to do instead is show you one of the more popular options, which is Kubernetes, so that you can actually take a look at, just from a functional standpoint, what the similarities and differences are in doing all of that. So first thing is you need another Postgres instance. Again, we already have it up and running. Let me go back and reopen the portal. I accidentally closed it. So again, we have our database up and running. So there's a database, right? Azure database for Postgres Server, as you can see. You will need a Kubernetes instance to get this up and running. And again, it takes a little bit of time to create it. So in order to save time, I've go ahead and created it beforehand. So here it is, Jakarta eCafe cluster. So as you can see, this is Kubernetes service. There's a few things up and running here. Let me decrease the font size a little bit and show you that it is up and running and has been for a little while. So I'll click on the Insights window. And as you can see, it's I tested this out a little bit earlier. So there's some data from my previous runs. Then you need to set up Kubernetes tooling. Primarily, you do that using kubectl. And you need to issue just one command in order to link up your kubectl tool running locally onto your Kubernetes instance that is running remotely. So actually, I've done that. And now, to me, Kubernetes is almost something that is running locally again. So let's say kubectl get pods. And I don't have any pods running right now. I do have a couple of nodes allocated. Okay, so I have 3 machines. Basically, you can think of it as virtual machines allocated and ready to go. So these are my nodes. I should not have any services right at this moment. Okay, so there's no services except for Kubernetes itself, right? Kubernetes itself is a service, and it always runs on each Kubernetes cluster. So that's what's going on. So basically, this is a clean install of Kubernetes right at this moment. So now we're going to begin to build the application, and we're going to begin to deploy the application, sort of similar to what we did for VM. So let's begin to do that. So it all starts with application war file, same as before. So we're actually going to go ahead and build that again. So we're going to do a npm clean package here. And there we have it. Right, so we have the application up and running. Here it is built, right? As you can see, so it's ready to go. It always starts there. The next step for us is to take this WAR file and to put it in a Docker and to create a Docker image out of it. So I'll go ahead and do that. And while I'm doing it, I'll explain what I'm doing. First thing I need to do is to log on onto Docker Hub. I'm using Docker Hub as my image registry. So the reason you need an image registry is, remember that I'm doing this WAR file. I built this WAR file locally, but Kubernetes is running on Azure. So I need to upload this image that I'm about to create somewhere. And in this case, I'm going ahead and uploading it to my Docker Hub repository. So the first step to do that is to actually build your image. And I'll show you what a Docker image actually looks like and what it means. So in this case, for now, just take my word for it. I will explain the syntax of what I'm doing. So this is Docker build. So this is building a Docker image. -t means please make this thing, give it a name. So the name that I need to give it is the name of my Docker Hub account, which is Rez Rahman. And the name of the image is Jakarta Cafe, and then you can give it a version number, and I'm giving it a version number of v1. Do note the dot in the end. So basically the dot in the end is referring to the Docker file up here, as you can see, this Docker file. So I've described how the image should look like in the Docker file. So let's go ahead and run this. Okay, so I've run that, and after I've run that, let me show you what I just ran, right? So as you can see, if you take a close look at this, there's step 1, 2, 3, 4, and each of these actually correspond to entries in my Docker file. So here's the Docker file. So this is, in a way, it's an abstraction over what we did in the VM world. So remember, in the VMs, I installed Java, I installed Payara, and there was the operating system. All of that is abstracted in a single line called from Payara server. So this is encapsulates an already pre-built image with Payara on it. So there is an operating system here, there's Java here, as well as the Payara server installed here. But I still need to do the deltas, right? The additional things that I need to do. Remember, I did the deployment command. In this case, instead of calling asadmin deploy, which I could have, I'm simply copying over the war file into a known deployment directory on Payara. So when Payara starts, it's going to auto deploy the application. I still need to upload the jar file for the database, and I still need to invoke the asadmin command to add the library. So that's actually, in fact, exactly what I'm doing. So this is doing exactly what I was doing in the SSH, more or less, except I'm declaring it and sort of scripting it in my Docker file, if you will. So right now my Docker file is built. It's ready to go. I've given it a version number. I'm going to go ahead and upload this Docker image onto Docker Hub. Okay, so I'm going to push this, and I've pushed a copy to this already. So this is going to go super fast because it's already cached. Yeah, as you can see, a layer already exists. So this is all done already. Okay, so I'm done there. So my Docker, if I go on to log in into my Docker Hub, which I'll do. Okay, as you can see, there is my image, and it was updated just a few seconds ago. Now Kubernetes can read this location, okay, in order to deploy my application. So that's what we're going to do next. We're going to issue this command, kube control -f Jakarta EE Cafe. And before I do that, let me just check the contents of the Jakarta EE Cafe just for a moment, and I'll explain to you what the contents actually are. How about cat? Yeah, that's all I needed to see. So I'll show you what I was looking at in a second, but let me just issue this command. So this is going to begin to spin up the Kubernetes instance. So this is actually creating all of the instances that I need, and I'll show you what I mean by that. So here's the YAML file that I'm doing. So this is describing a deployment, as you can see, kind deployment, and this is the name of my application, Jakarta EE Cafe. It's in the default namespace. There's some labels. This is mostly just boilerplate stuff. The most important thing to understand here is that I'm running 2 copies of my image. So 2 copies of the application, 2 copies of Payara. That's what replicas 2 actually means. And this is the name of my image. And locally speaking, I actually changed this beforehand to Reza Rahman Jakarta EE Cafe :v1, which is the name of my image over here, right? As you can see, right, this is a tag name, and there should be just one tag. Yeah, v1 is a tag that is there. So basically, that is what I specify in my YAML file. Now, in addition to deploying these 2 instances of Payara, I also need to expose this. Remember, this is the same deal as Docker. So this is running in its own little virtual network. I don't have access to it unless I create access to it. And the way you do that is by exposing a service. And I'm exposing a type of service load balancer And again, I can only expose port 80, so I'm exposing port 80. But since Pyra is running on port 8080, I'm actually specifying the target port to be 8080. So when I invoke port 80, it's really going to port 8080 on a given image. So let's go ahead and try to access this guy. And the way we do that is let's see what changes happened in our cluster 2. So get nodes is going to be the same. It's going to be still 3 nodes that I serve my pods from. There we go. I'm going to get pods. So as you can see, we have 2 copies, and they're both up and running. You can see status up and running. And I'm going to get services next. Typo. And as you can see, in addition to Kubernetes, I've also created that load balancer instance. So here's the load balancer. It has an internal cluster IP, which I can refer to for internal purposes. But what I actually want is the external IP. So I'll go ahead and copy the external IP here. Enter it. And here we go. We have Pyra up and running as well. I'm going to FA. And there's my application once again. So now I'm accessing the same application that I was in VMs, but this time I'm running on a Kubernetes cluster. So you can see the differences here. It's mostly the same, but a little bit different. So everything is a little bit more automated. And really what you're doing is you're describing things like pods and load balancers and storage and so on in all of these YAML files. So it's a lot more declarative in style. So I won't be able to show you the PaaS and the ACI portion. Feel free to take a look at those yourself. Hopefully, it'll be just fine. I will go ahead and make that one update to the IaaS portion and make sure the Zulu works properly for you. So I don't have a whole lot of time left. I'm going to turn my camera back on and see if there's a little bit of Q&A that we can do and see if you have any questions. So let me turn my camera back on. And let me stop sharing for a moment. Okay, somebody had a suggestion for me. Sudo apt-get install Zulu JDK 8.11 JDK. I will try that. Thank you very much for that suggestion. All right, any other questions? We still have about 3 to 5 minutes, I would say. I would like to stop on time, but if you have any questions, please let me know. No questions at all? All right, well, I appreciate your time. I hope this was a worthwhile presentation. Let me know if you have any questions. I'm easy enough to reach either on Twitter or my email or what have you. So anyway, I thank you for attending the session, and I hope you enjoyed the rest of the presentation. That's really it all for me at this point.
So yeah, thank you, Reza. And hope to see you next year in Java2Days.
your life.
Hello, everyone. So welcome to this session. It's going to be about lab demos with Eclipse J. Okay, so before we start, my name is Santan. I'm a software engineer at Red Hat, and I've been contributing to the Eclipse J project for maybe 6 years now. And yes, I'm also enjoying speaking at various events, like of course Java2Days, but also Java1, EclipseCon, and so on. And during my free time, I'm leading the Paris Java user group, and I'm also brewing my own beer in my kitchen. So if you go through Paris, just let me know, and maybe we can share a beer together. You can follow me in Twitter with the handle @_Unix_. And also, yeah, I'm tweeting from time to time short videos about great features that we have in Che with the hashtag #Chejoy, so you can already have a look. But after the talk, of course. Okay, so wait. I have just received an email from Sébastien Blanc. It's one of my colleagues. So let's have a look to what he's saying. So he's saying that, yes, he's on PTO. So yeah. And his manager is asking him to work on the Post-it app. Yes, I know this Post-it app. I've been working on that few times ago, but it's been a long time. The customer would like to have the title in uppercase for tomorrow. Damn it. And I wish you could help me on that. Here the source code. Come on. Okay, let's have a look. Maybe we can help him. How do I exit that? Yes. So the Post-it app, as far as I remember, it's available in our OpenShift cluster. So, and it is composed of 3 components. So there is a Mongo database, Quarkus backend, and a Node frontend. Yeah. So, and how? Yeah. Maybe you're wondering how it looks like. So I can open it from there. Yes. Yeah. So it looks like that. So it's a very great application. So you can enter some items like hello, Java2Days. Yeah. And when I hit submit, it will store the data in the Mongo database, going through a Quarkus backend. So, yeah, very great. And as I understand what it is, so it's, the mail is here. So it is asking to set the title in uppercase. So I guess we want to set that in uppercase somehow. I'm not sure how I'm gonna do because I don't have anything installed on my laptop, so let me do like let's see if I can if I have a Mongo database first. No, I don't have anything. Maybe something like that. Yum search Mongo. Oh, okay. I think NoSQL. That's gonna be tricky. So wait a minute. Let's have a look to the source code. So in GitHub. Oh, what's that? It's a dev file.yaml. Oh, I think I heard about that. It's I remember now. It is a file that would help you to generate new workspaces in Eclipse J. And what I can just do is take my repo and add a chair, the chair host, and calling the factory URLs, and that would generate a new workspace. I can even try by clicking on that button. Let's give a try. Let's have a look. So, so this is a Chi instance that we have in our office, or our data center. It's running inside Kubernetes, so I can have a look to the dashboard where it is loading. I can increase the font. So let me know if you see if I need to increase the font in the chat. Let me know if you are there, if you can hear me, because I feel like lonely in this room. Yeah, so this is the Kipche, and yeah, so it is starting the workspace. So when I click on the button, and yeah, if you want to start a sample project, you can go to get it started on your Chi instance. On it is installed, of course, and start any project in there. Or you can just provide. So as I did, but a bit differently. If I provide the Git URL to Che, that would automatically generate what we call the dev file. So what is that dev file? It is everything that is needed to generate a new workspace that would contain not only the source code, so the source code is here, but also the plugins. So I can go down. So here there is a bunch of plugins. Well, let's have a look in GitHub because it's a bit more clear. So there is the plugins here. So that these are actually Visual Studio Code plugins that runs inside sidecar containers. So there's a bunch of them. So one is Quarkus Java 11. And there's also the TypeScript one, and so on. What we can also find in that dev file is the runtime container. So the things that I wanted to install locally on my machine. So for instance, Mongo, I don't want to install that on my machine. Okay, so there is a simple way to declare that to the dev file, and that will start the Mongo database. And that will start the Mongo database. So using the container image. So here we are using a CentOS, the CentOS one. Okay, so it has started. I will go through the dev file. So when it is continuing to load, there is also some containers to run my backend. So that's, you can see that it is using here UBI minimal, which is a very tiny container to run Quarkus native application. There is what we call a node frontend image, which is a basic node image. And it will also provide other containers to build your application. So this one is a special one because it will allow me to either start the Quarkus backend in dev mode or to build the application in natively with GraphVM. So this image contains GraphVM, so I don't have anything. So there's also other containers here.
You can increase your font size a bit.
Yes, of course. Like here, Git and so on. So yes, so let's have a look to the generated workspace. So it has been generated. It's a brand new one, and so I've configured this workspace with a plugin called Didact that will provide to the new people who are using this, who would generate this workspace and use it, it will provide a guide that would help the user to understand a bit what he can do. And for instance, there is some guide saying that there is a Mongo database and that you can run this predefined task to show the post item that is in the database. And that would execute a command and it shows an empty array. So what did just happen? So there is in the right side there is a panel called My Workspace View, and that shows all the containers that we have defined in our dev file and that has been generated. So we can find, for instance, the Mongo database, and you see this command. So I haven't show you there, but these are the commands that I have in the dev file as well. So I can say, okay, let's find the one that we just started. So it's show post. So it's the last one, and we say, okay, run show post in the Mongo container, and run this command. And so I don't have to remember how to run this command. So so this is running a Mongo database in a container, the right container, the one that we would use in production. So probably that one, but in a new workspace which is isolated and generated on demand. And I can, so the next step would be to start the Quarkus, because what we want to do, if I remember the email from Sedi, we want to set the title in uppercase. But before doing that, maybe we want to start the application to see if it's really working or not. I can first open the file. So this is the post.java. So this is a file where we're going to do our modification. So probably here. Sorry. But let's start the application and see how it looks like, and then we're gonna do the modification as CP requested. So I'm gonna start. Yes, let's start it here. So start dev mode Quarkus backend. So that's gonna run the command to start the dev mode. So the dev mode in Quarkus is a way to start your application with the debug mode and the live reload. And once it's started, I can open it in preview. And this is the default page. And there is an iframe here to show the entry point, the post entry point. So this is a REST API. Okay. And as you remember, we had it is empty. So if you want to properly test our application, we want to start the front end as well. So there is a command. Well, yeah, I can start it from here as well. So start React.js frontend in dev mode. So I can do it from here, and that will start the React.js in dev mode. So it's gonna compile. And here we are. We have our application. So this is all these things are running inside my workspace. So the Mongo, the Quarkus backend in dev mode in that container, and the Node application in that container as well. Okay, and I can start to add some items like hello hello, Sophia. Okay, it works. I can even check if I have the items in my database. So here it is. Good, good, good. So I could reproduce. I could start the application in dev mode and without having to install anything on my computer, on my laptop. So no Mongo database, no Quarkus Java stuff. So if I open terminal, I don't even have Maven installed, and start coding in Java in a second. So what we want to do here is set the title here in uppercase. So what I'm gonna do is use the IntelliSense of Eclipse that is actually using the Visual Studio Code, the Java extension for Visual Studio Code, but we run that in Che because we have made things compatible with VS Code extensions. So you could say uppercase, for instance, okay, and just hit refresh, and here we are. It's in uppercase. Okay, good. I think, yeah, something else you can also do and pre-configure in the dev file for your user is to start the debug mode. So you can either click here or go to or press F5 or click here, run, start debugging, or I would just click here because it's I like the guide. It's quite new. I did it this morning, by the way. Yeah, start the debugging. Oh, I forgot to set a breakpoint here. Yeah, so normally if I refresh it, it should stop at the breakpoint. I can even change the local variable here. Yeah, Sophia, Paris, and continue, and there, hello Paris, there we are. Okay, so what else? Oh, so I think we yes, of course there is the Git. Oops, close that. There's this Git panel, and you can diff, you can push. I have not included the pull request panel, but you can include the plugin to make a pull request as well. And what else? There is yeah, you can. Yes, if you don't want to, if you don't feel like installing GraalVM to perform your application, most of the people, what they do is that they set up a CI environment to do that. But with Che, we're already in the cloud, so we can take advantage of the resources that we have in the cloud and do it in our workspace that is running in the cloud. And I can do run Quarkus, the native build of Quarkus. I won't do that here because it takes some time. I've done that previously in in that cluster. So this is another Che cluster, another workspace. And you see, it took like yes, 40 minutes. But it is important to be able to do that in development mode, because sometimes you have some difference when you want to run your application in native mode. There's some difference that you won't find out if you just run the Quarkus dev mode, so the JVM version. If I click here, starts, it starts in very quickly and it works. So that the Quarkus native build. That's I have done. So if you have a look at the log, you see it's been pretty fast in running that. What is the usually say it started in a few seconds, so it's not written. Anyway, it was very quick, but it took a long time to compile. So here, unfortunately, it depends on the resources you have in your. So this cluster is not that good, that nice. And yeah, so that's pretty it for the first demo. So I don't know how much time I have. So, but I can make a second demo if you like. And if, of course, if you have any questions, don't hesitate. So no questions. And I can show you a few slides, maybe. So yes, before starting the demo, just a few slides, and then I will play with Scratch. I don't know if you know Scratch, maybe not. Okay, so just to recap, what is Eclipse? So Eclipse is so there's three important things. The first thing is that your workspace will run inside Kubernetes pods, and it will try to replicate what you have in production in Kubernetes. It means that if you run something in Che, there's much chance that more chance that that your application will run in the same condition that in production. And as you can see, once you have your dev file and your project, your dev file setup, it's very easy to start, and anybody can run the project and start to contribute to that project. The second thing is that it will protect your code. I mean, we are a lot here now at the moment working from home, and you don't know how many things that may be insecure in your local network. So I heard some people using IPTV to watch soccer. I don't do that, but some does, and you don't know what there is in there and what's in your networks. It is like a Trojan horse, and the fact that we run Che in your data center, it will avoid you to download the source codes and all the configuration files locally in your computer, in your laptop, and security code and run your application in the cloud. And as you can see, the look and feel is very close to Visual Studio Code. The third thing is the developer environment as code. So what I call developer environment as code. It's taking inspiration from the infrastructure as code, but we are adding things like the project to clone or the commands to the predefined commands, or the container to build your application and the containers to run your application, and that can generate new workspace on demand and isolated. So it means that, for instance, if I go back to my workspace and say I have pushed this the changes. If I want to switch to another workspace, as long as I don't remove it, I can do it. So yes, so I can switch up. I won't do that because it's let's do that and we'll see. So I can, for instance, start this workspace and all the things, all the project, the configuration will be isolated. So it means that I can come back here and be in the same states. So these are isolated. I can have multiple workspace of the same from the same dev file. So for instance, if I work on a branch, I don't want to push it or I'm waiting for reviews, I can start to work on a new issue without dealing with Git stash and so on. Okay. And yeah, so the web ID, it's a web-based ID. So there is by default we're using this user interface, which is Eclipse TIA, and Eclipse TIA is a project that is implementing an ID, a web ID. And we're using that, and we put that inside a pod, a Kubernetes pod, and this is Eclipse. So Che is not only based on TIA, so you could configure Che to run, for instance, any other web-based IDE. So we have, if you have a look to CodeWord Workspaces, which is the Red Hat projects behind Eclipse Che, that use Eclipse Che as an upstream project. So CodeWord Workspaces is the project, so that's it's Eclipse Che but maintained by Red Hat and supported by Red Hat. You will find, if you use CodeWord Workspaces, the ability to run another editor, not the TIA based ID, but the IntelliJ ID. And of course, you can use any other web-based ID. So this is about configuration. So this is one of the capabilities that we have in Che. And so the main idea is to say, okay, we have our application that runs in a pod, for instance, and what we're going to do is add tools as sidecar containers, and that would so it could be some tools as containers, just containers. So as, for instance, the Git containers that I've shown to you, or the build containers, or it could be the editor. So in our case, it's TIA, and it could be also language server containers, so and plugins. So for instance, the Java IntelliSense has its own containers, and that would run inside a pod in Kubernetes. So as you see, when you're coding in Che, you would be very close to your production environment, because the containers will run in Kubernetes. So it will be not that many differences with what you have in production. So the dev file looks like that. If you want to start from Che, a dev file. So this is the other project that I've cloned, I've restarted. So and this is my own project. So we're using Che to code in Che, and this is one of the dev files. Okay. Let's go back to. I'm gonna stop that one as well. Let's go back to here. So yes, if you want to start, if you have a Che instance working, you can give a try with one of the samples. So for instance, if I start Quarkus, I won't start it because I wanted to show something else. So you can start like that. I will stop it. But you can also have look at the custom workspace here. It is a workspace, a way to customize the workspace. So you can take one of the templates. So the one I started just previously was the Quarkus REST API. So you click here, and then you can customize it. So you can add your plugins. For instance, PHP. So that would be Vue just to do code extension. That sometimes we run this extension in a sidecar container. So for instance, for the Java extension, we run a container which has Java installed. So you won't have to install Java on your machine. Yes, on the main container. So it looks like a Docker Compose file, if you know Docker Compose, but we add more elements like the project sequence and so on. So you can give a try like that, create a dev file, and then add that to your Git repo, like I did it. So here, you Git repo, and then you could start your application with the right URL. So this is an example of how you can do it. So you provide the URL, and that would generate. You provide the GitHub project, and that would generate the. It would have a look to the to the project itself, see if there's a dev file, and then pause the dev file and generate the project for you. Okay, so if I'm finished with the slide, I can maybe play. Oh yes, so how to test Che? So there is che.app.io. So this is I can click here. Yes, this is a free way to test Che. It's quite limited, so there is a very poor storage. And okay, so but it's gonna be replaced. We're going in a few months to replace that with something that we call a dev sandbox, and that would be much faster. So just if you are interested to try Che, just keep posted. Maybe following me in Twitter, and I will probably send a few tweets about the dev sandbox with Che. So this is the way to test it quickly. But you could also install Che in any of the public clouds. So you can, for instance, we have some documentation in the doc. Docs. No. Che docs. Yeah. So if you go to the Che documentation, so there is a section called installing Che, and installing Che in the cloud. So for instance, in Google Cloud, and I've actually done that. So there is. I can show you my Google Cloud instance. I'm using it from time to time. So, and it's cost me about 30 euros per month. So that can sound a lot. So 30 euros a month. But if you take in consideration that once you have the things running in the cloud, you won't have to buy a new laptop, because the more we're going, we need more resources, and with Che, then once you have that in the cloud, you only have to pay for what you are consuming. And to me, 30 euros a month, it's okay. I can run that with any cheap laptop, and I can run things like native compilation. There's no problem. Okay, so sorry. So different ways of installing Che. You can install locally, but to me, it doesn't really make sense. So you can try. It's free. With Minikube, for instance, it works. And of course, on-prem, I have to show you the easiest way to install Che is in OpenShift. So you go to Operator Hub. You're looking for Eclipse Che, So I have already installed that cluster, but then you click install and start a cluster, and here we go. So in a few clicks, you can have an architecture up and running. Okay, and you can also install Code Workspaces. So Code Workspaces is it's a version of Che that is maintained by Red Hat. So that is the one that is maintained by Red Hat. But it's quite the same. So the stack are quite different, but it's basically the same features. Okay, so let's make I don't know how much time I still have, but I can make a very fun demo.
Minutes.
Okay, so let's do it. So I don't know if you know Scratch. So Scratch, it's a kind of programming language that you can use for yes, to program an application by moving blocks. So for instance, here. So here, this is when I create a project. So you go to scratch.mit.edu, and then you create an account, and then you create a new project, and this is where you are landing. And you have this little cat here. This is the game board, and you can move. Some actions in here. So this is a source code, like for instance, move 10 steps. So if usually we use the green flag to start the cat. So as you can see, it doesn't do anything here because there is some other categories of blocks, and there is one which is called when the green flag is clicked. So there, when the green flag is clicked, move 10 steps. So I can move 10 steps. So it's actually moving 10 pixels. So that's why it's not moving so fast. I can have then a control here when we can have things like for each loops. So I can say repeat 10 step, move 10 step, and that will do it. Or I can do something like forever move 10 step, and that would move forever. So come back, little cats. You see, I can just click on stop. That will stop. Okay. You can make great projects. I can show you one of the projects I've done with my son. So he's 8 years old. It's called Course de Voiture Remix. It means a race car in French. Okay, it looks like that. So it's, as you can see, it's quite simple. So I have what we call the sprites. So it's the cars. And then I can click on the green flag. So I will make that full screen, click on start, and then use my keyboard to control the car. Okay, so this is Scratch. I can make a very simple application like that by just moving blocks. And what I did is, sorry, close that project. I started a project with one of my colleagues. It's called Kubernetes, Scratch Kubernetes. Okay. So obviously there is a dev file. So let me just let me just start that with the dev file. So I can go back to my instance. So not that one. Yes, that one. And I can do instead of that. Oops, sorry. I can do start this project. Yes, load this project. So it's loading it will load the project, the dev file, and then create an open. And it will take a few minutes, maybe a minute and a half usually. And I can show you yes, what's the purpose of this project. So so the goal of this project, I thought I had a screenshot of the I thought I had a screenshot of the. Oh yes, it's there maybe. Of the how we call it, the architecture. The architecture diagram. Okay, that's it's what? Something is wrong. Why? Don't know. Is it better like that? This is strange. Okay, so yeah, so there is so the goal of this project is to create new blocks, as you've seen in Scratch, that will interact with Kubernetes. So it would be, for instance, get namespace block to get the current namespace, or set namespace, or get pods that we have in the current namespace, and so on. So and then you will be able in Scratch to move the blocks, and maybe then create your own application, your cloud native application. That you could imagine that you could create something like the OpenShift console, but in Scratch. So replacing that, create that user interface, but in Scratch. Who knows? So to do that, there is a Quarkus backend that will use the Fabricate client to interact with Kubernetes. Okay, and that would expose the REST API. And so Scratch is actually a Node.js application, and it is composed of two things. So there is the GUI, which is the user interface that you have seen. And there is a Scratch VM, which is the engine that will take the blocks that is composing your application and run it. And so what you could do is have an extension in both of them that will make the REST calls to the Quarkus backend. And because this is quite a big challenge to set up all these things, we could do that in Chi. And so if I'm coming back to the generated workspace, we could clone the projects. Oops. There is this guide that will explain you everything. So, yes, that would tell you what to do. So I would start the free tasks. So I can also check if I'm connected on the OpenShift cluster. So I think I have the OpenShift plugin, so I can go into that container and do, for instance, OC projects, OC get pods, for instance. So yes, there is 3 pods here. Okay, can I create a new pod? Yeah, let's try to do that. No space left on device. Okay, let me clean up some projects. Delete and try again. Where is it? I'm lost. So install. Come on. Fresh. So first, install the required dependencies. All right. And yes, I was going to open the OpenShift console. and see. Yes, I would like to create a new pod. So I have to go to workloads, pods, and maybe I can create a new pod here. But let's just wait for the workspace to be started. So okay. Oh, why? Okay, so this is the demo effect. I don't know how it is. It should work, no. But I think I have run the demo too many times in this workspace. Okay. Okay. You know what? If you have any problems with that, you can let me see if I can start this pod. This is the pod to clean up the. Yes, I have to see the deployment config. So very sorry. It shouldn't be like that. It should work. But I would clean up manually the content. How much time do I still have?
2 minutes, but you can go a bit over that.
Okay, that's that wasn't expected. Thanks. Let's see if I can quickly clean up the content.
You can show when stuff breaks in the cloud.
Exactly, but that's a disk space issue. So it's not really some application that is breaking. No space left on the device.
Anyways,
yes. So I wanted to start a container that have access to my volume, the whole volume tank, because I think that's maybe it wasn't well cleaned up. So this is supposed to be the container that is doing that, but I'm not sure why it is not starting as well. Neither. So the demo gods are not with me, but what I can try to do, I can try to run that on my GCP instance. So wait a minute. Where's my GCP instance? Here. But then I won't have time to play the whole demo. No worries. I would, just workspace, add the workspace. Then I could provide just my the URL and create. So it's using the dev file it would generate. It's in GCP, so Google Cloud Platform. It's in a plain Kubernetes, and with the dev file it would run exactly the same configuration, so I don't have to see. So even if I lose my laptop somehow, I will still be able to code my application. And yeah, so let me have a look if here the cleanup container has been started. It is not starting. I'm not sure why. Oh, interesting. Okay. I think it should be okay now. You know why? I have. Okay, let's restart that. Because yes, so there is some problem with one of the pods that are removing the data. So, but I have a full the same container is running in two different instances in the cloud. Yes, but if you want to see it working, sorry, if it doesn't work and if you have to shut down, yes, I gave the same demo at EclipseCon, so it is in YouTube, and yeah, so.
Best container is a video containing it.
Yeah, but that's not fun. Yeah, there's a video here, so I can show you. YouTube Scratch, coding Kubernetes Scratch with. So I would close that, but yeah. So yeah, so this is here. So if I can share the link in the chat, and you can have a look. And yeah, so let's wait a bit. Usually it's working just after that the talks is ending. Ah. Okay. So I have 3 workspaces here. Okay. Okay. Okay, so this is, I can remove that one. So yes, this is a pod that will mount the whole volume where I have all the file system for all the workspace. So, and sometimes in this instance, so this is we have the workspace are not clean up properly for some reason, and so I have to do it manually. And I'm running out of space when I want to make a demo. And yeah, so not sure why everything is slow. So any questions so far? Okay, so there is one question. So this Scratch Kubernetes sounds a very cool idea. Okay, can you please ping me the GitHub URL? Yes, the GitHub URL. I can paste the URL here. And any other questions?
It would be fun if this IDE shows you how much money you're spending in the cloud when you run the tests.
You could do that. So it's open source and contribution are welcome. No, yes, we're currently working on a monitoring plugin. But yes, so extensions are basically Visual Studio Code extension, and then we have APIs to talk to Kubernetes, for instance. You could do that. So if you, so yes, so you could like, and then it depends on how much it costs. So it's of course it's changing. It is changing after depending on the cloud provider. So let's be crazy. Google, no, Kubernetes. What is my to open that. But if usually the cloud provider provides you nice, yes, it's gonna be quite. So yeah, so if you go to so sorry, it's in French, but if you go to bills or invoices, there is a part where most of the cloud provider that provide that, so you can see how much it costs your resources and kind of analyze. So this is my Che workspace that this is running. So and you can see that for instance it cost me yes, in the last month. So I stopped that instance during the weekend and during the night, but otherwise it cost me, yes, 35 euros. And then we're working on an extension in Che to have metrics on the container on the workspace itself. So you could maybe see if there is how much you pay for a specific a test, for instance, maybe.
I meant it mostly as a joke. But you're right that with plugins you can go pretty far. It's pretty amazing, this tool.
Let's see if, oh yeah, so So that's the problem of Che. So yes, there is a problem. So it's not a problem of Che. It's the fact that on GCP I don't have enough resources, I guess. So because I don't want to pay that much, I'm just having small nodes to run Che, and I guess it doesn't start well. I don't know why this one has not started. So this is a big failure for me tonight, but it happens. So the debuggers were not with me, but it would work just after the talk. So I guess we can close the session. What do you think?
Yes, thank you very much for this talk, Son. It was really amazing.
Yes, and hope. So the first part was working, but the second part, when I reached the disk space issue, it just got crazy. So anyway, it will. You have the videos, and it will work next time. Maybe next year.
Yeah, just make sure to implement disk size checking in Che, so this won't happen on your next talk.
Yes, I'm counting on you to do that. It's open source.
Okay, I can take a look. Thank you very much, Son.
Yes, thank you very much. Yes, take care. Bye.
Bye. Size checking in Che, so this won't happen on your next talk.
Yes, I'm counting on you to do that. It's open source.
Okay, I can take a look. Thank you very much, Son.
Yes, thank you very much. Yes, take care. Bye.
Bye. Size checking in Che, so this won't happen on your next talk.
Yes, I'm counting on you to do that. It's open source.
Okay, I can take a look. Thank you very much, Son.
Yes, thank you very much. Yes, take care. Bye.
Bye. Size checking in Che, so this won't happen on your next talk.
Yes, I'm counting on you to do that. It's open source.
Okay, I can take a look. Thank you very much, Son.
Yes, thank you very much. Yes, take care. Bye.
Bye. You can go.
Hi. So welcome to our session, R and Jakarta MVC. So little overview. First we do an introduction. I'll also introduce ourselves. Then I will cover the history of OpenDDR and similar approaches. Then I will briefly touch the two most common MVC frameworks, which are Spring and the specialty called Spring Mobile, which is an extension. as well as Jakarta MVC, where we also created an extension and wrapper around the OpenDDR framework. And Ivar is going to show that since he's one of the project leads of the Jakarta MVC project. So first, a little bit about myself. I'm a consultant and coach working for various from embedded to backend and enterprise. Right now, I'm a little more on the RCP side again. I'm an open source evangelist and contributor to several projects. I'm a maintenance lead of the units of measurement GSR, and I also took over as one of the maintenance leads of the Java Money GSR. And I'm also the committer representative in the Jakarta EE spec committee.
Okay, and then it's me then. I'm Ivar Grimstad. I'm the Jakarta EE developer advocate at Eclipse Foundation. I'm a jug leader here in Malmö, and I'm a Java champion. And as Werner said, I'm one of the project leads in the Jakarta MVC specification, where we've been leading it through the JCP as JSR 371, and released a version there in the beginning of this year, actually. And later this year, we've actually released 2 versions. So yesterday, we released the version 2.0 of Jakarta MVC. So that's what we're going to use in this demo as well. So it's very fresh and new version. So back to you, Werner.
Yeah. So actually, OpenDDR also, I think, had the world premiere at what was then the Java2Days conference in 2011. So I found a little rakia here, so it's a bit of celebrating that anniversary. And it's also actually these days and this week, literally the anniversary when OpenDDR came back under the current domain after Apache device map was archived, and we'll come to that in the history. So there are so many devices nowadays and different attributes, like you got smartphones, smart watches, foldable devices, and all sorts of new devices with different attributes. So it's very hard to cope. What is a DDR? Okay, I guess especially in Bulgaria, you probably also still remember that time. It's actually an acronym that's not the Trump wall. It's also an acronym for a memory format, which I believe is still in use.
Do you remember what the acronym is for the memory?
You mean what the 3 letters stood for, DDR? Yeah. I'm not exactly sure. I believe R must be RAM, but whether D stands for direct or something, I can't exactly remember. Do you know?
No, I can't remember either, but I remember DDR3. Yeah.
Yeah. So OpenDDR is currently the last surviving open source project that implements the device definition repository standard. That's a W3C spec that was finalized in 2008. So it's also been a while, and it's now pretty stable. That's why OpenDDR is different in the sense that it's open source and free to use, both for commercial and non-commercial applications. And even though over the years, some of the power users have now shifted a little bit to something like responsive CSS design, and some of them may no longer need vast device repository. There have been several power users. Yeah, we talked about the weather. Weather.com was using it for a very long time. I'm not sure if they still are now that they are part of IBM, but earlier they were using this in their various applications. So a little bit about the history. There was an open source project called Worthful until approximately 2011, and in summer 2011, some of the project leads actually decided they want to make a lot of money with it, and they decided to take the former open source project and turn it into a closed source project, which it now still is. So members of the community and contributors who felt sad, and some of them even felt betrayed for their contributions because their efforts have been taken away, and somebody else is now selling them, and they can no longer access it, at least not unless they pay for it. So some of those former contributors gathered and helped us create the OpenDDR project in the second half of 2011. So that was also when I first presented it at Java2Days in 2011. And the Apache committers and some Apache projects that are also dealing with device recognition noticed this effort. And so OpenDDR was one of the founding members of the Apache project called DeviceMap in the incubator. It also graduated about 2 to 3 years later. But unfortunately, the momentum that OpenDDR had before that, when almost every month a new release of the device data was released, in Apache, the momentum was not quite so massive, and the number of committers didn't grow. And some of the sub-projects for .NET and others were almost stopped, and people could no longer contribute. So at some point, when the activity became very low, in January 2017, DeviceMap was retired after the last PMC members decided that it was not worth, and there were too few of them who were really active. And since in Apache there's a process where things have to be approved by a minimum number of 2 or 3 or more, having fewer than that made it very complicated and almost impossible to find decisions. So that's why it was retired. But that was not the end, because in late 2017, I think it was actually in late 2016, so more or less an overlap before it retired. This domain, openddr.mobi, was registered, and we contributed that as an initial contribution. And after some time, in the middle of 2018, there was actually a record spike, sometimes even above the 500,000 downloads per year. So, of course, some projects like Spring and Spring Boot probably have millions of downloads per year, but I guess there are not so many open source projects other than that who can say that they are downloaded hundreds of thousands of times per year or 10,000 of times each month. So it was solid 6-digit also in 2019. This year, because some of the main power users moved to something else, like using CSS. So there have been a bit fewer downloads, but they're still solid, and it should be somewhere in the 5-digit region by the end of this year. And as long as it continues like that, it has never been that successful when it comes to downloads, while it was DeviceMap at Apache. There we had sometimes no more than triple digits each year. So what are the other solutions. These are probably the only remaining ones aside from OpenDDR. The two bottom ones, I believe, are more or less dead or disappeared after several mergers and acquisitions. So I don't think these still exist. If they do, then they're only available under a commercial license in closed source. The same is for Wurfel, which after August 2011 is only available through a closed source license. Few bits and pieces may be available in a license where it's that special license that I think MongoDB also uses, which you can see the code, but you're not allowed to use it in a service unless you pay for it. So it's not completely open source, and most of the rest is actually closed source. The same for Device Atlas, and 51 Degree Mobi is probably an interesting example because they do have a few free bits and pieces. So it's a bit like freeware with commercial extensions that are then in a pro edition that you have to pay for. So they have some free parts, and they are also, I believe, the only one that supports Java and .NET. And most of them also support JavaScript nowadays on Node.js. So other than OpenDDR, I guess only 51 Degrees Mobi is the only other vendor or provider that has some part of transparent and open approaches and libraries, while the others are pretty much closed source. So OpenDDR is based on open standards. The repository is compliant with the W3C DDR standard. It's been under Apache license pretty much ever since. So even before we went to Apache, it was Apache license, which also made it easier to go back and stay with the license. It's also, by the way, the same license that Jakarta MVC uses. So here it also blends in well. OpenDDR has three major aspects of a device. So based on the user agent, it extracts information about the physical device, the operating system, and the web browser. It has a so-called confidence level, which is a bit like a threshold of precision, where you can decide if you want a very high confidence, then you can be more precise. If you want a lower level of confidence, then sometimes you may only recognize a device as being Android general purpose or something like that. But that means it will be faster and it takes less memory that way.
So we have a question here. What kind of data exactly is it for each device? So what kind of data can you get from OpenDDR?
It's the screen size, and for some newer devices that we added later on, it also contains things like how much RAM does a particular phone have, and how many memory slots, does it have memory at all? How big is the storage as opposed to the internal memory? So there are several aspects. The screen resolution is the most basic one, and a few others, including the version and the vendor of the browser. So these are the core OpenDDR properties that have been defined by the W3C ever since. And later we added some custom attributes in addition to that. So for every device, you will at least see the most basic ones. And for some devices where it has been maintained, you can also see more. And with version 2 of the device data, we also try to make that a little more flexible by adding some complex data in a tree where you can have multiple properties that are nested. At the moment, the classifier doesn't support that yet, and it's also something that is not really backward compatible, so it may not work with the classic W3C DDR client, but we want to add a little more information, especially things like foldable. And if you have a device that can be changed from a tablet to a phone, or from a tablet to a desktop, the traditional flags that say is desktop, is mobile, is Nokia so and so, those properties have been very legacy and historic. That's why we try to decommission them by adding a few more that are a little more appropriate nowadays. For example, for smartwatches and similar devices. It also allows patching, including you may even add some of your own custom properties in that patch that are not part of the core specification and vocabulary. So that means you can take the existing OpenDDR data and add a patch, and then patch it by adding your own devices if you want to work in a kind of closed environment, and for some reason you don't want to contribute it back to the actual project. Of course, you're very much welcome to do so, and we are happy about contributions from the community. But should you not be able to do that for some reason, then you can use a patch, and you can drop in that patch, and it will just add on top of the core device data. This is also a little historic because obviously we were only able to compare OpenDDR and Wurfel at the time when both were still open source, or until the point where Wurfel was still open source. So that's a little bit historic. So it doesn't say anything about the current commercial Wurfel libraries and device data that are out there right now, or they may be optimized if you pay for it. So that's why we also skipped the diagrams, but back then when we compared them, OpenDDR usually had an advantage, because when you reduce the level of confidence to the bare necessity, then you would usually have a very low footprint, and especially in the cloud, if you have to pay for the memory, that can be an advantage. So this is the way that the original W3C DDR simple API and its implementation can be customized and retrieved. So it's a bit like lookups in J2EE or Java EE almost up to 20 years ago. But then again, of course, this was defined until 2008. So they started doing this maybe almost in 2000 or 2003, and then it took them approximately up to 5 years to finalize it. So a lot of this is actually based originally on definitions that you would probably have seen in J2EE while it was still called J2EE. And that also made it a lot harder to retrieve the device data from a different distributed location, because all of this has to be in the same file system. So this is why the new Java client, or so-called classifier, was enhanced. Most of this was actually done while it was at Apache Device Map, and the data can be loaded either from a URL that could be on the other end of the world, or you can also load it directly from our OpenDDR repositories that are either located on the website or on bin tray in the DDR. Or you can use a jar file, or you can also use a exploded file system. So the last one would be more or less comparable to how it was done in the W3C DDR client. So the last way of retrieving it from a folder is very similar and would also be compatible to the DDR Lite client, while the others make you a little more flexible because you can either drop it as a jar, or you could even retrieve it dynamically from a different location. I'm not going to show this here this time, but again mention that OpenDDR is also available for .NET. Yeah, this was taken, I think, 1 or 2 years ago, so that's actually the station European Union in Sofia, Metro. So as a summary, OpenDDR is open and free. It's based on W3C standards. So it's also similar to other specs like servlets or WebSockets that also embrace W3C standards. You can easily migrate from the traditional W3C simple API to the new one because the underlying repository is the same. So let's take a little look at the MVC frameworks. So Spring Mobile has been around for quite a while, and it supports, on top of Spring MVC, a similar device detection, although in the most basic setup that I'm also going to show, it's more or less a parser for the user agent, so it doesn't need any external references, but you can also enrich it with an underlying device repository, and I believe there are some extensions for 51 degrees mobile, and at least before it was changed to closed source, I know that Spring Mobile supported Wurfel, but when it was moved into closed source, I believe they discontinued that and they no longer support it. So you may find closed source extensions and libraries and plugins for Wurfel or other competitors, but open source, I believe, out of the box, it's mostly simple parsing the user agent. So this is one example. So there's a similar POJO and model object to what OpenDDR has. It's called the device. But here the device only has a few attributes like is mobile, is tablet, or is desktop. And most of the other properties are pretty much hidden and automatically derived. Here's another feature called site preference. And a device-aware view resolution. Spring Mobile has not been very active lately, and I'm not sure if it's still actively maintained. It has like a version, I'm not sure which, but it has a snapshot, but that snapshot has been in snapshot for, I think, way over 5 years. So and it also has not been upgraded to the most recent Spring framework version. So if you want to use it without modifying it yourself, you're stuck with a slightly older Spring version, which is why we actually went and embraced Jakarta MVC, where, as you will see now, we literally just adopted to the most recent Jakarta MVC version that has been released only a few days ago, version 2. So here, you're definitely state of the art. While when you use Spring Mobile as it is and you don't customize or patch it, you may be stuck with a slightly older version of Spring. And it's also not certain whether, I guess there are so many Spring projects now that this is definitely similar to Spring Social. It's probably one that may be a little more exotic, and if it was under Eclipse or Apache, it would probably be deprecated or archived by now. So let's look at some code. First, this is the Spring mobile demo showing the REST controller and the request mapping, and then decision making based on whether is normal, is the desktop basically, is mobile, or is tablet. Eva will show you a few more aspects, but just as a simple. Can you hear me and see me? Because
Yeah.
I just got some strange pop-up saying the session has finished.
Okay, yeah, we still see you and hear
Okay.
you.
Yeah. So I will hand over in a moment to Eva to show you a little more about the underlying details, but just as a simple comparison, here's the classify controller on top of Jakarta MVC.
Font size a bit.
Okay. Is that enough or bigger? Okay. So here is the Spring mobile approach on top of Spring MVC. And here with slightly different annotations, but also annotation based, and in a relatively comparable way, you got the same on top of Jakarta MVC. Let's also show this in action. So here I already started it, and it shows on the desktop the device is a normal device. Eva will show you the Jakarta MVC demo on his machine in a moment, but for everyone who wants to try it out yourself instead of building it, you can visit the openddr.mobi page, and here if you click on try it out, you see a few code snippets for both the classifier and the traditional W3C DDR. And for the classifier, you here have 3 different examples. So this is not using Spring Mobile, but you can also use Spring MVC together with the classifier. That's a plain servlet example and a Jakarta MVC example. So then over to you.
Okay, thank you. And there you go. So I did play around with this application a little this morning, and I figured out that I'd update it to the latest version of MVC. And as you can see in my Maven project, I'm using the MVC 2.0, which is the latest version, and we released it this weekend. What's also notable here is that we're using the Craso Jersey version for which is version 2.0 as well, since we are running on Glassfish, and Glassfish has a Jakarta REST implementation that is called Jersey. If I was to run it on Wildfly, which is also possible, then I would use another dependency here, which is the REST-DC dependency, as well as for OpenLiberty, also a switch to REST-DC now.
Yeah, so there's a little caveat. I believe we already planned some switches and profiles in the POM, although at least recently I have not used any of it. But if you want to deploy it with Wildfly or OpenLiberty, then you would have to build it a little different, because if you build this exactly the same way and you deploy it to Wildfly, then I think it actually runs, but it won't work to a certain point. So you cannot really call the API.
Exactly. So I haven't played with the profiles either, but there is I think there is a JBoss profile here, and you can see the JBoss profile actually brings in the crosshair dependency for SDC. So it should work if you just build it with the JBoss profile. So let's look a little bit on the code for MVC. And as I said, it has been moved to the Jakarta namespace. So you can see we're using the Jakarta namespace for both, or this is actually not anything with related to MVC at all, because MVC builds on top of Jakarta REST. So it's just a simple configuration where we set the path of the application, and it's a Jakarta REST application. And our controller here is, as Werner showed, it's using the Jakarta REST at path annotation. And the only thing that kind of makes this a MVC controller is this at controller annotation, which comes from the MVC API. And the at controller here actually makes all resource methods on this class a controller. So it's not actually the class itself that is a controller, but you have one controller here for the actual classifier request. And we have one controller here for the result. We could put this in different classes or have them in the same. That's just as good. And the controller is request scoped, so it's using CDI scoped so it's initialized per request. And we inject this classified service here, which is the only thing that actually communicates with the OpenDDR. And I've chosen here to make this application scope. So what this one does is to do a lookup to load all the device information. And you don't want to do this every request, because that would slow your system down. So you do once in a while, whether application scoped or session scoped or some other scope or some timing is good for you. That depends on the use case. But in this case, I just did it for application scopes. So it will, when the application loads, it will load all the device information. And then it has some helper methods to figure out if it's a tablet or not. And then I've created a device info class, and it's just a dumb Java object. It just has whether it's a tablet or a mobile. And here you can see I'm using an interesting scope. And this is a scope that comes with, it's a custom scope for MVC, which is a redirect scope. So it will keep its values through one redirect and then be emptied again. So in my controller here, when I do the get request here first, I will use the classifier to figure out what kind of device this is. And then I will redirect this one to the result controller, which will use the device information to choose which view to display. So it's a very simple application. And the views will display slightly different information, whether it's a mobile tablet or a regular. So let's it's running here. So let's just open my browser and see this application is running here. So if I click on the classify request, you should see in the log here that it's doing some loading here. So somewhere it should say that it's doing the initializing the devices. Here you can see it's initializing, and it's loaded 2,531 devices. And this is something you would do in when the application starts. And you can see here it says the redirect works. So and the redirect works comes from the redirect JSP page. If I wanted to change which device I'm running here, so I'll just use the developer tools in Chrome to simulate that I'm using a Galaxy S5 here. I'll just beef up this a little. So Okay, so you can see I'm running a Galaxy S5, and I'm clicking the try it now, and I'm clicking this link, and I hope that you can see somewhere down here that it says redirect to mobile works. I don't wonder why zooming didn't
I think
work.
the tab also says mobile. So
Sorry,
the title on the tab says mobile.
it says redirect to mobile works.
Everything else.
Yeah, and if I switch this to, for example, an iPad, and try it again, it just say redirect to tablet, and it says tablet up here as well. So you can see it works whether you're to detect which device you're running on, and here is it. It's again with a computer. So that was about what I had planned to show. So I'll switch back to you, Werner. And of course, all of this was running on Glassfish 6, which implements Jakarta E9. So we have Jakarta MVC 2.0 on Jakarta EE9 running on Glassfish 6 and using OpenDDR. So you can stay on the newest and best technology out there.
So at the moment, the demo is deliberately kept relatively simple, so it mimics more or less what this Spring Mobile demo does. But hopefully in a future version, we actually should also be able to show some of the actual device properties that you see here in the existing Spring application and in the servlet application, because there the device is also placed as an attribute into the HTTP request and or servlet request, or the equivalent in Spring, and then retrieved so that the result page not only shows that it's successful or it's a mobile device or a tablet, but it shows a JSON dump representation of that particular device. So here you actually see most of these properties, at least the most basic ones, including some of the historic ones like Nokia series, which may not be too useful anymore, but they are part of the traditional DDR scope. And then you would have others like the browser version.
So we have a question here, a question about the redirect scope, and the redirect scope in MVC is it stays alive over a redirect. So you can use it when you implement the typical post redirect get pattern. That means that you post something to a form, and this form sends a redirect back to your browser, so your browser goes to a different page to display the results. And this is to prevent the double form submission things that you get if you redirect to the same page. So that's where you would use redirect scope. It's kind of specialized for this. In Spring, I think the same thing is called flow scope, but I'm not exactly sure, but I think so.
Yeah, so unless there are other questions, you can definitely visit all the different resources and links and sites. On top, you have the main OpenDDR website that also points you to all the live demos that you can run directly on your mobile device. Then the GitHub organization that hosts everything, including the examples. There's a mailing list on Google Group. So we use Google Groups like, for example, Eclipse Microprofile also does. The entry page to the Jakarta MVC specification. And on the bottom, if you are curious to compare or even want to use it, or maybe you want to contribute to it, there's Spring Mobile as a comparison. So yeah, if any other questions come to your mind later, then please join the Google group list or the mailing lists, including the Eclipse mailing list for Jakarta MVC if you have particular questions about Jakarta MVC. So if there are no other questions, then thank you very much.
Thank you, Ivar and Werner, for the great talk. And hopefully see you next year in the conference in live.
Yeah, I will also hope so, because then I can also probably stock on the Rakia, and depending on if we have some more news, next year will literally be the 10th anniversary of the OpenDDR project. So, but yeah, we also have other things to share and talk about, and hopefully we can probably do that again.
Maybe we can celebrate OpenDDR 10 years on Jakarta EE10.
Mm-hmm. Yes, that's definitely something that we should be looking forward a year from now to see the improvements and some of the new specs. I guess including MVC may even be part of the platform by then.
Thank you guys, and thanks for all our viewers. Session
Thank
for
you
today.
very
much. Okay, then thanks. Enjoy the rest of the week tomorrow, and hope to see you again soon, also in person.
Session
Thank
for
you very
today.
much.